how do you run Python? There are many ways to actually run Python code. In this lecture, we will only focus on running Python code in Jupyter Notebook. To begin, we are going to install a Python with the free Anaconda distribution. It's free and open source, so you don't need to pay anything here. And as I mentioned, this distribution includes Python as well as many other useful libraries, including Jupyter Notebook environment, which is where we'll do our coding in this course. Anaconda can also be easily installed on major operating systems like Windows, Mac OS, and even Linux. After installing Python, we will proceed to run Python Notebook briefly and finally explore other no-install options like Google Collaboration, which you do not need to pay anything or install anything. We are now going to download and install Anaconda distribution platform, which comes with Python 3.9. Anaconda is the most popular open source Python distribution platform in the world. Anaconda allows you to access open source software you need for your data related projects. It is user friendly and it's trusted. Anaconda includes many open source data science and machine learning tools like Jupyter Notebook, Spider, PowerShell, Jupyter Lab, IBM Watson, and so many other. To download, open your Google browser, as I've done, and type Anaconda distribution. You can search that and click on the first link that you see. Once it finishes loading, as you can see on the home page, we have a button for download, which comes with Python 3.9, a 64-bit graphical installer, and at the time of downloading this, it's 621 MB. You can go ahead and click on the download, and as you can see, it's currently downloading, and it's gonna take approximately 5 minutes, so you have to be very patient with this. It's still downloading. You're gonna give it time, and you're going to come back once the download is finished. It's about to finish installing, downloading, and as you can see, the downloading is finished. So what you do, you navigate to your downloads. You can open the downloads and right click on the and open. Once you open, it's gonna start installing process. So give it a bit of time to start. So as you can see, there's a welcome to Anaconda window that appears, and all you need to do here is click next. Read the license agreement. Once you finish reading, you click on I agree, and then it's recommended that you just choose just me if this is for personal use, but if it's in a work environment, it's recommended that you use all users, but for this one you require to have admin privileges. So in this case, make sure that you just click on just me and click on next, and now specify the destination folder where you want Anaconda 3 to be installed and click on next. And for the advanced options, just make sure that you check register Anaconda 3 as my Python 3.9, which should be the default one, and click on install. The installation process has started, and we'll come back once the installation process ends or completes. You can actually even click on details to see more details. We're gonna come back once that is complete. As you can see, the installation is complete. Setup is completed successfully. Next, you click on next. The next page shows some more information about Python and Jupyter in breeze. They say that working with Python and Jupyter is a breeze in data spell, but we don't need the data spell for now, so we click on next. And if you need Anaconda distribution tutorial, you can make sure that the checkbox is checked, as well as getting started with Anaconda, and click on finish. And just like that, we've installed Anaconda 3. It comes with Python 3.9. Well, now that we've been able to download Anaconda distribution for Python, we can go ahead and open it, or rather start it, and we're gonna see all the features that are there. So we go to Windows, search, and you can select, you can either type and search Anaconda Navigator, or you can simply select the recent, which is Anaconda Navigator here, and give it time for it to start. Yeah, it's initializing. As soon as it starts, it's gonna give you an option to update to the recent version of Anaconda Navigator. But now, for now, we say no, remind me later. As you can see, there are quite a few applications that are being hosted in Anaconda Navigator. You can see that there is a Jupyter Lab and Jupyter Notebook, which we're going to use for this course. And there's also another one that is very important when running Python, which is Spider, which is just a scientific Python development environment. And it's actually a very powerful IDE. And we can go ahead and launch Jupyter Notebook, which we're going to focus on in this course. And once you launch, it's going to open in your default browser, which happens to be, in my case, happens to be Google Chrome. And as you can see, the home page only shows the root directory, which shows you the folders in your root directory. The next step, we want to open a Jupyter Notebook. Once you click on New, you'll see there's an option to under Notebook, option to open a notebook using Python. Great. I can go ahead and click that as I do. And here we have now Jupyter Notebook. Has different sections. You can see that there's these options that you can click on. The file where you might choose to save the Jupyter Notebook, make a copy, rename, and other things. We have also edit, where this now helps you to make changes. Maybe you can copy or cut cell. And we have view, we have insert, cell, panel, widget, help, and the most important of all is this cell that you can see here. There are different things that you can do within this cell depending on which mode it is on. One, there's code. Code means that you can type code that you can execute. Another option that you can, another mode is Markdown or heading. These ones normally allow you to input text, textual, any text characters. Maybe you can write a normal text like you write in Word document, and you can actually even incorporate some formattings that can format the text in a way the way you want, like having header. Maybe you can have a topic, a subtopic, and so on. So the only two options you have here is either you want to type text or the code. So in this case, we might decide to check if it's working. The best way to check if Jupyter Notebook is working is just doing a simple print. We can print hello world, print hello world, hello world. And to run this code, there are different ways. You can either click here on run. For this one, run will run the whole notebook. But if you want to run only this cell, you have to click on this one, the just on the left side of the cell, and click on it. Once you click on it, it will print the statement hello world. And another option how you can run a piece of code there, you can either click on control enter, it'll do just the same thing, just print out the hello world, or you can say just executes the current cell. The other option you can use is just hold on shift and hit enter. What that does, it will automatically execute the current cell and goes to the next, starts a new cell. If you do that, shift enter and start a new cell, which happens to be by default it's a code. You can do whichever calculations you want to do. Maybe you can say maybe a calculation 100 divided by 8. If you hit enter, it just goes to the next line. But if you want to execute, you just use the methods that I outlined earlier. You can use shift enter, which will show us the output and start a new cell. The other option would be changing this to Markdown,
and you can type any text here. You can say maybe Python is awesome. And if you execute this, it only shows, it's not text. You see, you realize the cell disappeared, but it just prints out Python is awesome, because the cell was actually Markdown, which was only accepting text. So once you do that, another cell appears. If you use Shift Enter, another cell appears. And if you want to edit this, the Markdown, you have to just double click and the cell will appear, and you can continue typing whatever you want to type. And basically, if you want to save the Jupyter Notebook, you can actually double click on Untitled too, because it's not saved. And once you do that, you can change the text, the notebook name. You can say maybe Python tutorial and rename. And you might want to save as. If you want to change the name, is save as. It'll give you the option, so you can just type the path relative to the notebook directory. You can so yeah. And here, if you want to know the working directory, you can type something like pwd, path to working directory, and that's my working directory. So the same thing would happen if you type that. And I think that's enough intro for Jupyter Notebook. The next option that you can explore is the no install. The no install, good example is Google Collaboratory uh, environment, where you don't have to install Python, you just have to go and run any piece of code that you want. You can do that. You come to Google and search Google Colab. Once you search, you'll find there are quite a few. If you click on welcome to this Google Colab.research, welcome to Collaboratory, you click on it. So once you search, it's gonna say welcome to Collaboratory, and you can insert a piece of code that you want. And once you click on code, it uh, starts a new cell which only accepts a piece of code. Or you can click on text. It will only allow you to input text, just like Markdown in Jupyter Notebook. And we can insert a piece of code. I'll show you how to execute. Here you can do print hello world. If you want to execute, you can either hit Control Enter or Shift Enter, or you can click on this button here on the left side. If I click on the button, what does it will execute the code, and it's gonna print out the statement hello world. So as you can see, has printed hello world. You can choose to add text. If you can say Python is very powerful, and all you need to do is just execute just normally, Shift Enter, but all it does is just shows the text. So basically, you can type anything that you want to there. If you want to edit this, you just have to double click on it and you can continue editing. And that's it for the non-install. That's a good example where you don't have to install anything, and it's free. You don't have to pay anything. So it's a good option to explore. But in this case, even Jupyter Notebook is free, so you don't have to worry so much about the cost, unless you don't want to install other libraries that comes with Python. So for Google Collaboratory, you don't have to install anything. Everything is just there. It's already installed. You don't have to install anything. So, but in this case, we only focus with Jupyter Notebook for this entire course.
The first fundamental we will look at is the comments. To include a comment to describe part of the code, you must start the statement with a hash. A comment may appear at the start of a line or following a white space or a code, but not within a literal. All comments are ignored in Python. It is particularly important to add comments to describe variable definition or part of your program, because it is very easy to lose track of what you have done in your code, or for other people who would like to use your code. Another fundamental for Python, just like other programming languages, is that it uses variables. Variables are basically names that represent values stored in the computer memory. The values stored in a computer memory are able to change. The variables in Python are automatically created as soon as they are initialized. Normally, the variables are defined when they are assigned a value. When a variable represents a value stored in the memory, we normally say that the variable references the value. So, how do you create a variable? In Python, the assignment statement is actually an equal sign. For example, the variable num is assigned the value 20. In this case, the variable name num or the name num represents the variable, and the value 20 is stored in the memory location. So what this means is that the variable will be automatically created and it will reference the value 20. Let us try it out in Jupyter Notebook. If you have not installed Anaconda distribution, which comes with Jupyter Notebook, please watch my previous video. Now we can go ahead and start Anaconda distribution. We go to search, Windows search, and type Anaconda distribution and select under best match, click on it, and we can go ahead and launch Jupyter Notebook. We can go ahead and start a new Jupyter Notebook with Python 3. Once you click on it, this is the landing page. You rename this to Python Fundamentals, and then you click on rename. So the first thing that I'll do is convert this cell to Markdown, and I can go ahead and have the level 1 topic. All you need to do is just start with a hash sign, and now you can write whatever the topic is. And then the first thing we want to do is I'll show you how to add comments. For you to add comments, you have to start with hash. So in this code cell, make sure that now this is a code. We can add our comments. Remember we said that comment may appear at the start of a line. So we can add a comment. You have to start with a hash and you put a space, and then you can say something like that's, you can add a comment like that. That can be a comment. And also it can also appear after a code. You can say something like digits. Maybe we assign a value like 25, and then we can add another comment. This is another way of adding a comment. You can add hash, and then you can say also following a code. This here, this is a piece of code, and this is, we'll look at it later, but this is a variable and has been assigned a value 25. So this is another way of adding a comment. Also, we have another way. We can have a white space, and you can add a comment after white space. So you can say also following a white space. That's another way. So these three, all of them represents a comment in Python. In some instances, if a string character starts with a hash, it does not qualify to be a comment. For example, because the whole of this is a string. A string is just a data type where it's enclosed within these quotes. So this is not a comment. So what happens is that Python will automatically ignore any comment, but it will recognize this. This is now a code. This is another code where a variable of string type has been created in the memory. And this is just one way of having a comment. So they will be ignored. The next thing we want to do is create some variables. And now we can go ahead and initialize a variable. Remember, a variable will always be initialized using an assignment statement, which is equal sign, and then followed by the variable itself, the value. Now in this case, we can say that the value 20 is assigned to a variable named num. We can go ahead and print the value. You can say print num, and if you execute that, you can either click on this run button here on the left side of that code cell to execute, or you can hold the control key and hit enter. Num is a variable, which means that it can take different values. You can say, if you decide to change the value of num to 23,
and execute again, maybe control enter, the value of num becomes 23. That's why it's called a variable, because it takes usually take different values during the execution. There's also something else we call variable reference. Variable reference means that a variable is just the name given to the memory location. In this case, for example, here, the num is a variable name, and 23, where 23 is saved in the computer memory, that is what we call memory location. So the variable num usually point to the location where that is a certain memory location where a value of that variable can be stored. It can be 23, it can be 50. So it doesn't matter. We will now look at variable reference versus copy. Whenever the variable is used, it takes the value by referring to it in memory. It does not take value from a copy. For example, when num1 references the value 20 stored in the computer memory, and num2 references num1, num2 refers to the same object as num1, i.e., the two variable points to the same memory location where the value 20 is stored. In this case, Python uses referencing to memory. This is particularly important when working with large datasets, as you do not need to reserve computer memory for the same dataset. Going back to Jupyter Notebook, I'll show you how this is done. We might decide, for example, say initialize num1 equal to maybe 20, and then we can also have another variable num2 that is assigned num1. So if you decide to print, for example, the value of num1, you realize that the value is 20. If you decide again now to print the value of num2, you realize that both of them are equal to 20. So something that you should realize is that num2 is using a variable rather than a value. So what happens here is that we don't create another variable. Remember that variable points to a certain memory location. But in this case, since num2 is referencing num1, it means that it doesn't take the value from a copy of num1. What it does, it takes the value stored in the computer memory that is being pointed by num1. So in this case, it's going to that memory location where there's a value 20 being saved, and now that's why it does return the value 20. So basically, we can see that num1 and num2 are both pointing to the same object. There is a clear difference between variables and constants. Variable is used to measure characteristic of interest that can take different values. The value stored in a computer memory can change during program execution. On the other hand, a constant is a quantity that has a fixed value. Once stored in a computer memory, constant does not change during program execution. A good example is pi, which takes on the value 3.14159. Let us go back to Jupyter Notebook to see this. Let us now look at how to initialize a variable and a constant. To differentiate the two, I'll use an example where we can get the area of a circle. We usually say it's pi multiplied by radius squared. The value of pi doesn't change. It usually remains the same, but the value of radius can change. You will have pi to be a fixed value, and we can have our radius r to be a variable. To define fixed value as a constant name, what we do, we usually use all uppercase. So in this case, to define it, we have fixed value. All these should be assigned a value 3.14159, and radius is our variable. So constant should be all uppercase, and for the radius should be all lowercase. So now we can decide what is the value of radius that you want to use. We can decide to use a radius 10. So we can say the area of circle is assigned constant value of pi and multiply it by the value of radius multiplied by radius. So we might as well decide to print area of that circle. If you run this, you actually get the value of 314.159. So that's how you are able to differentiate between a fixed value, constant, and a variable by the way you define them. So how do we name our variables in Python? Just like other programming languages, there are some rules to adhere to when naming variables in Python. Variable names must start with a letter or an underscore. Variable names cannot contain white spaces or punctuations. Variable names may contain letters, numbers 0 to 9, and underscores. Something else to note is that variable names are case sensitive and should never be Python keywords. There are several variable naming conventions, most of which are not mandatory, but very vital for readability of code and avoiding confusion. Variable names should be all lowercase, while constants should be in uppercase. Variable names should be short and descriptive. For variable names made up of multiple words, use either underscore to separate the words or use camel case to represent the two words. Whichever approach you choose, please be consistent. Class names should always start with an uppercase letter. A single leading underscore should be for private identifier and two leading underscore used for a strong private identifier. The next thing that we're going to look at here in Jupyter Notebook is how to name our variables. A good example is the name of a person. We can have a name and say something like Matthew. If you print name, it's going to print out name. That's a very good variable name. It's all lowercase and it starts with a letter. We can have it starting with underscore. Still, this will be recognized as a variable. But then let's try something else. Let's try it to start with a 1. Let's see what happens if you do this. Voila. It says syntax error, invalid syntax. The reason is because it can't start with a digit between 0 to 9. It can only start with a letter or underscore. The next thing I want to show is that we can have the same here. We can have letters and numbers or underscores. So you can have this one underscore, name underscore 1 underscore 1. This is valid variable name. But then let's try something else. What if we decide to have this to be our first name, and we have the space? Let's see what happens. If you try to have a white space in the variable name, what happens? You get invalid syntax. What this means is that you can never have a white space in the variable name. If you have multiple words that you want to use for your variable name, what you should do, you should either use an underscore between the two names, between the two words, or you can have something like maybe last name and say my last name. Let me just use my last name. And we can have something like this. So first name is Matthew, so we need to have an underscore. So rather than having an underscore, we can have camel case. The first letter is lowercase, but the first letter of the second word is capitalized. So these two are valid variable names. And something else you should know is that variable names are case sensitive. For instance, I initially defined first underscore name, which is all lowercase. Then you decide, look, let me just change this to try to call maybe first name with the F being uppercase. If you try to execute this, what does they tell you? First name is not defined. The reason is because this is not recognized as small. So these are two different variables. These are two different approaches. Either use underscore or camel case. In your program, it's always recommended that don't mix the two approaches. The next thing I would like to say is that variable names can never be Python keywords.
all these words that are here can never be used for, you can never use these for your variable names, because there will be a conflict and that will cause problems for your program. So make sure that you never use these words. These are the keywords anyway. And I think that's it for the naming conventions. But if you have any question, you can type in the comment section. Thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. Hello, welcome again to this video tutorial on how to format Jupyter Notebook. Jupyter Notebook is a web-based interactive computing notebook environment. It allows you to edit and run human-readable docs while describing the data analysis. It enables you to represent textual information, code, and output in a visually appealing manner. It is very important to know how to format the notebook. The first important thing you are going to look at is the heading. To format the heading and titles, do the following. To have a title, the only thing you're supposed to do is start with a hash followed by the title name. That will give you the title. The next thing is having the heading. So we are going to have our heading in different heading levels. The first heading you use to hash signs followed by the heading name. If you want to have heading 2, you have hash appearing 3 times followed by the heading 2, and so on. If I execute this, that's what you get. The next thing we are going to look at is how to add emphasis on a piece of text. To add bold text, insert text in between a pair of double underscores. For example, we can add 2 underscores before text and double underscore after the text. If you execute this, you realize that the text in between the double underscores has been highlighted in bold. On the other hand, to write italic text, insert text in between a pair of single underscore. And for example, if you add the underscore before the text and an underscore after the text and execute that, you realize that the text in between the underscores has been highlighted in italic. The next important thing we are going to look at here is how to add line break in Jupyter Notebook. To add a line break, add BR, which stands for break, at the end of the line. For example, if I choose to write 3 sentences and I want them to appear in individual lines, then if I execute these, you realize that we get all the 3 sentences in a continuous single line. To ensure that all these appear in separate lines, you'll have to add a line break at the end of each sentence. So if now we try to execute this again, you get all the 3 sentences in individual lines. The next thing we are going to look at is how to add horizontal lines in Jupyter Notebook. On a new line, enter 3 asterisks. For example, if I want to add a line after the first sentence, I'm going to add 3 asterisks on a new line after the first sentence. So if I execute this, we get a horizontal line after the first sentence. The next thing we are going to look at is how to add colors in Jupyter Notebook. To highlight some text in different colors, do the following. You can use this special code to highlight your text in different colors. For example, all you need to do is specify the color in here and make sure that your text is here. If we execute this, we see that our text has been highlighted in different colors. The first text was highlighted in pink, the second one in red, the third one in blue, yellow, and green. The next thing we're going to look at is numbered lists and sublists. To add numbering to text, do the following. 1. For numbering, type a number followed by a dot and a space. For example, if I want to have 3 sentences and each is numbered from 1 to 3, what you should do is add the number followed by a dot and a space. If I execute this, you realize that we'll have a list that has been numbered. Again, we would like to have something like the sublists. Sublists is where we have
different form of numbering. To add those, we have to start with a tab space and then type a number followed by a dot and a space. And here we have a normal numbering. Then to add a sublist, you have to start with a tab space followed by a number followed by a dot and a space. And then you can have your text there. If you want to add a deeper subtext, all you need to do is have two tab spaces before the number followed by dot and then the space. So here, if I run this will look like this. The next important thing we'll do now is how to do text indentation. To display text in an indented block, start the line with this sign or arrow followed by a space and then the text. For example, if you just want to have a single indented block, you can have that symbol followed by a space and then the text. If you want a deeper indented text, you use 2 of those arrows. And if you want a more deeper indented text, then you use 3 and so on. If you execute this is what you get. The next thing we are going to look at is how to add monospace font. Monospace font is some text highlighted in a light gray background, and it's mostly used to highlight file paths, user entered messages, file names, etc. For example, to achieve this, we use a single quote on one side of the text and a single quote at the end of the text. And if I execute this is what I get. You can see that this text here, this is a monospace font, has been highlighted in a light gray background. Another very important thing that you should know how to achieve in Jupyter Notebook is how to add mathematical symbols. To add mathematical symbols, insert the symbols in between the $sign. For example, if you want to add a function y is equals to mx plus c, which is a mathematical formula, what you do, you just add the $sign before the formula and a $sign after the formula. So if I execute this is what you get. And clearly, this looks like a legit mathematical formula, y is equals to mx plus c. The next thing we are going to look at is internal links. Adding internal links to jump to different sections of a notebook. Internal links has two components, the source and the destination. For the source, this has to be implemented in the location where you would like to get the clickable link. The format for this is as follows. It should look like this. This is where the text goes and the ID for that link. For the destination, this has to be implemented in the location where you would like to take the user once the user clicks on the link. The format followed for this is you start with a tag and then you have ID, then you close the tag. This can be followed by whatever content you want, be it text or image. For example, at the destination, you're supposed to have this. For example, if you'd like to have someone to click on a link to go all the way to the top of the page, you're supposed to define this in a cell on top of that page. And the source should have this. First, this is what the link will have, and this is the same as this ID, the name of that ID. For example, we can go ahead and define this. I'm going to copy, and then scroll all the way to the top of the page, and then create that here. This is where now this is a destination. Once I paste that and hit execute, that disappears. You can't even notice that it's there. So going back to the link, now you create this link, the source. Once you execute this, you get this. This is the top of the page. That was the link name. But then there's a link to the top of the page where we defined this handle, the link handle, which is on top of the page. So if I click on the link, the source link,
it's gonna take me jump to the first page or on top of the page. So if I click it, let's see what happens if I click, it jumps to the top of the page. Now, this is very important because sometimes you might want to have content for your Jupyter Notebook and you want to help someone. If they click on a certain link, we're gonna go to a specific section of that notebook. We can go ahead and look at external links. These links, once clicked, they should be able to take you outside the notebook. For example, if you would like to navigate to a personal YouTube channel, for example, here, this is my YouTube channel. What you do, you just define what you want displayed on the link, the clickable link. And then inside these brackets, you have to have your URL. Once I execute, you'll have a clickable link that once clicked is gonna take me to my YouTube channel. And going back to Jupyter Notebook, so we've been able to create external links to refer to a specific web page content in your Jupyter Notebook. We use a library called iframe. So basically, you are supposed to import iframe from ipython.display. What it does, it only helps you to display web content. Now this is where the code that you're able to embed your web page in. So you start with iframe and note that these I and F are capitalized, and this is where your link goes, the link to that web page. And then the display should be of width 800 and height 450. This it's all up to you. You can have it to be a small one or a bigger one, depending on what you prefer. If, for example, if I execute this, you'll get an output which will be a web page. Suppose now, instead of embedding a web page, we want to embed a PDF document. We will use the same library iframe and have the link to be the link to the PDF instead of the web page. And if I do execute this, I'll get the PDF instead. Moving on, you might want to embed a YouTube video in your notebook. And to achieve that, we'll use a library called YouTube videos from IPython display. And to do that, we use the function YouTube video. Note about the capitalization of this word. And here is where you have the YouTube video ID, and the width is 800 and the height is 500. We can go ahead and execute this to see what we get. So basically what happens here, we get a video, a clickable video that I can play. In some cases, you might want to add some graphics or just images to your Jupyter Notebook in a Markdown cell. So in this case, to achieve this, ensure that the image that you want to add to Jupyter Notebook is saved in the same working directory as your Jupyter Notebook. So to do this, we have to use this special code that will help you upload a picture, an image. In this case, you can see that it's called img src, and then we have the name of the image plus the extension, which is png image. I want the image to be displayed in these dimensions. Its width of 200 and should be left aligned. I have the image saved in my working directory. So once I execute this, the image will be embedded in my Jupyter Notebook in this particular cell. But because I want the image to be in a new line, I can simply add the line break here after the first sentence. So if I go ahead and execute this, the image will be loaded on this section after the first line here. So I can go ahead and execute that. So you see, we have our image which has been uploaded here and has been
left aligned. The next thing we are going to look at is how to change your Jupyter Notebook theme. By default, Jupyter Notebook uses a light theme. There are many themes that you can apply to your notebook, but you have to install them first. We can do it as follows. Launch command prompt from Anaconda distribution 2. If you do not have pip installed already, run the following command to install it. You can install pip by first running this command on the command prompt. Once you run this, it's gonna download a file called get.pip.py. Once you download this, I don't want to do it again because I already have pip on my computer. And once you download it, you're gonna run this. You paste it here and hit enter, and that will basically install pip on your computer. Then the next thing you do is install themes, which we're gonna achieve by running this command in the command prompt. Remember, the reasons why we were installing pip in earlier is because we needed to run this command, pip install Jupyter themes. Once you run this, you're not going to install the most recent themes. So you have to run this command to get the most recent ones or upgrade to these the most current Jupyter themes. And then to ensure that you have installed the themes correctly in your computer, then you have to run this command, this. And if I run this, it's going to show me all the available themes that I can change to. And then the next step is applying the theme of your choice to your notebook. And this is the code that you are supposed to use. But this has to be done on a code cell. If you want to change the theme to Chesterish, you just paste it here and run the cell. Once the cell has been executed, what you need to do, you have to close Jupyter Notebook completely for it to be implemented correctly. So I'm gonna make sure that you save first your work and close Jupyter Notebook. I'll close everything and relaunch Jupyter Notebook. Once I launch it again, this is what you get. And you're gonna open your Jupyter Notebook wherever it's saved. I've saved it under the name Formatting Jupyter Notebook. If I click on it, this is what I get. You see the formatting is now a bit different. To revert back to your default one, this is the code that you use. Exclamation JT hyphen R. This will revert back to the default theme. So all I need to do is run this code. Once I run it, it executes. But remember, for you to get back to your default one, if you make any change to the theme, you have to close and open Jupyter Notebook. So exactly what I'm gonna do, I'm gonna close it and just leave because I haven't made any change. I'm gonna close these two and I'm gonna launch it back. So this is how it looks like. And then I'm gonna go back down here and open my Jupyter Notebook by double clicking on it. And as you can see, I'm back to my default theme. And this is the key to remember when you're trying to change. You have to completely shut down and restart Jupyter Notebook every time you apply a new theme. And thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. Welcome to this tutorial. We're going to look at the print method in Python. Basically, the print function in Python is a built-in function that allows you to output a string or any other data type to the console. There are several ways you can use the print function in Python, and the first one is print a string. You can have it as a heading, and to print a simple string, you can simply call the print function and pass the string as an argument. So for example, you can have print hello world. This is the string that you want to print out, and note that the string are enclosed in double quotes. So if I decide to print this, I get
hello world. The next way you can use the print function is print multiple strings. If you want to print multiple strings, you can pass them as separate arguments to the print function separated by commas. And so I can convert this to Markdown and convert this to heading. So for example, we can have separate words, separate string, and all you need to do is just pass them as arguments, separate arguments, but you separate them with commas. If I print this out, I get hello world. What Python will do here, to print the word hello and the word world and separate them with a space. So you get the two words or the two strings separated by a space. The next thing you can do is print some variables. Assuming that you have declared some variables and you want to print them out. For these ones, the only thing that you're supposed to do is just pass them as arguments to the print function, just like the way you're doing for the strings. For example, if you had a variable called name and the age of John in this case is 30, and then we wanted to print out a statement saying my name is John and my age is 30 years old. How to achieve that? You're supposed to come and print this out. Print, just pass the first argument to be a string, and then this will be a variable, comma, then you pass another string argument, and then age, which is the variable, and then the last part of the string. If I execute this, I get one complete statement saying my name is John and I am 30 years old. And that's basically how you can print the variables. And also, you might want to print string with variables. And how to do that? We can use some special string formatting to insert the values of the variables into the string. And we can have a small heading. So to do that, assuming we have the same variables, we have these two and copy and paste them there. And we wanted to print out a string and also these, the two variables. How to achieve that? We use the print function and format it this way. So you're supposed to use the percent sign s, and this will be the placeholder. So what happens is that the first variable will be substituted here and the second variable will be substituted here. So if I go ahead and print this out, I get my name is John and I am 30 years old. So that's how you can print out strings with variable by formatting the strings in this format. This will act as a placeholder where the variables will go. So basically, you can use this to incorporate variables into the string. The next way you can use the print is using something we call f strings. Add this as a markdown, so have it as a header. So suppose now we have our names, name and age variables, and we want to print these but using f string. And to print the same thing using this, we use a special format, and this special format is you start with f and then we write the first part of that string and then we enclose the variables inside curly braces. So basically where you want the variable to go, that's where we use the curly braces. And if I print this out, I get the same thing as what I got above, just the output above, which is the same as saying my name is John and I am 30 years old. And the next thing you can do is sometimes you might have some special characters that you want to print. You have string that you want to print out, but within the string, you have some special characters. And these special characters might be something like a new line, could be a new line, could be a tab, or some escape characters. You might want to print something with some quotes. So for example, to print a string with special character, you can use escape sequences. An escape sequence is a combination of characters that represent a special character. For example, to print a new line, you can use the backslash and then n. For example, assuming you wanted to print this, you want to print hello world and how are you today. You want to start a new line after hello world. How do you achieve that? Mark you, if for example I decide to do this and hit enter, then there's an error. So the best way to do this is to use forward slash n. This will print two lines because we have the escape character indicating that we are starting a new line. Also, to print with special characters, especially like multi-line, you might as well use triple quotes. But in this case, let me just do that. You can actually do this, hit enter. But instead of having a single quote, we can have three quotes. We have three quotes. So actually this will be able to print out two set of lines. So if I execute this, I get this, but then I have to remove that. So we need to have print and three quotes. That will print out multi-lines. Another thing that we might be able to print out with the print function is custom separators. Suppose you wanted to print out hello world, but in between the two words, you want to separate with something else other than the space. If you remember well here we printed out two separate strings into one, but separated them with the space. Now, in this case, if for example you wanted to print out a string, you wanted to print out string, but with custom separators. So to achieve this, what you do, you just come and pass the two strings as separate arguments in the print function and pass the third argument called sep equal, and then you enclose whatever the separator you want inside the bracket. So if I print this out, I get hello world, comma, hello, comma, world. That's what we get. And then there's also another way we can print without a new line. So suppose we have two pieces of text and you want to print them. It's like you have two lines. Just cut that. Then you have two lines, but then you don't want to, without a new line, print strings without a new line. So suppose you want to use two separate print functions, but then you want whatever will be printed out would appear in a single line. And to do that, all you need to do is come here and print hello, and then instead of ending the line so that you print out the next line, then you say end equal space. Now what this will do, the two will be printed as a single line. So you have hello world in a single line rather than having two lines. And I hope this is clear. If, for example, I try to do this as an example, I get two lines. But if you don't want them to appear in different lines, then what you do, you put a comma, then end equal space. Now this will simply substitute the new line with space. So I hope that is clear. Thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. Welcome back. In this video tutorial, I'll go through the overview of the different data types we have in Python. Python has a number of built-in data types that allow you to store and manipulate different kind of data. The first one I'm going to look at is numbers. Numbers are classified into three. The first one is integers. Integers are basically whole numbers that can be positive, negative, or zero. You can use the int data type to represent the integers. A good example here, and a very clear one, is you can assign a value, a whole number 10, to a variable called x. A negative is assigned to a variable called y, and a 0, z. If you check the type of this data type by executing the cell, you get the int, which means the int is just a data type that is used to represent the integers. The next kind of number we're going to look at is the floats. Floats are basically numbers that have decimal points, and we use a data type called float to represent the floats. For example, we can have a positive float or we can have a negative float, but we can also have a 0, but it will be 0.0 something. So in this case, we can have an example where a value 10.5 has been assigned to a variable called x, and another negative 0.25 has been assigned to a variable called y, and z has also been assigned to a decimal number. If we execute the cell, we're going to see that the data type for the variable y is float. So that's the second number that we can have in Python. The last number is the complex numbers. The complex numbers are basically numbers with a real and imaginary part. In Python, you can use the complex data type to represent complex numbers. The real part is specified before j, and the imaginary part is specified after it. For example, so we have, this is the j is the imaginary part, and this, what comes before j, is the real part. And you can have these examples. X is equals to, or is assigned the value 3 plus 5j, which is an example of a complex number, which basically it's a complex because it doesn't take one, there's one part that's imaginary and the other part is real. So if you check the type, you get it's complex. The next data type you're going to look at is the string. And basically, strings are just a sequence of characters that can be used to represent text. And the data type that we use here is the str, to represent the strings. And we have two ways of defining the string type. We have single quotes enclosing the text, or a single quote. Both of them are of string type, but make sure that when you're defining, you cannot have a double quote and a single quote. Both of them have to be the same as if you decide to use single quote. You have to use single quote on both sides of the word. And the type is str, which is the string type. And you can also represent string in triple quotes if you want to define a multi-line string. For example, there are three lines, and you want to have them represented the way they are here. So you need to use three double quotes or three quotes. They can be single or double, depends what you want. And if you decide to print the type of x and also want to print the value x, so if you execute this, you get as of the string type is a string, and you have the three lines printed out. The next type of data type you're going to look at is the Boolean. For Boolean, these are just data types that allow you to define true or false. For example, you see that x has been assigned a value true and y has been assigned a value false. If you check the type of either x or y, you get is the bool
So basically, bool is the data type used to represent Boolean. The next thing we are going to look at is the lists. As the name suggests, these are basically a collection of items that can be of different data types. So in Python, we use the data type called list to represent the lists. For example, we can have a list of integers, We can also have a list of string characters, or you can have a mixture of different data types. For example, you can have, this is an integer, this is a string character, and this is a float. So all this represents a list. If I decide to check the type of, maybe let's check y, if I execute this, it tells you that whatever y is of list data type. And the next thing you're going to look at is the tuples. And tuples are just similar to lists. The only difference is that it's immutable, meaning that you cannot modify or change the content once they are created. And in Python, we use tuple data type to represent the tuples. You can define a tuple using parentheses and separating the items with commas. For example, and you can have a tuple which contains a number of integers which are being separated by commas. You can have a tuple of a number of string characters separated by comma. Or you can have a mixture of different data types, which is maybe one is an integer, and apple is a string, and 3.14 it's is a float. And you can also check the type, and you can check, for example, z. Type of z it's tuple. So this is the data type. And the next thing we look at is the sets. Basically, sets are just an ordered collection of unique items. So they have to be unique. You cannot have different numbers. They have to be unique. They have to be unique, like 1, 2, 3. So, and how to define them? You have to use the curly braces to enclose your items, which have to be separated by commas. You can also have another set of string characters, some sort of number of strings that are being separated by comma. You can also have a set of Boolean characters or Boolean values or variables. And the last one we are going to look at is the dictionaries, which are basically an ordered collection of key value pairs. By key, they mean this. The first part is the key, and the second part is the value. And these pairs, you can have a number of pairs, and these pairs have to be separated by commas. And the value, the key and the value have to be separated by a full colon. You can have different value types or data types. These are basically integers. And the second one, the values are string characters, string character and integer, and another string character. You can also have another pair that has the value being float type, and they're enclosed in curly braces. So we use a type called dict. A dict type is used to represent the dictionaries. And if we decide to check the type, let's see what we have. We can check for X. If I execute this, I get a dict. So basically, that's an overview of how to define the different data types we have in Python. And in the next series of videos, I'm going to explain these data types individually, and it's gonna be very clear. I know at this point it might be very confusing, and these data types, there's a lot that you can do. So in the next videos, I'll explain to you exactly how to work with them in Python, and it's gonna be very interesting. And thank you for watching.
Please remember to subscribe to my YouTube channel and let me in the comment section what else you want to learn other than Python. You can tell me which part of data science you want to learn, be it machine learning, deep learning, anything that you would like to learn. Let me know. Thank you and see you in the next video. In this video tutorial, I will look at numeric data types. Numeric data types are used to represent numbers in a Python program. And in Python, there are several built-in data types for representing numbers. The first one we're going to look at is the int, which is basically used to represent integers and can store values from a big number, about 2 billion, about negative 2 billion to about positive 2 billion. If the number is larger than that, then we use the long data type to represent the integers that are too large to be stored in int. The long data type can be used to store any values of any size, but are generally slower to work with than int. The second numeric data type you're going to look at is float. And float is basically a data type that is used to represent floating point numbers. And floating point numbers are basically numbers with decimal points. And the next one that we're going to look at is the complex numbers. Complex numbers are basically numbers that have two parts. The first part is the real part, and the other one is imaginary part. And it's represented in a form. It's written as in a form of a plus b j, where a is the real part and b is the imaginary part. The next thing we're going to look at is how to work with numeric data types. And under that, we're going to see how you can declare these numeric data types. And basically, for you to declare the numeric data types, the only thing that you're supposed to do is just assign the numeric values to a variable. For example, if you assign a number 10 to a variable called x, then we say that x is an int, or basically an integer. If we assign 20 to y, y is still considered to be an integer or of int data type. If now we introduce a decimal point and assign that value to z, then we say that z is a float. And regardless of the number of decimal places that you use, still the variable will be considered to be a float. And now, if you have a complex number, which is 3 plus 4j, and assign it to a variable called c, then we say that c is complex, is of the data type complex. And there are some operations that you can perform using these numeric data types. And the first operator you can use is the plus sign, or the plus operator, if you want to add two numbers. You can use the minus operator if you want to subtract those numbers. You can use asterisk if you want to multiply the numbers, and you can use the slash or the division operator to divide the numbers. And this is very important to note. Two asterisks represents an exponent. You can do exponent of a number using the two asterisks, double asterisks. And then in case you want to get the remainder of a division, then we use the modulo operator or the percent operator. This is called modulo. So modulo operator can be used to calculate the remainder of a division. For example, we can find the total of x plus y. Basically, if you add two integers, because remember, x and y are both of integer type, which means the resulting sum will be of integer type. The same applies to if you decide to get the difference between two numbers, two integers, we get an integer. Likewise, if you decide to get the product of two integers, you still get an integer.
But if you decide to get the division of two numbers, then you get a float. Any division of two numbers, you get float. But if you decide to get exponent of a number and an integer, then you will get an integer. If you decide to get the modulo or the remainder of x divided by y, then the difference must be a whole number, which means that it's still gonna remain to be an integer. So we can execute this. Once you execute, we can check the resulting values. For example, we can check what the type of total will be. Remember that Python is case sensitive, so if you want to check the type, then this has to be capital T. But in this case, I'll correct this to be a small t for both, because according to variable conventions, variables should be represented in small case. You just use lowercase for everything. So you see that we get int for total. If we try to get the type for the difference, we get integer as well, int. We can check the division. For division, you get float. Remember, if you are dividing any two numbers, regardless if they are float or they are integers, you still get a float. And we can also check the value, the type of the exponent. We get int. And if we check for the remainder, we still get the same int. And you can also perform some operations on floats and complex numbers. And we're going to look at floats, how to do some operations with floats. Remember that we said that Z was declared as a float as well as W. So to get the sum of Z and W, we'll automatically get total to be float. Likewise, if you get the difference between Z and W, you get the difference to be float. Same applies to if you get the product of Z and W, you'll still get a float. If you do division, Z divided by W, you'll still get a float. We can actually run that and check and print out. We can check the value of the type of the product. If you execute this, you get is of the float type. That's for product. Same applies to diff. If I execute this, I still get float. The same applies to the division. You still get a float. And that's it for the floats. It's just straightforward. It's just like the normal math that you normally do using your calculator. The only difference is that these are variables are being created. Total is a variable that is being created, similar to difference, product, and division, and all of them are of data type float. The next thing we are going to look at is the complex numbers. We can still perform some calculations using complex numbers. And for complex numbers, you have to make sure that this is can get total, because it's a keyword. That's why it was sum was highlighted in green, meaning that it was a keyword. And if you use keywords for your variables, it's going to create some issues. So if you add C is a complex number and W is a float, if you add a float and a complex number, you automatically get a complex number. The same applies if you want to multiply a float and a complex number. You'll still get complex. And same applies if you decide to divide. You still get the same thing. And we can actually print maybe one outcome like total to see what we get. And if I execute this, you realize that you are going to get a complex number. And this complex number has two parts. Remember, this is the real part and 4 is the imaginary component. So there's so much you can do with complex numbers, but these are good examples showing that you can still do some calculations. But just remember that you have to check. If you check the type of, maybe let's take one example like total. If you print out the type, it's gonna be of a class called and the data type is complex. So, but you don't have to use the print. You can actually just do that. If I just want to print to check the type without anything else, we just have to execute type, and then in the parentheses you put in the variable name that is being created, and if you check, you get is a complex data type. And those are ways that you can do some operations using the numeric data types. But in some cases, there are some inbuilt functions that you can use to manipulate numeric data types. For example, you can get the absolute value, which is basically it's like you're multiplying, you're just removing the negative part. If it's positive, just remain positive, but if it's negative, then it's like you're multiplying it by -1 to get a positive. So if I execute this, the output would be 3.14. This now is a function, it's an inbuilt function called ABS, which stands for absolute value. And then also you can round off some numbers. For example, this is quite a long number with how many decimal places? 1, 2, 3, 4, 5, 6. 6 decimal places. In some instances, we only want to round off to the nearest 2 decimal places, which means if I round off this to 2 decimal places, then I'm gonna get 3.14. And round is just a function that is used to do that. It has 2 components. The first component is the number that you want to round off, is a float that you want to round off, and this digit here just indicates the number of decimal places you want to round off to. And there's also another function called power. I can say power, it is assigned power of that. So this means it's like you want to get the exponent of, or just say 2 raised to 3. This is what the power function does. You just take 2 and raise it by 3. So is basically 2 cubed. And if we execute this, and there is some issue. Oh, sorry. Now you see, you have to ensure that you get the correct function name. The correct function name here is not power, but rather it's POW. That stands for power. And we can change this to be the variable name power, because this is not a keyword, but this is the keyword. So if I execute this, now you get it to run. If I can print out these values, can print out the absolute value. If I execute, I get 3.142. Is no longer negative but positive. If I check the value of the rounded, you get 3.14. If I print out the value of power, you'll automatically you'll have 8. You'll get 8 because 2 raised to 3 is 8. So it's actually working just fine. And I think those are the 2 examples of the inbuilt functions that you can use, but there are many out there that you can still use. And the last thing that we're going to look at is how to convert other data types to numeric, data types. For example, here we have 3.14, which is float. And if you execute this, if you check this is going to convert, it's going to convert 3.14 to integer. So basically, it's going to have it as 3. And suppose that you had a string type and is 3.14, but a string type. If you want to convert it to float, then you just have to execute, and you're going to get 3.14 because it's been converted to a float type. And you might have 3, 4. 3, 4. If you convert that to complex, then you're going to have 3. The first part, 3, will be the real part, and 4 will become the imaginary part. And we might as well print these values. If we print, you can actually print all of them together. A, B, C. Make sure that you just separate the whatever you want to print, separate them using a comma. If I execute this, I get 3, which means that 3.14 has been converted to int, and the string 3.14 has been converted to float, and 3, 4 has been converted to complex and became 3 plus 4j. And you can decide to check even the type. You can just insert a new cell and maybe check the type of A. Let's see what we get. We get int. You can check for B as well. You get a float, which is true. And we can check C. If we check C here, let's see what we get. We get complex. And it means that those values inside the brackets have been converted to numeric type. It's basically switching the numeric. So to convert to integer, you just use int, and then you put anything that you want to convert in the bracket. Float, you put whatever you want to have in the bracket. Complex, you have whatever you want in the same thing inside the brackets. And that's basically it for numeric data types. And next, we will look at strings. So be on the lookout for the next video. And thank you for watching and following. Hopefully everything is all right. If something is still not clear, please do post a comment on the comment section, and I'll be able to help you. Thank you for following, and see you in the next video.
String is a data type in Python that is used to represent text. A string is made up of sequence of characters. In Python, you can define a string using either single quote or double quotes. Triple quotes can also be used to define a multi-line string. We will now learn more about working with strings. To define a string in Python, we use either single or double quotes. For example, string 1 has been defined using single quote, and string 2 has been defined using double quotes. It is important to match the quotes when defining a string. If you use single quote to start the string, you must use single quote to close the string. If you use double quote to start the string, you must use double quotes to close the string. If you need to include a quote character within a string, you must use the other type of quote to define the string.
We can now go ahead and demonstrate how to define variables. And to define variables, you can either use single quote or double quotes. And so this is the first single quote, and you can as well use double quotes. If, for example, we decide to print this out, you can print the first one, string 1, and you can as well print string 2, just to confirm if both of them are the same. If I do print string 2, if I execute this, I get the same thing, which means that string 1 and string 2 are the same, despite being declared using different quotes.
To define a multi-line string in Python, we use triple quotes. This allows us to include line breaks in our string. Triple quotes can be used with either single or double quotes. It is important to use the same type of quotes to start and end the string. Multi-line are useful for defining strings that contain a lot of special characters such as new lines, tabs, and quotes without having to escape them. We will learn more about this next.
To declare a multi-string, then we can either use triple single quotes or we use triple double quotes. And if I execute this and print out string 3 and string 4, you realize that you're gonna get the same thing. Both of them have been printed out as two words, 2 lines each, which means this is another way you can declare variables, and it's particularly important if you want to use special characters like line break, tab, and you don't want to escape them. So that's where you can declare those.
In Python, we can access individual characters in a string using indexing. Indexing allows us to retrieve a specific character from a string based on its position in the string. In Python, indexing starts at 0, meaning that the first character in the string has an index 0, the second character has an index 1, and so on. For example, if you define a string 1 and assign it a string called hello world, then if we decide to print the first character, then we are going to say print bracket string 1, then you use the square bracket 0, and then you close the square bracket and then close the print brackets. The output will be H, which is the first character. If you want to print the second character, then you have to use 1 in the square bracket, which will give you the character E. We can also use negative indexing to start from the end of the string. In negative indexing, the character in the string has an index of -1. The second to last character has an index of -2, and so on. For example, if you wanted to print out the last character, which is D, then we have to say print strings, and inside the square brackets, we have -1. That will give you D. If you want to print the second to last character, then you have to use -2, and the output will be I. String indexing is a useful tool for accessing individual characters within a string.
To do string indexing, you first can have a comment string indexing, and you can also declare a string variable. Maybe say string 1. String 1 has a number of characters, and remember to count we start from 0, 1, 2, and so on. And you can also do the negative indexing. This one is position -1, followed by -2, -3, -4, and so on. So if you wanted to index, then we can use square brackets after the, for example, you can choose to print out the first character. You can say is string 1, use square brackets and specify the position, the index. And the index is basically the position of the character. So for example, if you want to print out the first one, then you print out square bracket 0. If I execute this, you get H. H is the first one, which takes up the index 0. If, for example, I wanted to print out the second character, I just change this to 1 and execute. You realize you get H and E, E standing for the second one. So we've been able to print out the second character. And also you can do negative indexing. And for negative indexing, you start counting from the end. And we can actually print out the last character. All you need to do is just copy and paste this and change this to -1, which stands for the last character in hello world, which should be D. We can confirm that. And suppose we want to print the second to last, you just copy this, you can have that, and change this to -2. If you print out this, you will get D and L. So this is the second to last, which means you're taking -2. And that's basically how you can index a string.
In Python, you can use slicing to access a range of characters within a string. To slice a string, use square brackets with the start and the end indices separated by colon. The start index is included, but the end index is not. For example, if you want to print the third, fourth, and fifth characters, set the start index to 2 and the end index to 5. The output will be LLO. If you want to print the first 5 characters, set the start index to blank and the end index to 5. The output will be hello. If you want to print the last 5 characters, set the start index to 6 and the end index to blank. The output will be world. You can also use negative indices to slice a string from the end. For example, if you want to print the last 5 characters, set the start index to -5 and the end index to blank. The output will be world. If you want to print the first 6 characters, set the start index to blank and the end index to -5. The output will be hello and the space. String slicing is a useful tool for extracting substrings from a large string. To do string slicing, then you can first declare a variable. We can call it a string. We can call it string, and we can go ahead and execute. And basically, to do some string slicing is that you want to select a piece of the string. For example, you might want to get the first three characters, or you might decide to get the last from 3, 4, and 5. You might decide to get the last 5. That's basically what we call string slicing. For example, if you choose to print out the third, fourth, and fifth character, and we can have 2:5. What this actually means is that this is included, the start index is included, but the last, the end index is not included. So which means is that since 2, given that we start from 0 to count, then 2 is the third character, the fourth character, and the fifth character. The sixth character is not included. I hope that is clear, because 5, index 5 is position 6. So if, for example, now we execute this, we get LLO. As you can see here, this is the third, fourth, and fifth. So this is 2 to 5, but 5, which is the space, is not included. That's why we're getting LLO. Similarly, if, for example, I choose to print out the first 5 characters, which means is character number 1, character number 2, character number 3, character number 4, and character number 5, we leave the start index to be blank, and we specify the end index to be 5. And if you execute this, you get hello. So those are the first 5 characters. And likewise, you can decide to print out the last 5 characters from character number 7 to the end. So you don't specify the end index, but you say 6. Remember, 6 now will be included. So if we count here, we have this 0, 1, 2, 3, 4, and 5. So we are starting from 6 all the way to the end. So if I execute that, we get the word world. So the last 5 characters. We might also want to do slicing using negative indices. For instance, we might want to print the last 5 characters, but now using negative indices. So we can do this. We can say, because we want to print the last 5 and -5 has to be included. Remember, we have -5 starting from, this will start from -1, -2, -3, -4, -5. So W is -5, and we want to print the whole word, including W
And since we know that the start index is included during slicing, then we just have to say it starts from -5 all the way to the end, because the end has been left blank. So if I execute this, you get the word world. Again, you might want, for example, to print out the first 6 characters and see. So basically, we want to print all the way to, this is position -5. We can have the same thing here, but and switch the places of, instead of having the start index, we can have it in the end index. If we execute this, let's see what we get. We get, if you can see, you notice that if I highlight it like that, there is a space. The reason for this is because, as you can see, we are indexing from the start. This means that it's basically from 0, at the start of the string, all the way to index number 6, but not including that index -5, which means is that it's gonna come all the way to the space. It's from 0 all the way to -5, but not including that -5. So you are going to get the word hello and a space. I hope that is clear for slicing. There are several inbuilt functions that you can use when working with strings. We can use examples to demonstrate that. You can go ahead and define a variable called string and execute that. If, for example, you just take string and put a dot and hit tab, you will see all these are functions that you can use to manipulate the string variable. So all I did was write the name of that variable, put a dot, and hit tab on your keyboard. You'll see all different sort of functions that you can use to manipulate the strings. We can use some examples to do a couple of them. For example, you might want to check the length of the string. You can use the len function. The len function will basically count the number of characters in that string, including the white spaces. So if I execute that, we see that the length of string is 19. We can also convert everything to lowercase by using the lower function, and we can go ahead and execute that. We see that it's lowercase string is hello world. We see that h has been converted to lowercase. The next thing we can have a look is converting everything to uppercase. So we just use upper, but you have to start with string dot upper, and you can print out the resulting string variable is just the hello world, where everything has been converted to uppercase. We can also check, we can also capitalize the string. By capitalizing the string, what it does, it just converts, usually converts anything that was in capital has been converted to lowercase. So that's how you're able to achieve that. Then the next thing we can do is count the number of occurrences of a certain substring. For example, you might want to count the number of times L is appearing in your string hello world, and we know that hello world will have, those are 2 and 3. Let's confirm if the count variable will do it for us. Let's count and see. Let's execute that. We get the number of occurrences of L is 3, which is true. You can also check if the string starts with a given prefix. So here we expect to have maybe a true or false. So for example, we might want to check if the string starts with space and h. To check that, we use the function called starts with, all small letters or lowercase. If you execute this, we see that starts with space and h is true. Because it's true, this is how it starts with that. There's a space and a h. Luckily for this one, if, for example, we chose to change this to small and see what it does. If you execute, you see it's false. The reason, remember our string starts with a capital H, which means that this is being lowercase, it's false. It doesn't start with a capital H. So we can revert back to our initial capital H and execute, so you find that that is true. Also, you might also be able to check if the string ends with a given suffix. And to do that, we use, so here we can use this, check if the string ends with a given suffix. We use the function called ends with exclamation and a space, some couple of spaces. So if I execute this, I print out the variable, which is the resulting variable. You find it true. You can also check something else, like if, for example, I say just copy the same thing and paste it there, and say maybe just add one space. Let's see what happens. If we execute that, we see that it's false. The reason, we have an extra space. We have an extra space in our string, but in this we only checked if it ends with some specific characters, but had one space deleted. The next thing that we can check using the inbuilt functions, is find the index of the first occurrence of a substring. For example, you might want to check at what index does the first O appear. So now this is the code that you can use, the function that you can use, find O. This will return the first occurrence of the string O, or the character O in our string hello world. So if I execute that, you see that it's position 7. That is index 7. And we can as well go here and count. We just use the arrow keys in the keyboard to count. This will be 1, 2, 3, 4, 5, 6, 7. It's in position 8. It occurs in position 8. The index is 8. It occurs after 7. That's why we are getting the first index to be 7. The index of first occurrence, it occurs after index 7. It's index 8, but it occurs after 7. The next thing we can do is we can replace occurrences of a substring with a new string. And to do that, we are going to use the replace. It's just like find and replace. And to do this, we find the occurrence of O and replace it with a 0. And let's see what we get if we replace and print out the variable that is created. You see, we have our hello world, but in this case, O has been replaced with a 0. So that's how it looks like. The next thing we can do with the strings is split them. We can split them based on something. For example, we can say split the string into a list of substring, and to split them, we are going to separate them with a comma. Yes. So you are splitting the string into different words and separate them with a comma. And remember, we said if it's enclosed in square brackets, that's a list. So the split function will always create a string of substrings. So the next thing that we can do is join a list of strings into a single string. And to do that, we normally use the join function. And the join function will just take the words and join them together. Remember, we created a substring, a substring containing a list. So all we want to do is we just want to join them together and add a comma. So if I execute this, we see we are getting hello, comma, world. So you are taking this and this and joining them with a comma. Hope that is clear. And the last thing that we can do, we can remove leading and trailing white spaces from the string. For example, we know that our string has some spaces before and some spaces after. And to achieve that, we will use the function called strip. And what strip does, it just remove the trailing and the leading white space. That's all it does. If we go ahead and print this, we see that our white spaces have been removed. And there are so many other functions that you can use. If you remember well, I told you that you can just write the name of your string and put a dot and hit tab on your keyboard. You will see all of them.
Thanks for watching this tutorial. I hope you found it helpful and learned a lot about strings in Python. Stay tuned for our next video. Don't forget to subscribe to my YouTube channel to be notified when the next video is released. Lists are a common data type in Python that allows you to store and manipulate a group of items in a specific order. Lists are mutable, meaning you can add or remove items from the list as needed. Lists have indices, which enables you to access items within the list by their position. Lists are iterable, which means you can loop through the items in a list using a for loop. In Python, you can create a list by enclosing a comma-separated list of items in a square brackets. Lists in Python are zero-indexed, which means that the first item in the list has an index of 0, the second item has an index of 1, and so on. To access an item in the list, you can use its index in square brackets. You can also use negative indices to access items from the end of the list. For example, the index -1 refers to the last item in the list, -2 refers to the second to last item, and so on. For example, if you wanted to create a list of items, then you say fruits is assigned a list enclosed in a square brackets, apple, banana, orange, and remember that all those are of string type, which means that they are enclosed in single quotes. And if you wanted to access the second item in the list, which that means that it's going to take the index 1. Remember, it's we start counting from 0. So which means that for you to access the second item or the second fruit, you say it's fruits, then in square brackets, you say 1. That will return the second fruit in that list, which is banana. And if you wanted to access the last item in the list, all you need to do is just assign fruits. Inside the square bracket, you say -1, and you assign that to a variable called last fruit. And the last fruit will contain orange, since that is the last fruit. I will now show you how to achieve this in Jupyter Notebook. To create a list, can add a comment, create a list. The first thing we do, will do the same example. Fruits, you assign it a number of fruits: apple, banana, and orange. And this is basically how you create a list. If you execute and print it out, say print fruits, you realize that you've created a variable of list type with 2 fruits inside. So something to note is that we use the square brackets and we add the list of items that you want to add and make sure that you separate them with commas. That's basically a list. The next thing I'll demonstrate here is how to access. Maybe you can access the second item in the list. And to do that, we use a square bracket with the index. So basically, let's find the second fruit. That's the variable name. And we want to get the second item. Remember, in Python, indexing starts from 0, which means the second item will have index 1. So we have 1 there. And we can go ahead and print that as well and see
the outcome, print, and then fruit, second underscore fruit. And once you do that, if you execute that, you get you get an error. The reason is because our variable is fruits but not fruit, so you have to change that to fruits. If you execute that, you get banana, which means you've actually created a variable, and the variable is assigned the second fruit in that list. And then if suppose we want to access the last item, we can use negative indexing, access the last fruit or in the list. So to access that, you can say last, assign it to a variable called last fruit. And then what you do, we use negative indexing. So all you need to do is just say fruits, and then you have -1. Basically, if you are doing negative indexing, you start from -1, -2, all the way to negative, whichever the first element is. So basically, this will give us the last fruit in that list, and we can go ahead and print it, last underscore fruit. If you execute this, you get orange. And as you can see here, orange is the last fruit in that list. And that's basically it, how to create a list, access an item in a list, and this is basically the positive indexing. And we have negative indexing, where we use the negative indices to get the items from the list from the last or from the end.
Lists are mutable objects in Python, which means that you can modify their contents. To add an item to the end of the list, you can use the function append. To insert an item at a particular index in a list, you can use the insert method. To remove an item from the list, you can use the remove method. For example, to add an item to the end of the list, we say fruits equal to, and then you assign the list of the fruits, the 3 fruits, apple, banana, and orange. Now to append another fruit at the end, in this case mango, we say fruits dot append, and then inside the bracket you specify the word mango, which is a string character, a string of string data type. And if you wanted to insert an item at a particular index, in this case index 2, we say fruits dot insert, and then inside the bracket you say index 1, comma, and then you specify the name of that fruit that you want to add to the list, which is pear. So the new list has 4 items: apple, banana, has apple, and then pear, the one that has been inserted, and then banana and orange. So if you decide to remove an item from the list, and we say fruits dot remove, we want to remove banana from the list, then we have to enclose the banana inside the brackets, which means our new list, if you execute that, you're going to get apple, pear, and orange.
We can go ahead and do it in Jupyter Notebook. So the first thing we're going to do is add items in a list. We're going to use the same list we had created earlier. Fruits, which contains 3 fruits. So you can add a comment there. It's always important to add comments. We want to add items to the end of a list, and to do that we use append. So we say fruits dot append, and then what we do, we add the item that you want to add, which is mango, and we can go ahead and print the resulting fruits. We can say print fruits, and see, remember initially we had a list of 3 items. If we add mango at the end, then we should have mango, a list of 4 elements or items, and you see mango has been added at the end of that list. Then the next thing we are going to check is how to insert an item at a particular index in a list. Suppose now we wanted to add in this now, in our new list, if we want to add another item at the second position or index 1, then you can go ahead and do that. Add an item at a particular index in a list. So to do that, we use the method insert. So all we need to do is start with the variable name, which is fruits, dot, and then you say insert, and then we have to specify two things here. The index, which is index 1, because we want to add in the second position, which is index 1, given that it starts from 0, then it means that the second position would be index 1, and then the name of the item that you want to include, which is, we can add pair, and we can go ahead and print this to see if our code works well. So fruits, you can use the print function, just say fruits. If you execute this, then you see that the second position, a fruit called pear has been added, and the rest. So now, according to our indexing, the list has got how many elements? 1, 2, 3, 4, 5. 5 elements. The len function returns the number of items in a list. The sort method sorts the items in the list in ascending or descending order. By default, it sorts the items in ascending order. You can pass the reverse equal true argument to sort the items in descending order. The reverse method reverses the order of the items in a list. The copy method creates a shallow copy of list. This means that the new list is a separate object, but the items in the list are still references to the original object. For example, if you wanted to get the length of a list of fruits, 3 fruits in particular, apple, banana, and orange in that order. If you want to get now the length, you say num underscore fruits equal to len into bracket fruits. That will give you the number of items in that list. And if you wanted to sort a list in ascending order, all you need to do is say fruits dot sort. That will sort in ascending order, because sort will by default sort will sort the list in ascending order. If you wanted to reverse that order, you say fruits dot sort, and then inside the bracket you say reverse equal true. That will ensure that the list has been sorted in descending order. I can go ahead and demonstrate this in Python. And the first thing we are going to do is get the length of a list. And to do that, let's first declare our list, which contains apple, banana, and orange. And I'll first print this out just so that I show you how it looks like. Fruits. If you execute this, we see our list is apple, banana, and orange. So to get the length, you say length, maybe you can say num underscore fruits. You use the len function and pass the argument, which will take our variable, which is fruits, and we can go ahead and print it. Print num underscore fruits. If you execute this, you get 3. So that's basically the function that you use to get the length of a list. The next thing we can do is that we can actually sort a list in ascending order. So sort a list in ascending order. So to achieve this, you are supposed to use the function sort. So we take fruits dot then you use the function sort, and that's it. By default, that will return a list ordered in ascending order alphabetically. Then we can say, if you decide to print fruits, you realize that it will be sorted alphabetically. And if you run that, by default has been sorted alphabetically, although it was sorted even from the time we so nothing changed because the list was already sorted in alphabetic order. But if you decide, for example, to sort in descending order, sort a list in descending order, you use the same function. You can go ahead and copy these 2 lines, and inside the bracket, the sort function, you have to use the reverse argument and assign it to true. What this will do, it will reverse the default functionality of the sort method, which will ensure that the list has been sorted in reverse order. So the reverse of the default is descending. So if I do this, I execute this and hit Control Enter on the keyboard, you realize that the list has orange, banana, apple. And from this, you can see that the list has been reversed. So it's sorted in a descending order alphabetically. The next thing we can have a look is the reverse function. And the reverse function, all it does, it reverses the items. The last one will become first, and the second to last will become second, all the way to the last item. So we can say reverse the order of a list. And all we need to do is now reverse the list. Remember now our list of items is orange, banana, apple. So we want to reverse this from apple to print out apple, banana, orange. And to do this, we just take fruits dot the function reverse, and you don't have to pass any argument in the reverse function. So when you execute that and print out fruits, the list will become orange, banana, apple. If you continue running this cell, you realize that this will continue changing. For example, if I hit Control Enter again, the list keeps on changing. So basically, that's how you use the function reverse to reverse the order of a list. The next function we can look at is the copy function. And basically, this is used to create a copy of a list. And to do that, we just assign it to a variable called fruits underscore copy, and fruits dot copy. And we can have the function copy without any argument passed in there. So if I run this and print it out, let's see what we get. So if you print the word copy, so you are creating a variable that takes a copy of the variable or a list called fruits. So if I execute this, you find that you're getting the list called fruits, and create another copy called fruits copy. And that's it for the copy. And that's basically the other operations that we can have a look at. These are the most common. There are others. If you remember well, I told you if you just type the name of that list and have a dot and hit tab, you'll see all the functions that are there for lists. You can go ahead and play around with them, how to use them, and you'll be good to go. But if you have any question, just post it in the comment section.
List comprehension is a concise way of creating a new list from an existing list in Python. To create a new list using list comprehension, you can use the following syntax: new underscore list equal to, and then inside square brackets, you specify the expression for items in the old list. You can also use an if clause to filter items in the list.
We can go ahead and have a look at this in Jupyter Notebook. And so can add a cell and have it you can have a comment called list comprehension, and we can use a few examples here. We can create a list that contains the square of each item in a number list. Suppose you have you can have another comment. You can have a comment there. We are creating a list that contains the square of each item in the list. And first, we can declare a variable called numbers. The list will contain the items 1, 2, 3, 4, 5, and to get the variable, another variable, which is the square of these numbers, basically we need to use list comprehension to get the square of this, which means it's just 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So to do that, we use list comprehension. We open square brackets and say we want to get x raised to 2 for all x in the variable called numbers. So basically what this does, it will take all the variables, we say the elements are x. So what you're doing, you're taking x for all x. Maybe this is x1, x2, x3, x4, x5. So you're taking all those x1 to x5 and you get the square. Now that's clear. So this is how you write your statement here is x squared for x in numbers. And you can go ahead and print square. If you print out that, you get another list with 1, 4, 9, 16, 5, which means that all the numbers has been squared. Then the next thing, we can have another example. And in this example, we just want to select even numbers. And you can have a comment, create a list that contains only even numbers from the numbers list. And to get the numbers, what we do, we can say even equal and then square brackets. Then we say you are returning the values of x for all x in numbers if, now this is now a condition that you have to specify for x, if x is divisible by 2. And how to specify that, we say x modulo 2 and we assign it to 0, which means that if a number x is divided by 2, then the remainder is 0. That's one condition to check if a number is even number. If it was 1, then it means that we are looking at even numbers. So I can go ahead and print out this. So print even. What happens is that if I print that out, see, this is the live demonstration is crazy things. You see how I wrote my numbers. I can't even type, man. And I can say numbers, that's the actual variable name. So if I execute this again, I get 2 and 4, which is actually true because we know that our number list has only 2 even numbers. And that's basically it for list comprehension. You can actually do a lot with this list comprehension, and it's an easy way of creating a concise way of creating new lists from an existing list by using list comprehension based on a certain condition. Thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. In this tutorial, we look at tuples in Python. Basically, a tuple is a type of data structure in Python that is similar to list but is immutable, meaning that its elements cannot be modified once it has been created. The first thing we look at is how to create a tuple. And to create a tuple, we have 2 methods. We can either use parentheses or we can use a tuple function. For example, we can use parentheses to create a tuple with 3 elements 1, 2, and 3, or we can create a tuple using the tuple function with 3 elements, but these 3 elements first were in a list, and that list was converted to tuple using the tuple function. We can go ahead and print T1, and we can as well print out T2. So if we decide to do that, execute this, and you can as well execute that. So you see we have two tuples. And the next thing we're going to do is accessing tuples in a tuple that we have created. There are two methods of accessing tuples. If you want to access a single element, then we use indexing. If you want to get a range of elements, then we use slicing. So, for example, we can decide to do this to access the first element of a tuple using indexing. Here, you create a tuple using parenthesis method, and we can print out the first element, which is this one. Remember, in Python, indexing starts from 0. So this will be index 0, index 1, and index 2. So to get this, to get the first element, then we use indexing method. So this one will return the first element. We can go ahead and print that out. And we can also use indexing if you want to access a range of elements in a tuple. And for example, you can do this. We can access a range of elements in a tuple using slicing. And for slicing, you specify the start index and the end index. So remember, since indexing starts from 0, this will be index 0, index 1. So the first element will be 2. And then the last element in this will be 3, which is in index 2, which means since we don't include the end index when slicing, then we are going to get the elements 2 and 3. And we can go and execute that. You get another tuple with elements 2 and 3. And that's basically how you access tuple elements. The next thing we look at is the tuple methods. The first method is if you want to count the number of occurrence of a value in a tuple, then we use the count method. So count method is one of two methods that we have in Python for tuples. So basically what this will do will count the occurrence of 3 in that tuple. A simple count returns at 3. We have 1, 2, and 3. So if we decide to execute this, we get 3, which is true. And the next method, inbuilt method that we have in Python for tuple is if you want to get the index of a number, of a value, then we use the index method. Basically, this will help you in finding the index of a value in a tuple. So in this case, we want to check the first occurrence of the value 3, which is index 0, 1, and 2. So this is index 2. So that's what we expect. We can go ahead and execute that. We get index 2. And basically that's all we have for the inbuilt functions that we can use for tuples. And actually I can even go ahead and show you that. We have our tuple to be t. If you type in a dot and hit tab in your keyboard, you see we have only two methods for tuples. I hope that is clear. So I'll go ahead and just delete that cell. The next thing we are going to look at is how to unpack tuple elements. And you can use tuple unpacking to assign elements of a tuple to separate variables. For example, suppose that you have a tuple with elements 1, 2, and 3. So if you wanted to assign those elements to a single, to individual variables, we use this assignment A, B, C equal to T. Basically what this will do, A will be assigned the value 1, B will be assigned the value 2, and C will be assigned the value 3. So suppose we wanted to print out to confirm if that happens. So that will be, we print out the value of the variable A. We can also print out the variable B, and we can also print out the variable C. If I execute this, you get the values 1, 2, and 3 in that order, because this will be the variable A, B, and C in that order. So basically meaning that the tuple has been unpacked to these separate variables. The next thing we are going to look at is a tuple comparison. Suppose we have several tuples that we want to compare. And suppose now, for example, you have 3 tuples. You have tuple 1, tuple 2, and tuple 3 with different elements. And you wanted to see if tuple 1 or tuple 2, or you can say tuple 1 is less than tuple 2. What we do, we use the common standard, or we use the standard comparison operators: less than, greater than, less than, or equal to, greater than, or less than, or equal to, or not equal to. So to see if tuple 1 is less than tuple 2, we can print that out. We use T1 is less than T2. What this will do, it will just return true or false. Let's see what happens. If I execute that, I get the value, the Boolean true. What that means is that these two elements, these two tuples have been compared element-wise, which means the first element will be compared to the first element of the second tuple. This will be compared to that, and this will be compared to that. If it happens that one of the elements when they're being compared is greater than, then that will be false. If it happens that all the elements except maybe this one is less than this value, then we return true. So normally what happens is that the first element will be compared to the first element of the second tuple, and if it's equal to, then we go to the next pair, 2 and 2, they are equal. If they are equal, then it's gonna go to the third one and compares. And since 3 is less than 4, then it's gonna return true. So that's how you do that. If you wanted to check if the elements are equal, if the tuples are equal, we can use that. Or you might also want to check if the the tuples are not equal. Then if I decide to run this, you find that they're all true. I can change this a bit and say, suppose now we change this to maybe greater than, and execute the cell. You find that it's true, false, true, true, because this has been violated at this point. Because this is greater than this, then it's going to return false. And the next thing we are going to look at is tuple concatenation and repetition. And suppose we have 2 tuples and we wanted to concatenate the 2. Then what we do, we use a plus sign to do that. So to concatenate the 2, we say T3, we are creating a new tuple. T3 is assigned T1 plus T2. So if I execute that and print out, I see that T3 has the elements of T1 and elements of T2. Now, we might also want to do some repetition. You want to repeat the tuple a number of times. So if you want to repeat that, then you can say T4, tuple 4 is assigned T1 repeated 3 times. So let's see what we get. We get tuple 1 repeated 3 times. I hope that is clear. The next thing we are going to look at is tuple membership. You can use the in and not in operators to check if the value is present in a tuple. For example, suppose that you have a tuple with 3 elements, and you want to check if a value 1 is present in that tuple. Then that will basically return either true or false. So in this case, checking that returns a true. Similarly, you might decide to check if a value 4 is in the tuple. So what happens is that Python will come and check if any of these values in that tuple is equal to 4. And if it's not contained in that, then it's going to return, let's see, it's going to return either false or yes. or false or true. And in this case, since 4 is not contained in that, then it's going to return false. And suppose we use not in in our statement. So suppose now we check if value 4 is not in our tuple T. Let's see what we get. We get true. What this means is that 4 is not in T. So we expect, since that is true, the statement is true, then we're going to have Python prints out true. The next thing we are going to look at is tuple iteration. In Python, we have different we call them loops that we can use to iterate over elements of a tuple. In this case, we can use a for loop. Suppose now we have a tuple T with elements 1, 2, and 3. And suppose now we want to iterate through all these lists, this tuple, these elements 1, 2, 3, which takes the index 0, 1, 2. So to do that, we use a for loop. So a for loop is simply written as for items in our tuple T. We want to print all the elements called items. So item. So basically what this will do, it will iterate over these values or the elements in that and print each individually. So if I execute this is what we get. So we have the values or the items in that tuple printed individually, and that's basically how you can iterate through a tuple. The next thing we do is we can look at tuple sorting. And for tuple sorting, we have to keep this in mind. Since tuples are immutable, it means that you cannot modify their elements. However, you can sort the elements of a tuple and create a new tuple with the sorted elements. You cannot change this exact. For example, suppose now we have a tuple with elements 3, 2, and 1. And you wanted to sort these elements in ascending order. So here you have to create a different tuple from these elements, and you make sure you use the function sorted. Sorted will basically sort that list in ascending order, and the tuple function will convert that list into a tuple. And maybe just to demonstrate how that is, I can unpack this. And suppose now I decide to print this sorted T. If I print out this, I get a list. So this will basically convert the tuple into a list. And now you assign that list, you have to convert that list back to tuple. That's why we're using the tuple function. We can go ahead and print out this, the new tuple. So if I print out this, I get the list that has been created by using the sorted function, and I get the list converted back to tuple. The next thing we are going to look at is tuple aliasing. When you assign a tuple to a new variable, a new tuple object is created, and the new variable points to the new object. Any changes made to the tuple through the new variable will not affect the original tuple. Note that in Python, tuple aliasing does not occur. We can demonstrate that. For example, suppose we had a variable tuple t1, and we have another variable t2, another tuple assigned to t1, and we want to check if t1 is equal to t2. So you can print t1, use the comparison operators equal, and t2. If I print this out, you see that it's true, simply because a tuple t1 was assigned to t2. So both of them are the same. And suppose now we make some changes to t2 by assigning it to a different tuple. If now I print out the same T1 to check if T1 and T2 are the same, then we end up getting, if I print this out, you find it's true and false, because any change to T2 does not affect the original tuple. And that's a clear evidence that tuple aliasing does not happen. And the next thing we are going to look at is tuple immutability. As mentioned earlier, tuples are immutable, which means that you cannot modify the elements once they have been created. This can be useful property when you need to store data that should not be changed. However, if you need to modify a tuple, you can create a new tuple with the modified elements. For example, suppose that you have a tuple T1 with the elements 1, 2, and 3, and you want to modify the tuple. How do you do it? So what you do, you just create a new tuple, and you want to change the first element, which takes index 1. So basically what you do, you just change the first element. So it's basically you're creating a tuple with 4, comma, don't put anything there, and then you add. You use plus to concatenate it with now sliced with a sliced tuple, or a tuple that has been sliced from the original one. So in this case, we can get T, and then we use the square brackets, and then we start from index 1 all the way to the end. So you don't have to specify the end index. So if I decide now to print our tuple T, this is what you get. You get, if we execute this, we get 4, 3, 4, 2, 3. And that's basically, you've changed this to 4 and sliced the original tuple to get 2 and 3 and concatenate them to the new, to this tuple which had the elements 4 only. So as we've seen that we've created a new tuple with the modified elements of the original tuple. I hope that is clear. The next thing we are going to look at is other operations that you can perform in Python. So there are quite a few. The first one we can look at is if you want to get the length of a tuple. If you want to get the length of a tuple, so basically the number of elements you have in the tuple, we can just simply print it out. So print length of a tuple. If you want to get the maximum or the minimum, we simply use this function. For minimum, we use min, and for maximum, we use max. Have it there. And if you want to get the sum of all elements in the tuple, then we use the sum function. So these are basically functions that you can use to get all this, and there are very many of them. So if I can execute that, we get this, which means we don't have our tuple, and we can simply create it in a different way. So before this, we can create a tuple by first defining the elements. So first you say x is assigned value 1, y is assigned 2, and z is assigned the value 3. And then now you can create a tuple variable with those variables. So if I create this, then and execute now, we get, these are the values, because you're getting the length. So the length of that tuple is 3. The minimum of x, y, z, of course, we get is x, which has the value 1. And to get the maximum, of course, it's z with value 3. So we return the value 3. And the sum is basically the sum of the 3 values is 1 plus 2 plus 3. And we get 6. So there are so many other things that you can do with tuples, but for now, I think you have all it takes to manipulate tuples in Python. Thank you for watching and for following. Hopefully everything is clear. But if something is not clear, please remember to post it on the comment section. Thank you for watching. See you in the next part of this Python programming tutorial. And please do remember to subscribe to this channel and turn on the notification bell. Welcome back. In this tutorial, we will look at Python dictionaries. Dictionaries are data structures in Python that store data in the form of key-value pairs. Dictionaries are useful for storing data that needs to be quickly accessed using a unique identifier known as a key. For example, let's say you have a list of students in a classroom and you want to store their names and ages. You can use dictionaries to store this information as follows. You can have a list of students in the classroom, and here, to store the information, the keys are the names of the students and the values are their ages, and the dictionary name is students, and the names of the students, Alice, Bob, Charlie, and David, are the keys, and the values are 20, 21, 22, and 23. If we decide to print out the dictionary students, we see we have the keys and the values separated by colon and are enclosed in curly braces, and that's one example of a dictionary. The first thing we are going to look at is how to create dictionaries. To create dictionary in Python, you can use curly braces to enclose comma-separated key values, and the keys and values are separated by colon. For example, we can have an example on how to create a dictionary using curly braces to enclose comma-separated list of key values. So in this case, we have the syntax my dict equal to curly braces, and the key values are separated with commas, and between key and the value there is a colon. And a good example is we may want to store stock prices for some stock, some various stocks, which are Apple, Microsoft, Amazon, and Google, and their corresponding prices. So this is how you do it. You just use the curly braces and define the key and values. And if I print this out, I get a dictionary. We can go ahead and check even the type of our dictionary, which is stock prices. If I execute that, I see that we have a dict, which is a dictionary. There's also another method that you can use to create a dictionary, and that is using the dict construct. So, and to do that, we use a syntax. We use a syntax called using the dict method, where the keys and the values are declared using the assignment operator equal sign. So key 1 is assigned the value 1, and key 2 is assigned value 2, and key 3 is assigned value 3. And that's the syntax. Going back to our example, if you want to use dict to create the dictionary called stock prices, then we just do this. We assign the stocks their corresponding prices and enclose them inside the dict method. So if I print this out, you'll notice that you get the same dictionary. Then the next thing we are going to look at is how to access values in the dictionary. To access the values in a dictionary, you can use keys as indexing. So to do that, this is the syntax we are going to use to access the values in a dictionary using the keys. So here, this is the key and is being used as an index. And here is our dictionary. So going back to our example, we can check the price of Apple stocks. And how to do that, we use the key Apple as our index. And if we execute that, it's going to get the price of Apple. So if I execute that, I get it's 100, which we can confirm is the same as the cost of Apple. You can also use get method to access the value in a dictionary. This method returns the value for specified key. And add a cell. So for this one, to use the get method, Then we use the syntax mydict.get, and then inside get we specify the key we want to get the value for. Going back to our example, we can get the price of apple using the get method. And to do that, we can have this where we specify the key apple inside the get method, and that if I execute this, I'll get the price of apple. And you can go ahead and execute that. We get the value 100, which is the same as what we got using the indexing method using the keys. And then the next thing we are going to look at is how to modify dictionaries. To add a new key value to a dictionary, you can simply assign a value to a new key. And to do that, and go ahead and add a cell. To do that, we use the following syntax, and is mydict, and inside the square brackets, we specify a new key that we want to add, and then we specify the value that we want to assign it. So going back to our example, we might as well decide to add a new stock and its corresponding stock price, and we can add a stock price, a new stock price for Tesla. And to do that, we just need to specify the new key and its corresponding price. If we execute this, we get our stock price. Our dictionary has now included a new key value, which is Tesla, and its corresponding value of 300. That's how to add. Suppose now we wanted to change the price of apple to 110. Remember it was 100. Now we want to change it to 110. So here is where we need to update the value for that existing key. You can simply assign a new value to that key, and we use this syntax and add that. That's the syntax we use to update a value for the existing key. It seems like it's almost similar to adding a new key, but if it doesn't exist, then you add it. But if it happens that it exists and you want to change the value, then you just include it. So the only thing that will happen is that the value will be added, will be updated. So going back to our example, we can update the stock price for apple. So, and this piece of code here will update the value of, or the price of apple to 110. We can go ahead and print out the stock price, and we see the value of apple has been changed from 100 to 110. Then we might also want to remove key value pair from a dictionary. To remove a key value pair from a dictionary, you can use the pop method. This method removes key value pair for the specified key and returns the value. So, and the syntax for that, we can simply assign mydict.pop with the key one specified to value. This will do two things. First, it's going to return a value, and it's going to remove the key one and its value from our dictionary. For example, we can go ahead and have it as an example for you to understand well. So here, we are removing the stock price for Amazon by using the pop. So what this will do is going to generate the value or the price of Amazon and print it out. So we can go ahead as well and print out our stock price to see what happens. Remember, this is our current stock price dictionary, and when I execute this, we'll see what happens. We'll see the price. So here we have two things. The price of Amazon, which was 200, and it's going to remove the key value for Amazon and its corresponding price from this from the dictionary, and you can see Amazon has been removed. Also, you can use delete keyword to remove a key value pair from a dictionary, and to do that we use the following syntax. So we use del mydict, and then we specify our key here. So we want to delete the key value for key 2 and its corresponding value, and that's your dictionary. So we're going to use an example to demonstrate that. And in this case, we are going to remove the stock price for Google. So in this case, all we need to do is use the key Google as the index, and we have the delete keyword here. And if I print this out, you realize that the Google and its corresponding stock price has been deleted. You can go ahead and print that out. And as you can see, we don't have the stock price for Google anymore because it has been deleted. And that's it for deleting key values. Then the next thing we are going to look at is the built-in dictionary methods. And these methods, we can have a look at them here. For example, we have our stock price as our dictionary. If you type a dot and you hit tab on your keyboard, you will see all the methods that are available for you to use when you are dealing with dictionaries. We have clear, which can be used to clear all the key values. We can create a copy of a dictionary. We can do from keys, get, items, pop items, set default, or update, or get the values. So in this case, we can go ahead and try out a few that are most common when you're dealing with dictionaries. And the first one that we are going to look at is the keys. And for keys, basically what keys method will do, it will just return a list of all keys in the dictionary. For example, in our case here, for the stock price, it would go ahead and return Apple, Microsoft, and Tesla. And again, we can use another method called value. For value, what value will do for you, it will simply return a list of all the values in the dictionary. We can use an example instead, or a syntax instead. So for the syntax, this is how the syntax will look like. mydict.values, that is the method values, which will automatically return list of all values in the dictionary. The next one we can have a look at is the items. In any dictionary, we have two main items, which are the keys and the values. In our case here, the method items will return a list of key value pairs in the dictionary. Then from there, we look at another thing called the len function. The len function, we've used it severally for other data types, is simply used to return the number of key value pairs in the dictionary. And to further understand this well, we can go ahead and use several examples. And to use the keys method, we can use it to return all the keys in the stock prices dictionary. And since we know that our keys are the names, we can assign the keys to names. If I execute that, you'll see that we have dicts keys, which includes key, Apple, Microsoft, and Tesla. So those are the keys. The next example, we can use the values. We can get all the values in our dictionary named stock prices. So if I execute this, I get the values 110, 50, and 300. And those are the corresponding prices for Apple, Microsoft, and Tesla. So the next example we can have to further demonstrate these methods, we can have the items method. And for items, we are going to get the key prices, the stock prices, the stocks, and their corresponding prices. They'll come in pairs. So if I execute this, you see we get dict items, Apple, comma, corresponding price, Microsoft and its corresponding price, and Tesla and its corresponding price. And something interesting here is that overall, that is a list of the key pairs. And the key pairs are an example of tuple, because you see tuples are enclosed in these parentheses, while lists are enclosed in the square brackets. The next example we can look at is the len method. For the len method, as mentioned earlier, is used to get the number of stocks in the dictionary. So in this case, you're going to get the length of the stock price. So if I execute this, I get 3, which is actually true, because after all the manipulations that we have done to our dictionary stock prices, we only have 3 stocks: Apple, Microsoft, and Tesla. And that's basically it for Python dictionaries. And as you've seen, dictionaries are a powerful and useful data structure for storing and organizing data in Python. With the knowledge you've gained from this tutorial, you should be able to use dictionary effectively in your Python code. But if you have any questions, do not hesitate to post them in the comment section and I will reply to them. Thank you. Thank you for watching. See you in the next video of this Python programming tutorial series. Please remember to subscribe, like, and turn on the notification bell. Welcome to this comprehensive tutorial on control structures in Python. Control structures are a fundamental part of any programming language, and they allow you to control the flow of your code. There are 3 main control structures. The first control structure we're going to look at is the if-else statements. They are used to execute a block of code based on whether a certain condition is met. The syntax is very simple. It has 2 parts, the if part and the else part. In the if part, that's where we specify the condition and we write the code that we would like to execute if the condition is true. We write it here. And if the condition is false, then we write our piece of code here that we would like to execute. We can do a few examples in Jupyter Notebook to demonstrate how to work with if-else statements. We can use 2 examples. The first example, suppose that you have a variable x and you wanted to check if the value of x is greater than 3, then we can do the following. That's our example. If suppose now you have the value of x to be 5 and you want to check if it's greater than 3, then we use the if statement. If x is greater than 3, then what do we want to do? We want to print out the value of x to be value of x is greater than 3. The condition will be checked. If it's true, this will be printed out. But if it's not true, then we print the else part. The else part will do the opposite of whatever happened here. Or you can specify a different piece of code. But in this case, we just want to check if it's true or not true. So we print out x is not greater than 3. If we execute this, then we see that x is greater than 3, which means this has been executed. The reason for that is that the condition was checked and it was ascertained that this is true. Given that it's true, this piece of code will be executed, and that's why we got x is greater than 3. Suppose now we had our value of x to be 2. Let's see what happens. If I execute this, I get x is not greater than 3. The reason for this is because the condition was checked and we have is 2 greater than 3. The answer is no, which means that this will return false, which means the second part will be executed and hence x is not greater than 3 was printed out. I hope that is clear. And there's also some instances where you'd like to check more than one condition. For example, suppose that you had a number or the variable x with a certain value, and you wanted to check if the value of that variable is greater than 10. If it so happened that it's not greater than 10, it's less than 10, then check another condition, which is check if it is greater than 3. So there are two layers. First, check if it's greater than 10. If true, then we are going to execute something. If it's not true, we check if it's greater than 3 and do something else. If those two conditions are not met, then automatically say it's not greater than 3. So the first thing we need is our variable x is assigned the value, let's say 6. So we want to check the first condition. So we say if x is greater than 10, then what do we want to do? We print out that the value of x is greater than 10. If that is not true, then we use the keyword elif, which stands for else if. Else if x is greater than 3, then what do? We print out that the value of x is greater than 3, but not greater than 10. What if now these two conditions are not met? Then we use the else component. The else component will mean that if these two have not been met, then it means that the value of x is less than 3, or we can simply say it's not greater than 3. So we print out x is not greater than 3. Let's now check what we get if we execute the cell. We see that x is greater than 3, but not greater than 10. Suppose now, instead of having 6 as the value of x, what if we had 2 and we execute? We get x is not greater than 3. The reason for that is that the else part has been executed. And what happened, what Python did is that it came here, replaced the value of x to be 2, and checked the condition. Is x greater than 10? Of course, it's false. So, because it's false, it goes to the next condition, check the next condition. So, it came to replace x here, checked if 2 is greater than 3. Is it true or false? It's false. So, has to go to the next block. The next block of which you have x. So, whatever happens, if that is not met, then we have to execute. This is the third part, of which now we return x is not greater than 3. So, suppose now, instead of 2, we had something like 14. And so what will happen here, in this case, before I even execute the cell, I'll come and check, is 14 greater than 10? Yes. So if it's true, then it prints out this. And it doesn't check any other condition, because the first instance where the condition was met, that's when it executed the code. So we can confirm that, and we see that x is greater than 10, which means the condition was met at the first instance at the if block. And that's it for if else. The second control structure we are going to look at is the for loop. It allows you to iterate over a sequence of items such as a list or a string. The syntax is as follows. We use the keyword for, then we write the item in sequence, and then we write a piece of code that you would like to execute on each item in that sequence. We can look at this in Jupyter Notebook. To demonstrate how to use for loops in Python, we can use several examples. And the first example I'm going to use is how to loop over a list. Suppose that we have our list called my list and has the numbers 1, 2, all the way to 4. And it's a list because it's enclosed in square brackets. Suppose now we wanted to loop over, or rather we wanted to print out 1, 2, 3, 4 in that list. Now, what we do, we use a for loop. And to use a for loop, we can say for items in my list, what do you want to do? You want to print the items in that list. So what this will do, I'll go to that list, and for the items can be anything. Can be anything inside that bracket. So for each item in that list, print that item. So if I execute this, you get 1, 2, 3, 4. So came here, took that item, which is 1, printed it out, then looped over to the next item and printed it out all the way to the last one. So that's one example how to loop over a list. you can also use loops, for loop to loop over a string. So suppose that's our comment. It's good to add some comments. Suppose we had a string called my string, and the string is maybe hello world, maybe exclamation. And now we wanted to loop over this piece of text or string. So here we use the same thing. You can say all the characters in that word are called char. Each is called char. You can call it anything. You can say it's X, I, whatever you want to call it. But in this case, I say for the characters in our string, what do you want to do to them? We want to print our individual character called char. So if you go ahead and print that out, we get hello world. So it prints on individual lines. And that's another example. Suppose now, instead of string, we wanted to print out numbers, maybe between 1 and 100. There are several ways you can do that, but the best one you can do is loop over a range, a specific range. So this function here, range, it just says the range. If you put a number maybe like 5 here, what this will do is just in Python will understand what you mean. It's numbers from 0 to 5. So we can loop over that range from 0 to 5. And we can say for I representing the integers between 0 and 5. So we say I in, then we use the function range and say we want to print up to 5. Let's say something like that. And then we use colon at the end and then hit enter. And please note this indentation. If you just put here and hit enter, it will automatically create you proper indentation. So you have to hit enter while your cursor is immediately after the colon. If you click enter, you can now write the piece of code you want to write here. So you can say print, maybe we print our items which are i's. So it's I from 0 to 5. If I print this out, we get 0, 1, 2, all the way to 4. And the reason we are printing it's like we are printing from 0 to index. So we don't print out the fifth option. We are printing 5 elements, 5 items beginning from 0. So basically we printed out 0 to 4. There are 5 in numbers. So it's like we are printing out a range of 5 numbers. If we can change this to 10 and execute that, we get 0 to 9. So here you specify the number of numbers that you want to print out. If it's 100, it's going to print out 0 to 99 because Python starts counting from 0. That's why it's doing that. And then also we can loop over another data type like Python dictionaries. And that's a very good example, in fact, looping over a dictionary. Suppose now you had a dictionary called myDict and this is the key and the value. It has several key values pairs. And just a recap, for dictionary, the key and the value are separated with comma, and those pairs are separated by commas. So suppose now you wanted to loop over this and get the items in that dictionary. So what we do, we use a for loop, and in that for loop, we have to specify 2 things. So it's for, then we want to print out the key and value in that dictionary. So there's one function that's applicable for dictionaries called items function. And so here you want to call your function, which is myDict.items, and then you open and close the parentheses and no arguments in there. Don't add any argument inside the brackets, the parentheses, and hit enter. Make sure that your cursor was right after the colon so that when you hit enter, you get proper indentation. And what do you want to do? You want to print whatever you got here, the key and the value. And so we print key, comma, value. So we can go ahead and execute that. And what we get the key and the values printed out one at a time. So what it did, it came here, looked for items for key and values, the key and value in the first instance, it just printed it out there. Then it looped to the second pair of key and value and printed out banana and 2 key and value basically all the way. Even if you had 100, that's the same loop. It's gonna loop to all the key value pairs. Hope that is clear. And we can also do something else with we can also loop for the values. For the dictionary, you can also get the values alone. You have our dictionary. Suppose now you only wanted to get the values. You can do that. And instead of items here, you have values. And then here, you have value and execute. So you get the values 1, 2, 3, 4. Suppose you wanted maybe the keys alone. So if you wanted the keys, you change this to key and then these to keys. Those are just methods that you can use and then print out the key. If you print that out, you get banana, apple, banana, orange. So basically you just printed out the keys. You can basically do most things with the for loop. Yeah, so hopefully everything is clear. You can play with all these examples and make sure that you're typing them out, because that's the only way you can learn how to code well. So that's it for the for loop. The last control structure we are going to look at is the while loops. While loops allow you to execute a block of code repeatedly as long as a certain condition is met. The syntax is as follows. We write the keyword while, and then we specify the condition that you want to check. And here is where the piece of code that you want to execute while the condition you specified here is true. We can look at this in Jupyter Notebook. To demonstrate how to use while loops in Python, we're going to use an example. And suppose you wanted to print out the numbers from 0 to 9. To do this, you can of course use a for loop, but we want to use while loop. The first thing you do, you initialize the value of x to be 0, and then we want to print a number for as long as the value of x is less than 10. So that's the for loop condition, while loop condition, and we want to print the value of x. But then if I do this, we need to have a way of incrementing this from 0 to all the way to 9. So what we do, after printing the value of x, which at this point it's 0, the initial one, then we need to increment by 1. So we say is x, you add equal 1. So this was it's just doing this. You can just write here. It's just taking the value of x, assign it to x plus 1. This is what it does. So this has been this is the best way of writing it. So after doing that, if we execute this, we get the numbers from 0 all the way to 9. Remember our initial value was 0. So what the while loop did, it checked 0 against 10 and ascertained that the value of x is less than 10. Hence, it printed out the value of x to be 0. Then it looped again. After printing it out, it incremented the value of x by 1. So our current value of x is 1. So came here, checked the condition again. 1 is less than 10, true. It prints out the value of x and increment x by 1 all the way to 9. But at the point where it prints out 9, at the point where it prints out the value of x to be 9 and increments it by 1, so we have the current value to be 10, then what happens is that it checks, is 10 less than 10? It's false. So the while loop breaks, and that's it.
So at the end, it just prints out the values of x to be 0 to 9. But as we have seen, it's checking this condition. It's checking if the condition is true. If it happens that the condition is true, it will continue doing something. So for example, assume we had another, we decided to do this. You can have the same code, but instead of this one, assuming that we write this to be true. So if I try to print this out, let's see what happens. So what it does is start printing out the values. So it's infinite loop. It doesn't stop because the condition is always true. So what we do here in this case, we can interrupt the kernel by simply clicking on kernel and interrupt. That will basically stop the kernel, and the execution of that piece of infinite code will stop. So as you have seen, that it's very important to have an exit plan because something can go wrong. And to ensure that nothing goes wrong, we are supposed to use an if condition and say if x is greater than, maybe let's say 10 or 9, then what do? We break the code or the execution. And that's basically it for that. So once you insert the break, and if you decide to click execute, then you see that we are printing out 0 to 9. And that's another way you can use to print x, the value of x being 1 to 9. And if the condition is always true, then we need to have an exit plan by using the break command, which will stop the execution of that piece of code here. This is the piece of code that will execute for as long as this is true. And since we've already declared the condition to be true, then we need that break. And that's it for the while loop. And that concludes this tutorial on control structures in Python. If you have any question, please do remember to drop a comment, and I'll get back to you with the feedback. And please do remember to subscribe, like my videos, and leave comments. Welcome to this video tutorial on Python user-defined functions. Function is a block of code to perform a specific task. Python provides many built-in functions like print, len, etc. But you can also create your own functions. These functions are called user-defined functions. In Python, a function is defined using the def keyword, followed by the name of the function and a set of parentheses that may include parameters. The block of code inside the function is indented. Here is the basic syntax for defining a function in Python. You start with the def keyword, followed by function name. Then you open parentheses. You type your parameters. And after that, you close the parentheses, followed by colon. And once you hit enter, you make sure that you have an indented block called the function block, where you type in the statements that you would like to execute when you call the function that you've created. Below is an example of a simple function that takes a name as the parameter and prints out a greeting. Here we have the keyword def and greet, which is the function name, and inside the parentheses we have our parameter, which is the word name. The function will print the word hello and then name and exclamation mark. For example, if you try calling the function greet and you pass an argument called John, it's going to print out hello John. To return a value from a function, use the return statement. Below is an example of a function that takes two numbers as parameters and return their sum. We start with our usual def keyword followed by the function name. In this case, we call it add, which takes two parameters a and b, and the output we use the return keyword followed by what you want that function to do, which is add a plus b. If you want to call that function, then we assign the output of that function to a variable called result, and to call the function itself, we say add, which is the function name, and inside the parentheses, we pass the arguments.
and the arguments in this case is the number 3 and 4. So the expected results for that function would be 7. You can define a function with optional parameters by giving them default values. If a default value is provided for a parameter, the caller can choose to omit that argument. For example, we can define a function called greet, which takes the parameters name and greetings. But in this case, our greetings has been assigned a default value called hello. The function will print greetings, comma, name, and exclamation mark. So if, for example, we call the function greet and pass argument John, which is just the name, then it's going to print hello John. The reason is because it took the default greeting, which is hello, and the name of John that has been passed as argument and printed out hello John. On the other hand, if we print greet, we call the function greet and pass the argument John, which is the name, and pass another argument for greeting, then we'll print out hi John. The reason, the default value of greeting has been replaced with hi, and that's why it printed out hi John. We will now look at several examples involving Python user-defined functions. In this example, we will write a function that takes a list of numbers and returns the largest number in that list. The first thing we will do, we'll define a function if find largest, which takes the parameters numbers, and the first thing we'll do, we will set the initial largest number to be the first element in that list. So we can say largest is numbers index 0. And then we want to iterate through the rest of the numbers and check if any of those numbers is greater than our current largest number. So we use a for loop. We say for num in numbers. What do we want to do? If any of those numbers, or if num is larger than the current largest number, set it to be the new largest number. To do that, we use a if statement. So we say if num is greater than largest, what do? We assign that num to be the largest. So we say largest is now equal to num. And the loop will continue doing the same, checking one number at a time, comparing to the current largest number. And then once it finishes, it's going to return a certain value. So here is where we return the largest number after the for loop has ended. And here we use the keyword return keyword, and we return the largest number. So as you have seen, we've created a function called largest that takes in parameter called numbers, which is basically a list of numbers. And then we set the first number in that list to be the largest. And then now we check using a for loop if any of those numbers is greater than our current largest number. And if any of them is larger than our current number, then we assign that number to largest. We can go ahead and run this, make sure that we've done the correct thing. And then the next thing we want to do is we want to call the function. And how to call the function? We write the name of that function, which is find largest, and open parentheses and close, and then we pass in a list. We can try 1, 2, 3 and see what will be the largest number. So if I run that, I get 3, which means that it's returning the maximum in that list. We can try another example. We call that function find largest. Once we find the largest, and then we pass in a list, we can say 10, 20, maybe 5, and then maybe 50. Let's see if it's going to return 50 as the largest number. Wow, we're getting the largest number to be 50. And suppose now we pass some negative values in there, what happens? So if we say find largest, and then we pass some negative values, -5, negative maybe 4, -60, and maybe 0. Let's see what we get in this case. So if I execute that, I get 0 to be the largest number. So our function is working well because it's just giving us the maximum in that list. Actually, we might be able to modify this using the functions that we already have in Python. For example, you can just copy and paste this here, insert a new cell. Instead of having all this, we can get rid of all this and just use a return. And then here, we can simply say return max of numbers. So if I execute this again and insert a cell and check, I can use the same example I used here. And if I call that function now, this, which is very short, what do we get? We get 50. So basically, this one is a longer version, but in programming, it's so much better to be lazy and just use a simple way of doing things. We just use 2 lines to declare that variable, which will give us the maximum in that list, as opposed to using all these lines. In this second example, we will write a function that takes a list of strings and returns a new list with all strings in uppercase. To begin, we define a function called to uppercase and takes the parameter strings, and the first thing we'll do is we will initialize an empty list that we are going to store the uppercase strings. So what we do is say upper strings, we assign it an empty list. Then the next thing we do, we'll iterate through the list of strings using a for loop. So we can say for s, let the strings in that string be called s in our list of strings. And for each s, what do you want to do? We want to convert them to uppercase. And after converting them to uppercase, we append them to the list that we created, the new list in this case. So to achieve that, you'll say our new list is called upper strings, and we want to append. We use the append function, and then for each string in that list of strings that we'll pass to the function, we convert them to uppercase. And to convert them to uppercase, we use the function upper. So that's why we are saying s.upper. Then after we convert them to uppercase and append them to the new list of strings, then we need to return the list of uppercase strings after the for loop has completed. That's why we need to make sure that we are outside that loop. And to make sure that you are outside the loop, we check the indentation. It should be in the same indentation as the for loop. And here is where we use our keyword return, so that you can return the upper string, which is the list of the new uppercase strings. And basically, just like that, we have created our function that will take list of strings and return a new list with all strings in uppercase. And we can go ahead and call the function. We execute this function that we've created, and we call it in the next cell. And we can use a simple example as ABC. So to call it, that's the name of our function. And then here is the list that we've passed as an argument. So we have that list in there, and we expect our function to convert it to uppercase. And let's see, moment of truth. Yes, has been converted to uppercase. All of them have been converted to uppercase. We can try another example that can convert towards hello and world to uppercase. So you have that. If you execute that, we find that everything has been converted to uppercase. And now we can also have another example, but for this example, I want us to make some sort of adjustment and write some numbers in between, maybe those strings. If I execute this, you realize that everything else has been converted to upper, but the numbers just remain the same. Thanks for watching and see you in the next video. Please also do remember to subscribe, share, and like my videos. Welcome to this tutorial on advanced control structures in Python. In addition to the basic control structures, Python has some advanced control structures that can be used to control the flow of execution of a program. The first one that you are going to look at is the try and except statements. The try and except statements in Python allows us to handle exceptions, which are errors that occur during the execution of our programs. Some of the exceptions may include, the first one is a zero division error, and this one will only occur if you try to divide a number by zero. You can go ahead and have an example. For example, if you wanted to declare a variable called x and the value is 1 divided by 0. If you try to execute that, you get an error. The error that you get is a zero division error. The next error we can have a look at is the type error. And this error occurs if you try to perform an operation on incompatible types. And for example, you might decide to create another variable called x, and you take a string, add 5. We know that that's not possible to add a string to an integer. So if you try to run that, we get type error and says can only concatenate string, not integer, to string. The next error we can have a look at is the name error, and this exception will only occur if you try to use a variable that has not been defined. For example, so far we have not declared a variable called y. So let's see if you try to print that variable called y. You get name error, which says name y is not defined. Another exception is called the index error, and we can have an example. Suppose we have a list maybe called my list, and it has maybe the elements 1, 2, 3. And as you can remember, we always start counting from index 0. So which means this is index 0, this is 1, and this is 2. Suppose now you wanted to get index 3. What happens? We don't have the index 3, but you want to call it anyway. So what you get is an error message, and the name of that error is index error, and says list index out of range, because you're trying to get index a list that only gets to index 2. So that's when you get that error. The next error you get here, you can get from Python program. It's the one called key error. This is associated to dictionaries, and for dictionaries, suppose you have a dictionary called mydict. It has a key called A and B, and they have the values 1 and 2 respectively. Suppose now you want to get some values for a certain key, and then suppose now you want to get the key, the value for a key called C. If you try to execute this, you get a key error because we do not have a key called C in that dictionary. And the next thing that you can, and the next exception that you can get is called the value error. And suppose you wanted to convert string to integer. Let's just try this and see. You get value error because you're trying to convert string to integer, which is not possible. That's why you get the error called value error, and it says invalid literal for integer with a base of 10. So 2 is not an integer and can never be converted to integer. So, and that's basically a few examples of exceptions. Now the biggest question is, how do you handle these exceptions? And to handle the exceptions, that's when try and except statements come in. So for example, if we wanted to handle specific exception that might occur in your program, we use the try block. Suppose you have that and you have 0, maybe something like you have a number that's being divided by 0. You're trying to declare a variable which takes the value of 1 divided by 0. So we know that we'll get a division by 0 error. So what we do, we need to handle that exception, and we have to declare another block called except 0 division error, because we know we are going to get that error. And in that block, that's where you write the error message that you want to display. And in this case, we want to print out error message saying error division by 0 is not allowed. And so from these two blocks, the try and except block, we see that the try, that's where the code goes, the one that you feel like that can generate an error. And in the except, that's where we print out the error message. So we can try to execute this, see what we get. We get the error division by 0 is not allowed. In some instances, we might want to handle multiple exceptions. And to do that, there are two ways to do it. So the first way is by using the following piece of code. Here, in the try block, you might have two sets of code that might generate different exceptions. In our case here, we are trying to convert a string to integer, which means we are going to get an error, the value error, and also we are trying to divide by 0. So because we want to handle both of these errors, then we use in the except block, we use a tuple and include both errors in there and print out an error message saying errors, an exception has occurred. So for example, if I try to execute this, automatically I get error, an exception has occurred. The other way you can handle these exceptions, different exceptions, we can use two separate except blocks. And in our example here, we are trying to convert an integer is a string, but with a digit 5 or integer 5 enclosed in that string. So this one is possible. We can convert a string as long as it's a digit enclosed in the quotes. We can convert it to integer. So this one is not going to generate an error. So if I try to execute this, given that I have to accept blocks, one meant to handle the value error and another one supposed to handle division by 0 error, we are going to get, if I execute that, I get error division by 0 is not allowed, which means this error didn't occur. So we only handle the second part. Suppose now we had something like our original foo string. If I try to execute this, note what happens. I get the first error message, which means because we had two error message happening, two type of errors happening, only the first one was handled and the second one was not handled. So suppose we only had one error, which is the value error. Suppose we had this to be, let's say we had this to be 3, which means we are not going to return the division by 0 error and execute. We still get the first error. Suppose now we had this to be 5 and this to be 0. Let's see what happens. If I execute this, I get error division by 0 is not allowed, which means given that the first error didn't happen, this was ignored, but the second error was handled here in the second except block. So as you have realized, if you have both errors happening, only one error will be handled using this piece of code here. So to be sure that you're handling both, then we use this except block. We use the except block with both errors represented in the tuple, but you cannot have a specific error message for them. You only have a general error message. So if this happens, then you have to go back to your code and see which specific error happened. So, which means this can now handle both errors, but this is only able to handle one. And this is very important since suppose you wanted to have someone input some values. Maybe this was a value and this was a value that has to be input. And we are not sure at the point of designing the code if someone will actually type something that doesn't, something that might generate an error. That's why we can have these two. But this will not work if two errors occur. And as I mentioned earlier, we have different type of errors. So to handle any of them, we use this. We have to specify whatever you want to check in the except block. Now suppose none of the errors occur. It means that you want your code to do something. If there's no errors and you don't have to handle any errors, then it means that you need something to be done after that. And that's where we can add two kind of blocks. There's one block called else block that will go with try, except, and then you can add, after except block, we can add else block. And I'll explain that using an example. Suppose you wanted to convert an integer to a string to integer, and there's no error. Or for example, I can say, I can choose to write full. If I execute this, I get an error, which means that I have to handle. But what if now this was 5 and the string 5 was actually converted to integer, meaning that there's no error to handle? That means that you need to do something else, which is we are supposed to use else block. And what else does, you can specify a block of code that should be executed if none of the errors occur. So in this case, if I execute this, you'll see that the input value is valid, which means the else block was executed. I hope that is clear. Now, suppose that you wanted to specify a block of code that should always be executed regardless of whether an exception occurs or not. Here, we use the finally block. I'll use an example to demonstrate that, and can use the following code. So what this piece of code will do, suppose you have an error that we expect to happen or to occur, and is a 0 division error, and it's being handled in this except block. And even if the error occurs or not, we still want to print out or to execute this piece of code. Finally will allow us to do that. For example, if I execute this, and note that there's an error that will occur. If I execute that, I get this printed out. Error division by 0 is not allowed, and this is also printed out. This code will always be executed regardless of whether an exception occurs or not. So that's in the situation where the error had occurred. But in the case where maybe assuming that the error didn't occur, we can change the 0 to 3, meaning that this operation is allowed. If I execute that, I only get the finally block being executed, which means it's prints out this error message, which is this code will always be executed. So as you have seen, a finally block will be executed regardless. And I hope that is clear. The finally block is useful for cleaning up resources or performing other tasks that should always be done regardless of whether an exception occurs or not. For example, you might use the finally block to close a file or a network connection that was opened in the try block. For example, assuming here you're opening a file saved in maybe a certain directory in your computer, and you expected that an error might occur. Maybe you wanted to open it and do some operations or write some materials, write something in the file, only to realize maybe there's an error. If an error happened, you still want to close that file. So that's where finally block comes in, because either way, whether the error occurred or you're trying to write the file, you still want to close it. So we use the finally block. Hopefully that is clear. The next thing we are going to look at is the break and continue statement, and have it as a heading. So the break and continue statements can be used to control the flow of a loop in your Python program. And the break statement is used to exit a loop prematurely, while the continue statement is used to skip the rest of the current iteration and move on to the next iteration. I can use an example. I can have a code here. I can add a cell. Suppose now you want to use break to exit the for loop. What this will do, the output for this would be, for this code, would be the numbers 0 to 4. Since the break statement will cause the loop to exit when the value of I is equal to 5. And we can actually execute that to see. So it prints out the value of I is equals to 1, 2, 3, 4, 0, 1, 2, 3, 4. But when it gets to 5, when the value of x is equals to 5, or the value of I is equals to 5, then it breaks the loop, and that's it. Another example of how to use continue, we can also use an example. And for this example, what you're trying to do is print out even numbers from 0 to 9. So what this code will do, it will print out even numbers 0 through 8, since the continue statement causes the loop to skip the rest of the iterations when I is odd. And if you can remember, this operation, this is the modulo, and what it does, it just checks if there's a remainder when a number is divided by 2. And as we know that odd numbers are not divisible by 2, and it means that they will always leave a remainder of 1. So this condition is just checking if the number is odd or not. So if it happens that the number is odd, then continue will skip to the next iteration. Now when the value of I becomes even, meaning that this will be violated, then the value of I will be printed out. So that's it for the break and continue. The next thing we are going to look at is the pass statement. For pass statement is just used as a placeholder when a statement is required but no action needs to be taken. For example, you might use a pass statement as a placeholder in a loop that has not yet been implemented. For example, suppose you wanted to do something with a range from 0 to 9. The reasons why I'm saying 0 to 9 is that this is 0 to 10, but in that range, this is not included. 10 is not included, meaning that since it starts from 0 for 10 items, the numbers that we want is 10, but starts from 0, so it's 0 to 9. And you just write this pass will act as just a placeholder for a future code. You can now decide to come and write something like this, a piece of code here. So this is just acting as a placeholder. This will be executed, but there's some sort of operation that is required, but no action is required at this moment. So this can be left there to act as a placeholder. And so you can say being used as a placeholder in a for loop. Also, this can also be used in a try except block. For example, you might have something like this, a try where a number is being divided by 0. We expect an error. But at this point, when you are writing this piece of code, we are not sure what you want to add here. So you want it to occur, but you're not sure what you want to have at the moment. You know there is an error, but you're not sure what you want the code to do. So you just leave the keyword pass to act as a placeholder for future exception handling code. So I hope that is clear for pass. So basically, we say that the pass statement is often used as a placeholder when developing code and is later replaced with actual code as needed. And that's it for this tutorial on advanced control structures. Just a recap, in this tutorial, we covered some advanced control structures in Python, including try and except statement for handling exceptions, break and continue statement for controlling the flow of a loop, and the pass statement, which act as a placeholder. These control structures, as you've seen, can be very useful in Python programming and can help you write more robust and efficient code. And what I would urge you to do is please try and practice using these control structures in your Python programs to get a better understanding of how they work, and that will be super helpful for you. Anyway, thank you for watching, and please do remember to subscribe, comment, and like my videos. Welcome to this YouTube tutorial on NumPy. In this video tutorial, we will be covering the basics of NumPy and how to use it for numerical computations and array manipulations in Python. NumPy is a Python library for working with large multidimensional arrays and matrices of numerical data. It provides efficient operations on arrays and matrices and includes functions for performing mathematical operations, linear algebra operations, and it provides integration capabilities with other libraries. It also includes tools for array manipulation, indexing, and reading and writing data to and from files. To use NumPy library in your Python code, you need to import it first using import statement and assign it to a short alias such as np. For example, you can use import NumPy as np to import the library and use the alias np to refer to its functions and classes. Creating NumPy array can be done in several ways. The most common method is to use the np.array function, which takes a list or a tuple of values and returns an array. For example, in a new cell in Jupyter Notebook, you can create one-dimensional array by passing a list of values like this. So that's the list of arrays, list of numbers. So just pass it in that function, np.array function. Then, and you can print it, execute to get that is the one-dimensional array. To create a two-dimensional array, you can pass a list of lists of values like this. You can have, this is a list of lists. So you have one list, second list, and the third list, all in a list. You can go ahead and print it this way. Print B, you execute, you get a 3x3, 3 rows and 3 columns. And similarly, a three-dimensional array can be created by passing a list of lists of lists of values like this. You can have add a cell and you can have that. So basically, it's like a list of 3x3 dimensional arrays. So it's a list of lists of lists. So you have 3 square brackets enclosing that, and inside the second bracket, square bracket, we have this list, and it has 2 of them, this one and this one. Hopefully it's clear, and you can print it as follows. Print say. So if I execute that, you see you have 2 3x3 arrays. So the first bracket represents a 3-dimensional array. If it's true, this second bracket only represents that, and this bracket here represents that 2-dimensional array. You can also create arrays of specific shapes and data types using np.zeros, np.ones, and np.empty function. For example, you can create a 3x3 array of zeros by typing np.zeros and pass a tuple 3x3, and then you can print it out by printing print D. If you execute that, you get a 3 by 3 two-dimensional array with all the values being floats, 0, and the data type is float. To create an array of ones, you can use np.ones, similar just the way we did for zeros, and just change this to ones. If you execute that, you get everything to be ones, and it's all floats. You can also specify the data type of the array, like instead of having, we can pass a data type in here. For example, you can pass a data type immediately after the tuple, you put a comma, and then you do that. So this will specify the data type, what you want to be displayed in that array. If I execute this, as you can see, everything has been converted to integers. Additionally, you can create arrays with evenly spaced values using np.arange function. For example, if you wanted a one-dimensional array containing only even numbers between 0 and 10 without including 10, then we use this function arange. The start index is 0 and the end index is 10, and you specify the size of those steps as 2. So 0 will be included, then 2 all the way to 8. 10 will not be included. So we can go ahead and print these out. If I print f, what I get is a one-dimensional array with everything being even. The NumPy library provides several other functions for creating arrays, such as array function, which can be used to convert inputs to NDA array, but it does not copy the input data if it's already an NDA array. The empty and the empty-like functions are used to create new arrays by allocating new memory, but they do not populate the arrays with any values like ones and zeros. The I and identity functions can be used to create square n by n identity matrix. You can check the dimension and shape of an NDA array by using ndim and shape attributes. For example, suppose you had a function f that is created using np.ones is a 3 by 3 matrix of the type integer. If I can go ahead and print this f, if I do that, it's a 3 by 3. To check the shape, all we need to do is call our NDA array f and then write the word shape. So this will just check the shape. If I execute that, I see that I get as a 3 by 3. Suppose now I wanted to get the dimension. What is the dimension of this? We use the function, the attribute ndim to get that. So we get it's 2 dimension. You can access elements of NumPy array using indexing and slicing, similar to how you would access elements in a Python list. For example, if you have a one-dimensional array, A assigned as follows. A is assigned np.array and has 5 numbers in a list. So we can go ahead and print that first. Print A. We see that it's a 5 elements in that array. You can access the first element of the array by using indexing, like you can use print A, and then inside the square bracket you specify index 0, which will get the first element. So if I execute that, I get 1. And suppose now we wanted to get a range of elements in that array, we can use slicing. And suppose that we wanted to get these 2, we can use slicing, and to get the slicing, we use and add a new line. So here we are getting from index 1 all the way to 3, but not including 3. So this will print out 2 and 3. That's one-dimensional array. Suppose now we had two-dimensional array, and the dimensional array has two rows and 3 columns. We can add a new line or a new cell. You can go ahead and print this just to see how it looks like. So that's B. You execute. Now, for you to get a specific element in a two-dimensional array, then we use column and row indexing. And to do that, we can access, for example, the first element in the first row and first column by simply using this. You specify the row and the column. So if I execute this, I get 1, which is in position 0, 0, meaning that it's row 0 and column 0. And suppose now we wanted to get a range. For example, you can use slicing to access a range of elements in a specific dimension, such as, suppose we wanted to get this. This is row 0, and then we want to get in that row 0, which is this one, we wanted to get the elements in index 1 and 2, because 3 is not included there. So this is what we use. We use 0 to represent the row and this to represent the column. So if I execute this, I get is 2, 3. So basically we've been able to get that. Additionally, you can use colon separator or operator to access all elements in a specific dimension, such as, for instance, if you wanted to get a whole column, you can use this. This one will mean that you want to get all the rows in column 0, which means it's column 0, both rows. So basically we expect to get 1 and 4. So if I execute this, I get 1, 4. That's basically how you can use slicing and indexing to select specific elements or a range of elements in a NDI array. NumPy provides a wide range of functions for performing mathematical operations on arrays. These functions include np.add, np.subtract, np.multiply, np.divide, np.exp, and np.sqrt for square root. For example, if you have two arrays A and B assigned, you have an array, a one-dimensional array A, and a one-dimensional array B, you can use np.add to add arrays element-wise like this. You can have another array being generated which takes np.add, which will return the following array if I execute this. So if I print this out, print C, this is what I get, 5, 7, 9. So basically what happened is that they added the elements element-wise. 1 plus 5, 1 plus 4 is equal 5, 7, and this is 9. So that's how we got 5, 7, and 9. Similarly, you can use np.subtract to subtract the arrays element-wise. Like, you can also have another operation which will subtract the elements of A minus the elements of B. For instance, you can have that np.subtract. You are taking elements of A minus elements of B. So if we print this out, we get -3, -3, -3. So what happened is that you took 1 minus 4, you got -3, 2 minus 5, you get -3, and 3 minus 6 is equal to that. So the operations is element-wise. You can also use np.multiply function to multiply the arrays element-wise. You can have another operation to multiply the elements. You can have np.multiply A, B. So what this will do, if we print this out, we get 4, 10, and 18. So this is what this is doing, is taking this element 1 multiplied by 4, you get 4, 2 multiplied by 5, you get 10, and 3 multiplied by 6, you get 18. And to divide, we do the same thing. We can have another operation where we can make use of the division, np.divide A, B, and if you print this out, we get the resulting operations or division, which is basically you're taking 1 divided by 4, that's 0.25, 2 divided by 5, that's 0.4, and 3 divided by 6, that's a half, which is 0.5. Additionally,
you can use np.exp function to calculate the exponential of each element in an array. Like you can have exponential of all elements in A. Remember, we have our A. Maybe you can just print this out. Print A, and at the same time we can print G, so that it's easy to show. So if I print those two, it's like you're taking each element and we get the exponent of each. So it's like you're taking e raised to 1, e raised to, and you can also get the square root of the elements in the same array A. So for example, we can execute that, and we can get the square root of this array called A. We can print h, and execute. So basically what you're doing, we are getting the square root of, this is 1, square root of 2, square root of 3. So, and this is what you're getting now. Remember, when you get a square root, automatically the values become floats. And that's basically it for the operations. There are many more, but these are the most common ones that you can use. Also, NumPy also provides functions for performing linear algebra operations such as matrix multiplication and determinant calculation. For example, if you have two arrays A and B assigned as, maybe you can add a new cell. You have A, which is a 2 by 2 array, and also you have B, which is also a 2 by 2 array. You can print these two, print A and print B. If I execute that, I see that this is the first array A and this is the B. So you can use np dot function to perform matrix multiplication. And how to do that? We can do the dot multiplication like this. So we are creating C, which is np dot multiplication. So this is just the normal way of multiplying matrices. So we can print this out, say, and clearly this is giving you a 2 by 2 matrix, which is as a result of multiplying these two matrices. So, and how this works is that it's like you're taking 1 multiplied by 5 plus 2 multiplied by 7. So it's 5 plus 14, which yields 9. And then you can take 1 multiplied by 6, that is 6, plus this multiplied by this, 16. So basically it's 6 plus 16, which gives us 22. And that's how we multiply two matrices. Additionally, you can use np.linalg.det function to calculate the determinant of an array. Like we can use this to get the determinant of matrix. We have our matrix A and we want to get the determinant. And to get the determinant, this is the function that we use, linalg.det. So it's like you're calling linear algebra from the NumPy library, and we use the function det to get the determinant. So if I print this out, print D, I get -2 and a lot of zeros and 4 at the end. So that is the determinant of the matrix A. Sorry. Yeah. So that's the determinant. So which is yields like -2, because these are too many zeros, and if you round off, you just get -2.0 because it has to be a float after getting the determinant. Thank you for watching. See you in the next video, and please do remember to like, share, and subscribe. Welcome back. We're going to look at pandas in Python. It's important for you to understand this. Please fire up your Jupyter Notebook and follow along. To begin, we can have pandas there as the heading, and to use pandas, we'll need to import it as PD and also import NumPy as NP. We are going to start with series, which is simply a one-dimensional labeled vector. So we can define we can define a series as follows. So using pd.series, and then you pass a list of numbers, can be positive or negative. You can go ahead and print that out. So we see that we have the values and the index. We can check what the values are and what the indexes are. So we can say object dot, and then you say index. That shows you that the index is 0 all the way to 4 on a step of 1. Remember, the end index is not included. That's why the index is 0 to all the way to 3, including the 3. We can also check the values, what the values are, and we see that the values is basically an array of list of numbers, and they are of data type integers. And as you have seen, that our index is simply numbers. Those are just automatic. We might choose to change that to some sort of labels. And to do that, we can specify the desired indices that we want to use by simply having a comma and specify our index. And our index are simply a list of string characters, DBAC. So can go ahead and print that out, object 2. If I print it out, we see that now our indices are DBAC, and those are the values. If you decide to say object 2, and then you check the index, you get the same thing. You get the index are now labels, and the values just remain the same. And we might want to select some values from that series. And how to do that? We use indexing. And to use indexing, we say object 2, and then we open a square bracket and we pass the string or the label. So if I execute that, we get it because our D is, so we are using the index to access the value of 4. And remember that this is, if we, for example, choose to use index 0, we get 4. So basically, we can use either the index numbers, which is 0 to 3, or we can use the labels of those index. So basically, we can either use the number or the label. Also, we can select the values, or maybe we might choose to change a value of a certain value. So what we do, we just use this. We can say, assuming you wanted to change the value of D, index D. So we use the index with the label, and then we assign it to D. If I execute that, we get, now the value of D has been changed to 6. And suppose now we wanted to select using a different way. We can use Boolean expression, and Boolean is simply true or false. So in this case, we can use this greater than, assuming you want to get all the value or to select the values of that series that are greater than 0. So we pass, instead of now the index, we use this object 2 is greater than 0. This one we just evaluate whether it's true or false. If it's true, then that going with object 2, then we are going to print out all the numbers that are greater than 0. So we get 6, 7, and 3 because negative 5 is automatically less than 0. So that's what we get. Also, we can perform some mathematical operations. For example, we might choose to multiply every number that is in that series by 2. So we simply say asterisk 2. That is, any number will be multiplied by 2. So if I execute that, I get 12, 4, 14, negative 10, and 2. Basically, all the numbers have been multiplied by 2. We can do something like division. We can do subtract all the numbers in that series. You subtract 2 from them. You can choose to do a floor division where you don't have the decimals. So you get 3. Notice the difference between these two, a floor division and an actual division. So what's happening here is that this one is the floor. What is happening is that this has been rounded off. So not rounded off. Yeah,
be rounded off to the nearest 0, to the nearest integer. So that's it. And then you can also decide to check if a certain value is included in a series. And to do that, we use the index, we use the in keyword. And how to do that? We write our index label, then followed by the keyword in, and then our series. This will just evaluate whether it's true or not. Is it in or not? If it's true, if B is contained in that series, then it's gonna evaluate to be true. And if we check something that is not there, if E is not contained, then what happens? We get a false. And you can also convert a dictionary to a series where the key will become the index label, while the values will become the series values. For example, you might have a dictionary called as data with the name of states and some value. So this is the key and the value. You can go ahead and print out that dictionary. And to convert it to a dictionary, what we do, we simply we use pd.series, and then we pass as data, which is a dictionary, as an argument. So you can go ahead and print that out. Objects 3, you print that out, you get, it's actually a series, a labeled series, where the states are the index labels or the indices. And you can also decide to add values to that series. And how to do that? We simply you assign indexing, you assign that to a certain value. If I execute that and print out the value of object 3, we have an additional value for Kansas, 18,000, and that's how to add. What if now you want to delete a value? Delete value. To delete value, we use the delete keyword. And to use the delete keyword, so you simply start with the delete, del, that's the keyword, and then you use the indexing Kansas. So it's object 3, square bracket, and then you pass the label or the value label that you want to delete from that series. So if I click that, I execute that and print out the value of object 3, I get Kansas has been deleted. And we can have another series where we can have a value NA in that. So basically we can simply convert a dictionary called data, which has a none. None simply means it's NA, and we pass that inside the pd.series. So to convert it to a series, we can go ahead actually and print this out, object 4. So basically, as you can see, we have not a number. And if, for example, now we decide to do some addition, to add two series, and we say object 3 plus object 4, we get NaN for Utah and NaN for California. The reason, our object 3, as you remember, had Utah, but our object 4 doesn't have Utah. California is NaN. The value of California is NaN, which means because to add two series, we are adding the corresponding values, specific labels. So if you can't perform any mathematical operations, then it returns NaN. So that's why we are getting that. So how would we be able to get rid of NaN such that if California, the value of California was present, we can assign it a value. If it's absent, it's 0. But for Utah, it's in one series but not in the other one, which means we want to get the actual value of Utah. So what we do, we initialize the value of NaN. So it's like we use fill value. If it's NA is NA, if it's NA, then the value would be 0, will be replaced with 0. So if it's missing, then is going to be replaced with a 0. So we can do this. We use add function. So we write object4 dot add, and then inside the add function, we pass object3, comma, and then the initial value of NA, or NA, the value that's going to replace NA. So if I execute this, I find out that California will still remain to be NaN, but the value of Utah will be printed out. So the next thing we are going to look at is the data frame. And data frame in Pandas is simply two-dimensional spreadsheet-like structure. So we can go ahead and add a Markdown cell or a text file and have it as a header there. And we are going to start with how to create a data frame. So basically, I can have a header there, construction. So we can construct, how to construct it. So here we can simply convert a dictionary with multiple values for each key and convert it to a data frame using data frame keyword. So first we can have the dictionary, which has multiple values for each key, but the number of values have to be the same. And then after that, we can convert that that dictionary to a data frame using pd.dataFrame, and you pass data, the dictionary, as your argument. But remember, note this is capitalized. D is capital and F is also a capital. So what is happening here is that the dictionary will be converted to a data frame. We can go ahead and print out the data frame, and there you go. You have a data frame that has 3 columns: state, year, and pop. We believe that pop is population. And as you can see, we have the rows have been given some index. From here onward, we are going to the labels for the rows called indices. So now the next thing we are going to look at under data frames is how to add columns. You can have it as a header there and convert to Markdown and then paste that. So, and how to add that, to add columns, is actually very easy. All you need to do is just specify the columns that are already existing, and you include a new column. For example, if we wanted to add a column called deaths in our frame 2 there. So basically what we do, we pass data and then columns, you assign them to a list of string characters. And we know that in data, we have year, state, and pop, but we don't have that. We have index, but it's just index numbers. So here we specify the labels for those index or indices. So if we go ahead and print this out, frame 2, we realize that there's an extra column that has been added with all the values being missing. Not a number, or basically you can say NA. Now, how do we retrieve columns from our data frame? To retrieve columns, we simply use indexing. So, and we simply use indexing with the row index state with a column name. So we are passing the column name inside the square bracket. And here, if I execute that, I get the state column. And remember, our rows are labeled, or they have some labeled indices. And this is one way. You can also use frame2 dot the name of that column. For example, if you wanted to get the value of for the column, to retrieve the column called year from frame2, then all we need to do is say frame2 dot year. And this is it's actually the same as how we would select columns in R programming. So if I execute that, we get the year column. That's how to retrieve columns. And to retrieve rows, it's a bit different. We need to use the the indices. So there are two ways. It's either you use the label or you use the indices. So for example, we can choose to use the labels. So we can retrieve rows using the name or the position. Those are two ways of how we can get them. So using the name of that index and this lock, score frame dot lock. Lock, we use the labels, but so I can go ahead and print that out. So basically I get row 3, which has the values. You can see row 3, which has these values. Also, we might decide to use the indices. For indices, we have to use iloc. For iloc, it's like index location. So we use the iloc with the numbers. So if I print that out, I still get the same thing. Remember, this is row 3 because we always start to count from 0. So it's 0, 1, 2, which means that that's the that. So that's why we are getting the same output or the same results. We get the same results. And suppose now we want to reassign some values. To reassign some values, we have to pass a set of numbers. If you have like five rows, then you have to pass 5 values for a certain column. And to do that, for example, we might choose to fill the date column with 5 set of numbers. So we can do this. We can say this one will just select the column date, and we assign it the values using NumPy, which is np dot arange and 5 dots. This dot means that the values that we are going to generate here using this are going to be of float type. So if I execute this, we get the values 0, 1, 2, 3, all the way to 4. Remember, we start counting from 0, which means if we pass here 5, it means that we are not going to get to 5. It's going to start from 0 all the way to 4. It doesn't include this value that is inside that has been passed as an argument. So we get those values, and just like that, our column date has been assigned those values. So now, what if now we wanted to insert some sort of values? So instead of having date as just numbers from 0 to, what if we wanted to insert some values to replace those? Another cell, I convert it to Markdown, and then we'll have a level 2 heading. So to insert some data in a data frame, all we need to do, we can choose to have a separate series with some values, and then we specify the index. Remember, we have named index here, 1, 2, all the way to 5. We have our columns, and now if we wanted to add column here to change these values, specific values, we can first define a series with how many values? This is 1, 2, and 3. Therefore, we are going to specify for which rows we want to replace the values. So here we want to replace row 2, 4, and 5 with these 3 values here. So to replace that, all we need to do, we are supposed to come and say we take frame 2, we select our column date, and then we assign it val, and val is a series with 3 values. And since we have specified the indices we want to replace, then let's see what we get. Frame 2. If we print this out, we find that row 2, 4, and 5 some values have been inserted. And given that we didn't pass values for 1 and 3, those are left to be NaN. Remember, the whole column is being replaced, and we only passed 3, so anything else becomes NaN. Now, what if we wanted to delete some columns? How would we achieve that? We have some columns that you don't need, and you need to delete them. So to achieve that, we'll have that as a heading. First, we can do some manipulations here. We can add a column called Eastern, and we assign it some values where we are taking frame2.state, so that we are checking if state is equal to Ohio. Do you know what this will evaluate to? If your answer is true or false, you are right. So basically, this will just check if in this column, any of these are equal to Ohio. If it's Ohio, then it's going to return true. If it's anything else, it's going to return false. So if I execute this, we see that we have a column that has been added called Eastern, and Eastern has true, 3 trues for 1, 2, and 3, and false for the rest. Now, suppose now we want to delete column. To delete a column, we use the del keyword in Python, and we pass the column that we want to delete. And to do that, we can use this, that del frame2, and then we pass Eastern in that square bracket. Remember, this just simply selects a column. So if it comes after del keyword, then it means that it will be deleted. So I can do that and print out frame2, and just like that, the Eastern column has been deleted. You can check if using this method, print out frame2.column to check the what columns we have, and as you can see, Eastern is not there, so basically it has been deleted. Now that's the way to delete column using the del keyword. So what if now we wanted to delete or to drop some entries, basically rows? Entries are rows in a data frame. So if you wanted to drop some entries, you can have it as a heading. So suppose now we had a series called object, obj. Actually, you can print it out, obj object. So we have a labeled series, and we want to drop some entries. So how to do that? We use the drop function, and so we first call our series, and then we type the word we type dot, and then we use the drop keyword, and then we inside the drop function we specify the label for that index that we want to drop. If I go ahead and type print out new obj, if I print it out, you realize that C has been deleted. So we have A, B, D, E. So that's how to delete an entry from a series. So how can we do it in a data frame? Suppose we had a data frame called data, which takes the values 0 to 15 or 0 to 16, not including 16, basically 0 to 16, and we reshape that to be a 4 by 4 to 4 by 4. So basically you're having 4 rows and 4 columns, and we label our index to be these states: Ohio, Colorado, Utah, and New York. And our columns, we name them 1, 2, 3, and 4. So if I execute this and print it out, I get 4 columns and 3 and 4 rows. So now, if you want to drop the entries, there are 2 ways. Do you want to drop some columns, or do you want to drop rows? So to drop rows, then we use data.drop. We can do it this way. So here, call our data frame dot drop function, and then if you want to drop more than 1 column, then you pass it as a list. So if I do that and print out data, actually we get 1, 2, 3, 4, and Colorado and Ohio has been deleted or have been dropped. So this is what we get. Now, suppose now you wanted to drop some columns. Here, you have to specify the axis. Remember, in a data frame, the row are considered to be axis 0, and the columns are considered to be axis 1. So if you wanted to drop the columns, then we have to use the drop function, pass a list of columns that you want to drop, and we specify axis equal 1. So if I execute this, I get our data frame with columns 2 and 4 having been deleted. Hope that is clear. Then the next thing we're going to look at is another way of creating a data frame from a nested dictionary. For a nested dictionary, we can use an example. It's easier to understand using an example, and convert that to Markdown and have it as a header or a heading. So first we can declare a nested dictionary just like that. Here we have Nevada as the key, and then the value is another dictionary. That's why it's called a nested dictionary. So we have year and the value, another year and a value. And then for Ohio, which is the second key, and then inside for the values, we have 2000 and 2001 as a key, as the keys inside that dictionary. So I'll go ahead and print that out. So we see it's just a nested, it's actually a nested dictionary. So suppose now we convert it to a data frame. Let's do that and see what we get. So we just pass it as an argument and print it out. So as you can see what happened there, the keys, the first set of keys becomes the columns, the column names, and the second, the keys in the inside becomes the row labels or the indices. And then inside, now the values becomes now the values of that data frame. Hope that is clear. So there's also something else we want to do. Suppose now you want to label this as our data frame that we've just created to be these two to be states. We want to label them. So basically we want to set row and column names. So to do that, we can have it as a header, convert it to Markdown and execute. And first we can set the index name using the following. We can say frame3.index.name, and then you specify that. So we have the name of our index or the rows is years, and we can also set the name for our columns. So our columns will be state, and if you go ahead and print out our frame3 and execute that, we see that we have our states is Nevada and Ohio, and year is 2001, 2002, and 2000. So we can check the value attributes. If we check the value attributes for this one, actually we use frame.values. If I execute this, we see the values is 241.1.7, just like that. The values that are inside here. We can also check the index. The index would be 2001. Now the years is of integer 64, and the name has been set to be year. We can also do the same for columns, just to have a feel of what we're dealing with. So it's Nevada and Ohio. Data type is object, and the name has been set to be state. And now the next thing you're going to look at, it's very crucial for you to understand, because for you to work with data frames, we need to know how to join multiple data frames. And to do that, we use join keyword or join. We can use merge and join. But in this case, we'll first look at merge function. That's what we are going to use. Just convert this to Markdown and have it as a header. So in SQL, we call it join. So we have left join, outer join. So here we can actually have two sets of data frames. We can have left frame and right frame. It's too much to type, so just copy and paste. So here we have our left frame, which is pd.dataframe. Then we pass a dictionary and the dictionary is key and takes the value range 5, which is simply 0 to 5, and then another key left value, which takes the value, but the values that it takes is actually a string, a list of string. So you can execute that. I can go ahead and print out left frame. So that's the left frame. Can print out the right frame. So you see it's key, right frame has other values. A quick look at this. We see that we have the key is 0 to 4 for the left frame, and for the right frame, it's from 2 all the way to 6. Now, we are going to look at different types of join. The first one that we are going to look at is the inner join. And inner join, what it does is simply take what is common between the two data frames that you want to join. And we use the function merge, and this is how it will look like. Merge usually take some few arguments. It takes the left frame, the right frame, and we also specify the on what. How do you want to join those data frames? What is the primary key? We call it primary key in SQL, but here we simply use it as the key. What is common? What is the unique labels that you want to use? In this case is the key. And we also need to specify how. And here is where you're supposed to specify how you want to join them. So in this case, we are using inner join. So if I execute that, we get key. What is common between them is 2, 3, and 4. And then the left value is C, D, and E, and the right value is F, G, H. So basically, it came here, took the value, this column, and added another column there, and only took a set of what is common using the key. The next one we are going to look at, it's the left outer join. So basically, what it does, it just take the left frame and then join it with all the matching values based on the key from the right frame. And go ahead and do that. So basically, you're getting using the how is equal to left, and the joining column is the key. So basically, you're getting key, left values, everything in the left frame will be present, and then anything that matches from the right frame is gonna be passed on to added on that column, and anything that is missing is gonna be NaN. The next thing you're going to look at is the right outer join. So here, everything on the right will be included, and anything that matches from the left frame will also be added as a column. And if it's missing, then it's gonna be NaN. And we have something else we call full outer join. And full outer join, this one will include both everything from the left and everything from the right frame. And anything that matches is gonna be included in both. But if it's missing from the right, it's gonna be on the right value. Then if no matching key from the left, it's gonna be NaN, and on the left value column, if it's missing from the right frame, then you're gonna have NaN. And then the next crucial thing you're going to look at is how to combine data frames. So here we use what we call concat. Basically, we are trying to concatenate data frames. You can have a markdown cell, execute. So the default is that the objects are vertically appended. If you use the concat function and you pass a list of left frame and right frame, then all it does is just append the values. For example, you can have a comment explaining that, and we can pass a list of data frames inside as an argument in the concat function. So if I execute this is what we get. So first we'll have our left, left frame on top, and everything else from the right will be included. And for the key, for anything that is matching between the two, then those will be merged, or will be concatenated in one column, and the unique columns in the two frames will be added as separate columns in the concatenated frame. Now, if we want to specify how we want to join, we add a comma and then axis. We specify the axis, how we want to join, how we want to combine them. So if we specify axis and we say axis 0, meaning that it's by rows, we see that it's simply like using the default one. So basically, it's just the same as what we got here. But then now what would happen in case we change the axis to be 1? It's gonna add them as horizontally. It's gonna add them horizontally or combine them horizontally. It's gonna take the left one and the right one and append them horizontally. And that's how we have that. That's what we get. Welcome back. In this second part of Pandas training, we'll first begin with grouping data frames. Here, we use a data set that is already existing. You can download it online from GitHub. And to begin, we first import the data set from our local directory where we saved it. So we import, and we can first check the first few rows, ntcars.head. Once you run that, you see the several rows. There are several rows, the first 5 rows, and as you can see, we have several columns. We have model, the model of the cars, MPG, number of cylinder, displacement, HP, DRAT, WT, QSEC, VS, AM, gear, and carburetor. We can check the shape of this the data set. Remember that this is a data frame. So if we check the shape, we see that we have 32 rows and 12 columns. We can also check the basic statistics, descriptive statistics, empty cars, describe. So this function .describe gives you some basic statistics: count, mean, standard deviation, the minimum, 25%, 50%, and 75% quartiles, and the maximum. So we can also check the mean, empty cars mean. If we check the mean, what Pandas will do will simply go to all those columns you have and check for all those numerical columns with numerical data type. Then it's gonna get the mean. That's why it's giving you an error. So that's it's saying ensure that you just select the columns that are required. But this for demonstration purposes, because sometimes you might have something like ID, which is numerical, and of course you don't want to conduct mathematical operations. You don't want to get the statistics of ID. The next thing we can have a look at is we can get the mean using different axes. Suppose you want to get the mean for the rows alone, or you wanted to get the mean for columns alone. That's where we introduce axes. So for example, using our mean example, you can just copy and paste here, and inside the bracket you pass an argument called axis, and you say axis 0. Doing that, axis 0, it means that you're getting the mean for the columns. And if you try to do the same for axis 1, let's see what happens. You still get the mean row-wise, but does it really make sense? No. You can't say that you're getting the mean for the rows, because what is this plus this plus this? You can't get the mean for the rows because it doesn't make sense. But anyway, for demonstration purposes, if you want to get the rows, the mean for the rows, you use axis equal 1. That's for demonstration purposes, but in this example, you can't do that. So the next thing you might want to do with the data, you might want to plot a histogram. A histogram, we use the function .hist. But remember you have to select the column that you want to draw a histogram for. So if I execute that, we see that as a histogram that has been generated for the column MPG. And how many bins do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Around 10 bins for the histogram. So that's a very basic way of just plotting a histogram. And for that, you can also use a different method to plot the histogram. You can also use this. This is another method where rather than using the indexing, you can use dot mpg to select the column that you want, and you use the dot hist function. So if I execute that, I get the same thing. Now we go to our group by demonstration here. Now, to group, we need to specify the variable of interest, and we are going to use group by function. So you first call your data frame, then you say dot, then you use the function group by. So this is our data frame, group by function, and inside the group by function, you specify the column that you want to group by. And the group by, once you store it as grouped by cab, in this case, we need to do a certain operation like min. So in our case, if we get the mean of a group by, then it's like we're getting mean for different categories as per the cab column. So if I execute this, we see that we have cab 1, 2, all the way to 8, and we have the different columns. So it's like you're getting the mean of MPG for cab equal to 1, equal to 2, all the way to 8. And suppose you wanted to group by more than one category. All you need to do is pass the columns that you want to group by as a list inside the group by function. And now we can check the mean for the group by the two category we just got. And actually you can have a comment just above that, which is very important, because once at some point you might want to come back to your code and you might not remember exactly what you are trying to achieve. So it's always nice to have comments. So if I execute that, you realize now you have grouped by two columns, carburetor and whether it's automatic or manual, AM, and for the different numerical columns. Next, we can compute statistics aggregated over certain groups. To do that, we'll use a NumPy function or NumPy library as follows. So you first import NumPy as NP, and then we already have the group by the two columns. So, and then we want to aggregate, we want to get different statistics. So here we want mean and standard deviation. So we need to call NumPy and then mean NumPy, which is np.std, and you pass them as a list inside the AGG or aggregation function. And if we run this, we get several things. So for each column, we get mean and standard deviation. And the mean is for the grouped categories for the by two columns, cab and AM. Also, you might want to count the number of cars in each combination of cab and AM. So to do that, we use .count function and ensure that you select the right column. So here we call our variable that you created earlier, grouped by cab and AM, and then you select cab and then you say .count, and you don't have to pass any argument inside the count function. If I run that, I get the count for each tabulator based on AM. Is it automatic, which is 1, or manual, which is 0? The next thing we can do is plot the count. And to plot the count, we will use a library called Matplotlib, and then we call pyplot as PLT. So that's the library we are going to use, and in that library, we can use pyplot, and we import it as plt. And we use the following code to plot. Too much to type, so just copy and paste it there. But for your understanding, I would suggest that you type it out. If I execute this, I get this. So we have in the y-axis we have count, and the x-axis we have the calculator, and we have AM. This is a stacked bar chart where we have the green part representing 1, which means that it's automatic, and the faint, it's a bit faint, represents 0. And that's how you can be able to plot the count. The next thing we might want to do with data frames and series is performing arithmetic operations between data frames. So the first thing we can do is what we call broadcasting. Suppose we had an array called R, which takes the numbers, the float values 0 to 11, and has been reshaped to a 3 by 4 array. So if I execute that, we see that it's a 3 by 4 array. And suppose we wanted to get the difference, to do some sort of operations where we want to subtract row 1 from the original array. To achieve that, we say array minus array first row. We use indexing to select the first row. If you get the subtraction, we see that what is happening here, we are taking the first row minus the first row, you get 0, 0, 0. Then you take the second row, you subtract row 1, you get 4, 4, 4. You subtract the second one, the third row, you subtract the first row, you get 8, 8, 8. So each element, it's basically element-wise. The operation is happening element-wise. That's why you're getting that. We can also do the same we can decide to add. Assuming you decide to add, we get the same. If you decide to get multiplication, you'll just get the same. It's like you're taking 0 multiplied by 0, then 1 multiplied by 1, just like that, and then go to the second row multiplied by first row. So it's 0, 0 times 4, 1 times 5, just like that. We can also do the same for a data frame using broadcasting. So suppose we had a data frame that takes the same numbers and same array and convert it to data frame, and we specify that the columns is B, D, and E. What this function will do, list, this will convert this to individual characters, string characters, and pass them as the columns. Our indices for those 4 rows will be Utah, Ohio, and Texas. So if I execute this, we see that that's how our data frame looks like. Now, suppose we want to subtract a series from that data frame. We can just first define our series here, and our series is simply the first row. Remember that this is how we said we can select a row using an index. Remember we said we can use index, or we can use the labels. So this one is the same, series equals to frame dot log, then you open square bracket and you pass the label. Remember, the label for the first row is Utah. So if you pass Utah there, this will simply give you the same output as when you use iloc and you pass the index. So now if you want to get to subtract the series from the data frame that we have called frame, you simply say frame minus series. If I execute that, this is what I get. So remember, it's like you're taking this minus itself, and then row 2 minus this one. So it's row wise. So it's 3 minus 0, 4 minus 1, 5 minus. So you get 3, 3, 3, and the same happens for the other rows. And suppose now you wanted to broadcast down the columns. So to do that, we can define a series that now selects a column instead. So as you can see, we specify our column. So our column will take D for all of this. And now suppose now you wanted to subtract that column from the frame. So if I execute, so here we use the sub function and we pass our series as an argument, and we specify that we're interested to do that row-wise. So if I execute this, this is what we get. We get -1, 0, and 1 for all, because we took this column and subtracted it from the data frame, which means it's 0 minus 0, you get 0. 3 minus 3, you get 0. Oh, sorry, not that one. It's 0 minus 1, 3 minus 4, 6 minus 7, 9 minus 10. You realize you get the first column in the results will be -1. This will be 0 because you are subtracting D from itself, and this one will become 1 for all the entries. A closer look at indexing, we can start with series. We can have a title there, convert it to Markdown. So here we have a series that takes 3 numbers, 0 to 3, and the indices is A, B, C. And suppose we wanted to change the value of index 1. So this is index 1. So this value, we want to change this to a different value. Suppose we do this. We want to change the index 1, this one, to D. Let's see what happens. We get an error. This is because index objects are immutable, meaning that they cannot be modified by user. What that means is that once you've defined the index or the indices, you can't change them. So that's why you are getting an error. So what if now you wanted to change it? Suppose you did something wrong and you said this is X instead of C, and you wanted to change it. Then we use something we call reindexing. Reindexing, we can use an example. Suppose we had a series called object that takes 5 values, and we have our desired indices. So if I do that, that's our series. And we wanted to change these indices to a different letters. To do that, we can simply use reindex function, and you pass our new indices as arguments. So if I execute that, I see that the indices for object have been changed. And given that I've passed more than enough indices, the last one will be assigned NaN. It's not a number. So suppose now we wanted to reindex and initialize anything that is missing to be NaN. Here, we'll use reindex function, pass the indices, and we specify the field value to be 0. We can go ahead and run this and see what we get. So in this case, as you can see, the value NaN has been replaced with 0. Again, we might want to reindex and initialize missing values with the forward fill or the backward fill method. So in this case, for instance, we might have an object 3, which is a series with a list of 3 string characters, blue, purple, and yellow, with index 0, 2, and 4. We can go ahead and run that. Object 3, you see that it has 3 values. The series has 3 string characters, blue, purple, and yellow, and index is 0, 2, and 4. Suppose now we wanted to reindex such that we have index 0 all the way to 5, and anything that is missing be replaced with method forward fill. So in this case, we use this method as follows. So here we reindex with 0 to 5, given that this will only generate numbers 0 to 5, since 6 is not included, with method called ffill, which means that since we have 0, that is blue, but since we don't have 1, it's gonna be prefilled using this method. Anything that is missing, this is the method that's gonna be used to fill that. So if I execute this, I see that we had our 0 to be blue. And given that 1 was missing, then the value for the previous index will be carried forward. So the missing value has been replaced with the previous value. And we see we didn't have 3, so it's replaced with purple. We didn't have 5, so it has been replaced with yellow. And that's that method. You can as well decide to use a different method. Suppose we decide to use, for the same one, I can rerun this object 3 to get the series, and you see that it's blue, yellow, and purple. Is blue, purple, and yellow with index 0, 2, and 4. So if I decide to use a different method, backfill, and rerun this, let's see what we see. We get here. So here you see that the missing values are being filled with the next values. So in this case, since 1 was missing, index 1 was missing a value, then has been replaced with purple. I hope that is clear. So we can have a closer look at indexing. So a closer look at indexing, and to look at this, we can use a frame, a data frame that takes the values from 0 to 8 and reshape that into an array, and the index is A, C, and D, and the columns are named Ohio, and that has been converted to a data frame. So I can go ahead and run this and print it out. So we see that we have a 3x3 data frame with 3 columns and 3 rows. So now, suppose we wanted to reindex such that we have A, B, C, D. Remember, we don't have a B. So if we decide to reindex like this, then it means that D will have NaN. Can go ahead and execute that. B, since it was missing, it's NaN for the whole row. And that's a way of reindexing the rows. You have to specify index. But if you wanted to reindex the columns, then we can first declare some states this way. And then after declaring some states, which is a list, and as you can see, we have Ohio, Texas, and California in our frame. But the ones that we have declared here, we have Texas, Utah, and California. And we can reindex. To reindex the frame, we simply say frame.reindex columns equal state. Let's see what we get after we execute this. We see that we have now replaced the columns Texas, Utah, and California. So we have our Texas there, which takes our frame. You see, this is the frame. We have our Texas because we have the Texas there in our list of states. We don't have Utah in our frame, so meaning that Utah will be NaN, and then we have California, which had the values in that column 2, 5, and 8. So we have those, and just like that, Utah has been added with the values NaN. So, and that's how to reindex a column. So the next thing you are going to look at is how to perform series indexing. For series indexing, you should realize that series indexing in Pandas works the same way as NumPy indexing. Remember, a data frame or a series is simply an array, and Pandas is built on top of NumPy, so they work in a similar manner. So you can have a comment there. And the only difference is we only use index values in place of just integers. Remember, for NumPy arrays, they don't accommodate index values. We just use integers. So, but in Pandas, we can use the values or the labels. So suppose now we had an object, a series that has four values, and these are the indexes A, B, C, and D, and we wanted to get the second object in that series. So we can go ahead and just print that out. Now, suppose that we wanted to get the second object. For example, we want to get this one. So we see that it has the index B. That is B is the index label, but in reality, the index is 1. So we can get this value in two ways through indexing. First is using 1 in a square bracket, or we can use the label B as follows. If you go ahead and execute these, you realize you get the same thing because Pandas series allows us to do indexing using the integer or the index labels. Also, we can do slicing, and slicing we can use index labels to specify the start and the end. We can do it as follows. So we can specify the start index and the end index using the labels. So if I execute that, I see that I'm getting B, C. Remember, when we use the labels, both are included. But if we decide to use slicing using the index values, then it's going to be different. For example, if I go ahead and do the same and use object, then we know that B is index 1 all the way. We know that C is index. So if we do this, you realize this is what we get. We get 1. Mark the difference. If we use the index labels, then both are included. But if we use the index values, only the start index is included and the end index is not included. So in this case, 2 is not included. Hopefully it's clear. But if you have any question, please post them in the comment section. Now we can go ahead and look at data frame indexing and see how we can achieve that. So suppose we had a data frame and we wanted to retrieve more than one column, because the data frame will allow you to index to retrieve more than one column. So suppose we had that data frame with 16 values starting from 0 to 15 and is forming a data frame, 4 rows and 4 columns. And the index are just like this with Ohio, Colorado, Utah, and New York. And the columns are 1, 2, 3, and 4. So we can go ahead and print this out. So we see that's our data frame. If you wanted to retrieve a column, all you need to do is just do the normal indexing and use the column label just the way we did for indexing. So here we retrieve one column called 2, just this way. We can go ahead and run that. We get just the second column. We can get the fourth one 4, just like that. So we see this is what we get. If we wanted to retrieve more than one column, then it means that we need to pass a list of columns that we want to retrieve. If we wanted to retrieve 2 and 4, so you see we have retrieved the 2 columns. And we can also do slicing using the column names by simply writing the first column all the way to column called Utah, and this is colon in between to enable you do the slicing. So here we've actually been able to get the 2 rows. We're getting 2 rows. So here we're using slicing with the index labels. And just like that, we've been able to get all the columns for the two rows with the index Colorado and Utah. Also, we might be able to do slicing with row numbers. And to do that, we simply use this. You can say data. The start index is not provided, but the end index is provided. But remember, when indexing and you're using the numbers, then you won't include, when slicing, it won't include the end index, which means that this, which happens to be row 3, will not be included. So it's gonna get all the rows up to the row with index 1. So that's why you're getting two rows, which happens to be rows with number 0 and 1. 2 is not included. That's why we only get 2. We can also do filtering, and to do filtering, we only use something that's gonna give us either true or false. For example, here we want to get all the rows or the data all the rows for which column 3, the column named 3, is greater than 5. So in this case, we see that the only row that violates that rule is the first one. So meaning that when we execute, we are supposed to get these 3 rows. Let's go and confirm if that is the case. So execute, I get the 3 rows because the first row, the value for the third column was less than 5. So that's how we actually do filtering. We can play with this. We can say maybe less than 5 and execute. We see we get 1 row for which column named 3 is less than 5. And we can also use a Boolean statement to generate either true or false. For example, we might want to check, we might want to convert data, the whole data set or the data frame, to be either true or false if the value is less than, any of those values are less than 5. And to do that, we use this statement. So it's data, and then you use the less than operator and 5. So if I execute this, you get a data frame with either true or false. So if you decide to incorporate or maybe to change everything to 0, you can simply do this. You can actually replace everything that is less than 5 with 0. And to execute that, so anything that was true has been replaced with 0 because that's the condition we set. So what we are doing here, we are taking in our data frame called data, anything that is less than 5 is being replaced with 0. And that's exactly what happens there. The next thing we might want to do is select a bunch of rows and columns. For example, if we wanted to use something we call lock and iLock with our data frames, we convert that to Markdown. So I want us to do this and see if we want to use the location lock data.lock. This one is simply gonna select some specific rows based on their labels. For example, we might get Colorado for rows for columns 2 and 3. Is Colorado for which columns? 2 and 3. So we expect to get 5 and 6. Let's execute that and see. You get 5, 6. Another example we can use is this one. Suppose now you wanted to get column 2 and 3 for 2 states, Colorado and Utah. All we need to do is use lock, and then we pass 2 sets of list for the specifying the rows that you want and the columns that you want. So if we execute this, we get row 2, column 2 and 3, and row named Colorado and Utah. And then we might as well decide, instead of using the labels, we can decide to use iLock or the actual values. So for this one, this means that I want to select row, this is row 3. If I execute this, I get is a column, all the columns, but for row 3. Row 3, because it's this 0, 1, and 2. So this is what I'm getting from this example. And suppose now you wanted to get all the rows before Utah and return only column 2. This is what we use. You realize that before comma, that's why we specify our rows, which rows we want to select, and after the comma, we specify the columns. So here, we want to get anything all the way up to the row called Utah. So if we execute this, we see that we are getting row 1, row 0, 1, and 2, and we are getting the values from column 2. I hope that is clear. Thank you for watching. See you in the next part of this Panda tutorial. Welcome to this third part of Pandas training. In this part, we'll talk about hierarchical indexing, and we're going to start with series. Hierarchical indexing enables multiple index levels on an axis. You can have more than one axis. You can have more than one index levels on a single axis. For example, you might have the following series. In this series, it contains 10 randomly generated normal distributed values, and on the first level of index has A, B, and C, and the second level of the indexing has the values 1, 2, 3, which are the labels. We can go ahead and execute this. So as you can see, is a series with two levels of indexing. We have the first index which has A, B, and C, and we have another level, second level, with the labels 1, 2, 3. Now suppose that we wanted to access B. How do we do it? We first do something we call partial indexing. You want to access only one section or one index based on the first index level. So here we can use data, that's our series, and then we do the normal indexing, and inside the square brackets we specify our label for the first indexing. If I execute this, I get everything that is contained in B. So B has all this. So this is what's being selected. We can also do slicing. We can select multiple indexes or values. So in the first level, we start with our start index, and the last one is C. So it's from B to C. So basically you want to access B and C. And that's basically how to do the slicing. To access the series elements based on the first level of indexing. Now, what if we wanted to get some values based on the second index level? So suppose we wanted to get a subset based on the second index level of the second label. So this is how we do it. So the first, if we have a comma, the first part represents the first index, and the second part represents the second index level. So if I execute this, I get A, B, C, D. So basically what's happening here, I'm getting this value for A, for B, and this for C, and this for, so that's why you're getting only one for each. Then there's something else. Because we have hierarchical indexing, we can do something we call series stack and unstacking. Basically is converting the hierarchical indexing in series to be rows and columns, or rather two-dimensional. So to achieve that, we can use unstack function to convert them into rows and columns. And this is how. So we've come from our original, which had two levels of indexes or indices, to rows and columns. So here, the second level becomes our column, and the first level becomes our row indices. And then what if now we wanted to go back from data to, we wanted to go back from this back to our original hierarchical series. So here, because you see, as you can see, data is in series. But if it happens that you stored this maybe into a data 2 and execute and we run that data 2, this is what you get. Now, if you want to go back to this kind of data or hierarchical index series, so this is what we do. We say data2 dot stack. So you see, we went back to our original format.
The next thing we are going to look at is hierarchical indexing in data frames. Remember, data frames have two axes, axis 0 and axis 1, or rather rows and columns. Now, suppose we had a data frame that uses numbers from 0 to 11 and has been reshaped to 4 rows and 3 columns and has 2 levels of indexing. First indexing for the rows is A and B, and the second level has the labels 1, 2, and on the columns has 2 levels. Level 1 is the 3 states, and on level 2 for each state it has green, red, and so basically is a green and red as follows. You can go ahead and print this out. So here we have Ohio with the green and red, and Colorado with green on the columns, and we have on the rows we have 2 levels, 2 index levels, A, B on the first and 1, 2 on the second. So we can use either axis to retrieve the values, and we can change the index names as follows. So to change the names of those index, we say index names frame index dot names equal key 1 and key 2. So if I execute this, you see that we have for the index for these ones, we have key 1, key 2. So basically we've renamed this one as key 1 and key 2. We can also do the same for columns. So here we see that we use columns dot names. So basically you are changing the names of the columns. So we have state and colors. So executing that, so we see we have states is the first level, and the second level has been named as colors. So to access the values here, we can access based on columns or rows. To access based on columns, we use the normal format. So we say frame, and then we pass the first level column name, which is like Ohio. If I execute that, I get the information for Ohio, and Ohio has all these values. So it has green and red. So basically you are selecting everything on that column. And remember that Ohio has 2 columns, green and red. That's why you're getting that. And now, if you wanted to select a row based on the second level of indexing, so we use iloc. We can use iloc or we can use loc. So for example, if we wanted to get for A and B, we get 1, 1. So this is how we do it. So we are getting for, since we are using the location, so we are talking about this first one here, A. We are talking about A. Sorry, not A, but rather B, because it starts counting from 0. So 0, 1. So we get state is Ohio and Colorado, and it's green, red for Ohio, and we're using Colorado. So basically what is happening here is that iloc 1 is taking the first row, the first level A, or so this is, so basically it's getting this row. Hope that is clear. The next thing we are going to look at is something we call function mapping. And function mapping, it's very important. And the reason is that Python defined functions automatically apply themselves to each element in a Pandas data frame. However, user-defined functions do not do that. So we need to find a way of applying those functions to these data frames. And how to do that? We use something we call apply function and apply map. So we look at map, we look at apply first, and basically this one will do it row wise or column wise. So suppose we had a data frame that takes randomly generated values, normally distributed values. So we have our values, our data frame with columns B, D, E, and the columns for the 4 states. Now, if we wanted to get the mean for the columns, then we can create something we call a lambda function that look like this. So we write the keyword lambda, and then we write x, and then x dot mean. So this one, it's like you're taking a single row x, and then you get the mean of that row. So basically we need to apply this function. Sorry, we have a column x that we want to get the mean for, or we want to get a mean for a certain, let's say a series x, and you want to get the mean for that series. So, and how do we apply that? We write our frame, our data frame, and then we use apply function, and we call our lambda function, which is f. If you execute that, so this is what you get. We get mean for each. So basically what happened is that the apply function did apply, actually literally applied the function f, which is getting the mean for any series. You pass it as an argument there. So it has been applied to other columns. Now suppose we wanted to use, instead of just having f, we can pass the axis you want to apply that to apply the lambda function to. So if we put axis 1, it's like you're getting the mean for the rows. But if we used 0, we would have gotten for columns. So axis 0, if you pass axis 0 there, we are getting the mean for the rows, for the columns. And if it's axis 1, we are getting the means for the rows. We can apply a different kind of, for several examples, we can apply a function that gets the maximum and minimum to the columns, and you can still do the same for the rows. In summary, there are those statistics that you can actually achieve. You can apply different. So as a summary, we can incorporate these in our lambda functions: count, mean, standard deviation, all this, describe, sum, whatever you want to do. So the next thing we can look at is apply map. Apply map will apply a certain function to each element in a data frame or a column or a row that you're interested with. Suppose we wanted to get a series of some statistics. Maybe, for example, we can have, we wanted to return minimum values in a certain series or a data frame, minimum and maximum. So we want to return the output as a map or a simple data frame. So here we want to get, for all the rows or columns, we want to get the minimum and maximum. So if we apply this, if we apply, we are getting the minimum and maximum for the columns. Now, suppose you wanted to use apply map, whereby you want to format the output, or you wanted to format the values of a frame in a certain way. For example, we can use these formats whereby everything will, all the values will have 2 decimal places. So basically it's like you're formatting all the values. So because every value will have to be changed, that's why we have to use apply map that works element wise. So to use apply map function, we say frame dot apply map, and then you pass your lambda function that does the formatting. So if I execute this, I see that all the values in our data frame, all these values have been rounded off to the nearest 2 decimal places. And that's basically what you get. And then the next thing we are going to look at is the most vital thing when dealing with data: how to handle missing data. So to handle missing data, we first call something we call NaN as NA. We're importing NaN from NumPy. So we say from NumPy, import NaN, and we can import Pandas as PD. Now, suppose we had a series called data, and we are passing a list. We are creating that series with values 1 NA, which means symbolizes missing, and
3.5 NA that are missing, and 7. So if I execute this, I see that we have some 2 missing values. So how do we handle these missing values? The first thing we can do is simply just drop them. Drop the missing values just like that. If I execute this, I see that the missing values NANs have been dropped. Basically, drop NA function works the same as just selecting the non-missing values, just like this. So we're saying data dot not null. This will return either true or false. So anything that is true will be selected, and basically we get the same thing. But using drop NA function will simply just delete them from our data. So in a in a series, there are several ways you can detect the missing values or the missing data. And to detect, we're going to use an example. Suppose you have several states, 4 states, and then we also have a list of values, and one of them is missing. And we wanted to create a series from those two, the state being the index, and this being the data that we want as data. So we can create a series by passing as data and declaring that our indices would come from that list states. If I execute this, we get a list, a series whereby for California, NAN is missing. So how do we detect if we have missing values? Yes, here we can see, but assuming you had a million rows or a million elements, you can't possibly just have a look and see it. So we need to use a function called isNull to detect. So this function will just return true or false. And since we know that California is missing, then it's going to be true, but the rest would be false. We can also use another function called not null. So basically we say PD, which means pandas dot not null, and then you pass our object 4 as an argument. So this will simply give you the same thing. It's gonna reverse, it's just like a reverse of is null. So is null checks if any of those are missing, and not null simply checks if any of those is not null. That's why we are getting false as the first for California, and the rest are true. So the next thing you're going to look at is how to fill the missing gaps or the missing values. And to do that, we use something we call fill NA and pass different arguments. Now, suppose we had a series and we wanted to replace anything that is missing to be 0. So this is what we use. We say that's our data, and then fill NA, you pass 0 as an argument. If you execute, we see that anything that was missing has been replaced with 0. Now, suppose you wanted to input specific values, we can pass a dictionary with keys representing with the key being the index that you want to replace, and the value being the value that you want to replace the missing with. So if I execute this, I get this. So which means that this was missing and has been replaced with 1, and also this was missing and has been replaced with -1. Also, we can do this. We can say underscore data dot fill NA 0. We are replacing this. We are replacing the NAs here, because if you realize here, let me show you something. We've been doing some replacement, but have we actually changed our data set? No, we haven't changed. But if you wanted to change now in the actual data set, we use this underscore. Underscore is equals to data.fillNA. And since we are saying in place is equal to true, then this will be replaced in the data set that has been saved has been imported. And now trying to read the data, everything there's no NAs, because the NAs have been replaced in the actual data that we we read or we created. Also, we can use various methods like just copying the values before or the values below. We can use the forward fill to replace those missing values. For example, forward fill means that the NA, the first NA in index 1 will be replaced with the values before, like this. You see it has been replaced with the value before. Also, we can do the backfill where we get the value, the next value, and replace the missing values. So here we are taking to replace this value. We of course took the value for index 2. So also we can replace missing values by getting the mean of the other values, non-missing values. So here we'll first get the mean for 3.5 and 7, and whatever we get, we replace the NA, or we fill the NAs. So executing that, we see that we are replacing that with there and another one there. The next thing we are going to look at is how to fill the missing values in a data frame. And how to do that, we can have two data frames. I can print out F1 and df2. Now suppose we combine those two. So we find that there are some missing values, E and row 3. So column E and row 3 are all missing. So suppose we wanted to replace the missing values with 0. This is how we would have done it. We say fill value equal to 0. So anything that was missing was, so basically we are getting this the sum, and anything that was missing would be replaced with 0. Therefore, we get the values, the sum of the non-missing values. So, and given that we do it element-wise, we go and get A0, we add it to A0. So this is exactly why we are getting this. We have for column E, we're only getting the values from df2, and the same happens for row index 3. We are getting the values for from df2. Now, the next thing we are going to look at is filtering missing data. Under this, let's assume that we have a data set that takes the first row has numbers, the second row has only one number, and the rest are NAs, and the fourth row has one value missing. So if I execute this, I get 3 columns and 4 rows, and for row 2 has 2 missing values, row 3 has 3 missing values, and row 4 has 1. Now, there are various ways that we can clean up the data with respect to the missing values. We can use drop NA, and if I execute this, we see that we are dropping any row that has some missing values, which is not very good option. Also, we can do some filtering just the way we did here. We are just selecting values that are non-missing by simply dropping rows that have missing values. We can also do this. We can also specify how by saying how equal to all, and this will basically return the NaN only rows. And how to do that? If you execute, we see that drop NA is only dropping those rows with all the values missing. As you can see, we have one such row. Row 3 has all the values missing. So that's what we are getting by specifying how all. This will just drop all the rows with missing values entirely. You can also specify which axis to consider, and we still use our argument how equal to all, and we specify the axis. In this case, for axis 1, anything that is missing entirely will be dropped. So in this case, if I execute this, I get is entirely nothing has been dropped, since axis 1 is only considering the columns, and none of the columns is missing entirely. But if we change this to 0, then it's going to consider the rows. If I execute this, you see the row that had missing values entirely has been dropped. We can also, that brings us to the end of this tutorial on Pandas. Please subscribe, like, and share my videos, and do leave a comment on how you found this tutorial. See you in the next video. Hi everyone, welcome again. In this video tutorial, we're going to look at various ways we can load different data types into a data frame using Pandas. The first thing we do is we import Pandas library and assign it to an alias called PD. So we have different data types that you can import into Python from your local computer or local drive. So there are two ways. You can either specify the path, the actual path, and hard code it, or you can save the data set in your working directory and just call the data. So in this case, the first thing you're going to do is to read or load CSV data into a data frame. And to do that, we normally use a function from Pandas library called read_CSV, and then we specify the path. So in this case, we are using read_CSV, and then we specify the path where the CSV file is saved. And then we can display the first 5 rows as well as the dimension of that data frame that we've just read. So I can go ahead and execute. So we see that we have a file with 5 columns and 34,110 rows. And this just a snapshot of the first 5 rows. So that's basically it, how to read CSV file. The next kind of file that you can load into a data frame is an Excel file. And remember, an Excel file might have different Excel sheets. So you need to specify the sheet name that you want to read. So for you to achieve that, we can use this code. And in this case, we are reading an Excel file called Global Superstore, and it's a .xlsx, and the sheet name is order. And just a snapshot of the first 5 rows, we use data frame .head to display the first 5 rows, and we can check the shape by simply calling our data frame, and we use the shape to return the dimensions. So executing this, we get this. So basically we have quite a number of columns. To be specific, we have 24 columns and 51,290 rows in that data frame. And as you can see, it's just easy as that. So the key to remember is that you're supposed to specify the sheet name that you want to load into a data frame. The next file we can read is a JSON file. So to read a JSON file, we use read_JSON function from Pandas to do that. So basically we have Nobel Prizes.json file, and after reading it, after loading it into a data frame, we need to see the first 5 rows and the shape. Executing this, we get basically we have 1 column and 664 rows, and for each row is basically a dictionary, and we have year 2022. Category is chemistry, and maybe I don't know. I'm not so sure what this is, but basically it's just a category. And that's basically how you can read a JSON file using that function. And then the next kind of file we can load into a data frame is a SAS file or a SAS data set. And to load it, we use a read underscore SAS function from Pandas. And basically, all you need to do is say PD, standing for Pandas, read underscore SAS, and then you specify the file path, including the file itself and its extension. The extension is indicates that it's a SAS file, and we can check the first 5 rows and the shape. So executing this, we see that it's the same data set that we had checked earlier for the CSV. So we see that we have 34,110 rows and 5 columns. And the next kind of data set we can read is HTML data into a data frame. In this case, a good example is just a web page with various data sets or tables, and you want to read just one table at a time. So you need to specify, after reading the data frame, we need to specify which table you want to read. And how to do that, we first read the data, the HTML file as a data frame, and then we specify which table by simply using indexing. In this case, we get the index 0. Basically, you're getting the first table in that HTML file. And we can get the first 5 rows and the shape. So executing this, we see that we have a data frame with 9 columns, 9 rows and 4 columns. So that's basically how you can read a table from HTML file. And the next kind of data we can read is static data, SATA. So in this case, we just do the same thing, but we use the function called read underscore SATA from Pandas. So in this case, we see that we have a file called nepal8.dta. That's basically a starter data, and we want to see the first 5 rows or display the first 5 rows and check the shape just to know what's the dimension. So executing this, we get a file with, or a data frame with 75 rows and 4 columns. And this is a snapshot of the first 5 rows. And this is basically it for this demonstration. But remember, these are not the only things, the only formats that you can load into a data frame using Pandas. We have others. And to do, I can show you how to get them. So you say PD, standing for Pandas, dot, and then you start typing the word read, and then you hit tab on your keyboard. It will simply show you everything that you can read. All these are functions showing you which kind of data formats you can read. In this case, you have clipboard, CSV, all the way HTML, JSON, awk, pickle, SAS, SPSS, SQL. So basically, you can actually get data, load data from a database, and you can also read a table, XML files, all those things. And that's basically a short tutorial on how you can load various data sets into a data frame using Pandas. And thank you for watching. See you in the next video, and remember to subscribe, like, and share my videos. And also do remember to comment. In case you have any question, just comment, and also you can tell me how you found the tutorial. Thank you, and see you in the next video.
Hello, welcome back, my good people. In this video, we're going to look at data visualization using Seaborn library in Python. If you're new to this channel, please do remember to subscribe, like, and share my videos. That will be super helpful for me.
Welcome back. To begin, we'll first need to import NumPy as NP, Seaborn as SNS, and Matplotlib in line. So in most cases, you'll find that there's some libraries in Anaconda that need to be updated.
and in which case you get some warnings, and because you don't want to see those, we need to import warning library, and using filter warnings function, we ignore showing those warnings. For this tutorial, we will use one dataset called tips that is already preloaded in Seaborn. So all we need to do is just load the file, and to load it, we use the function called load_dataset from Seaborn, and we specify the name of our dataset that we want to load. We can go ahead and take a look at the data by printing out the top 5 rows in that dataset. So here we see that the dataset has 7 variables. We have total bill paid in dollars, the amount of tip given, the gender of the person paying the bill, and whether there was a smoker in that party, and the day of the week and the time, was it lunchtime or dinner, and also the size in that party, how many people are in the party. We can check the shape of that, tips.shape, to get the dimension of that data set. We see that we have 244 rows and 7 columns. The first visualization that we are going to look at is bar plot, and for bar plot, it represents the estimate of central tendency for a numerical variable aggregated over a categorical variable. Create a bar plot, we use bar plot function from Seaborn, and we specify which variable should go on the x-axis, and the variable that goes on the y-axis, the data set, and the palette. And in this case, the palette represents the parameter that specify the color of those bar charts. And then we can go ahead and set the value labels for the x-axis and y-axis. In our case, we want to plot on the x-axis, we want to have sex, and on the y-axis, we want to have the total bill, and the palette, we use set1. And on the x-axis, we have sex on the x as the x label, and the y-axis label would be mean bill. If I execute this, we see that we get the mean bill on the y-axis, and on the x-axis, we get sex. And red represents male, and female is represented by blue. In some instances, the default font size is not good for you. So all you need to do is specify the font scale that you want. In this case, to do that, we use set function from Seaborn, and we specify the font scale as an argument in that set function, and we run it. And then you can go ahead and run the bar charts again. We run that code to create them. You'll see that there's a bit of a difference in the font size of everything in that chart. You can see the difference. In this chart, the mean bill is a bit smaller as compared to whatever we've created after setting the font scale. And as you can see, the bar plot is making use of the mean of the total bill paid in dollars for the two categories. It's getting the mean of those for male and female. But from the bar plot, we can't tell what the mean is. So what we do, we can compute the mean ourselves. So in this case, we use this, we first group by sex, and then we compute the mean for those groups. But in this case, if I execute this, I get the mean for the total bill, tip, and size as the average. So I'm getting a summary table for male and female for the mean for each numerical variable in the data set. But in some instances, like in our case, we only want to see the mean for the total bill. So in this case, we can specify, after grouping by sex, we specify the column
the numerical column that we want. In our case is total bill, and then we get the mean over the two categories of sex. So in this case, once I execute, I see that the mean for male is 20.7 and 18.1 for female, and these have been represented in the chart that we created. And this is a bit, the reasons why we use visualization is to represent the data. So it's easier to use visualization, it looks better, but there's an issue. In some instances, using mean for central tendency is a bit misleading because it might be affected by the outliers, either extreme values, too high values, or too low values. In this case, we can use the median as the measure of central tendency, and to plot it, we use the same code with two differences. We introduce an argument for estimator, whereby we calculate the median using NumPy, and we choose a different type of palette or the color choice. So in this case, we use the palette as HLS, and we leave everything else to be the same, whereby the x-axis will be sex, y-axis is total bill, but the aggregation will happen on the total bill will be median. So, and we change the y label to be median bill. So executing this is what I get. So we get on the y-axis, we have the median bill, and on the x-axis, we have sex. Remember, earlier on, we had set the font size to be 1.35, and that will remain for as long as we haven't changed anything. So as you can see, we see that the median bill is about 18, and for female, we see that it's about 16, and it's hard to tell from the visualization, but we can actually go ahead and compute the median for each group. So to compute the median of each variable by gender, this is what we do. We group by sex, and then we compute median. So executing this is what we get. We get for any categorical data or variable in our data set tip, we can compute the median for each. But in our case, we are not really interested in getting for all numerical variables, but rather we only want for median, for the total bill only. So we have to specify the total bill, and we get the median. So executing this, we see that the median for male is 18.35, and for female it's 16.4. And according to the bar plot using the median, we see that it's whatever we got here is accurate, because now we have the actual values. We have the actual median for the two groups, 18.35 and 16.4. And that's it for the bar plot. Until this point, we've been using palettes for the two visualizations that we've created. And you might be asking yourself, how do we choose these colors? There are two kinds of colors that you can choose from when you're using Seaborn. The first set of colors, we can call them default colors or default theme that are basically inbuilt in Seaborn, but that's not to say that you can't define your own colors. You can choose a wide range of colors. We normally call them named colors that you can choose from. You can mix and match the colors that you want to use. But the default theme, these are specific color ranges that have already been selected for you. And all you need to do is just specify the various colors that you can use, the default colors. And you can actually type in this URL and click on it to see the colors that exist. Well, these are the colors that you can actually choose from. There are different colors that have been selected for you, and you can come here and choose the colors that you might want to use for any of your visualization. You can learn more from this URL. I'm not going to go deep into that. You see, like here we have set 2. These are the colors: paired, you can use those colors, sequential color palettes, perceptually uniform palettes. Well, these are the colors that you can choose from depending on what you want. These are the default theme, and all you need to do is just come and get the name for the palette that you want to use. Anyway, for these default colors, there are quite a few, and you can even visualize them this way. So we have like several variations of the default theme. We can have deep, muted, pastel, bright, dark, colorblind, and so many other. So if I want to visualize colorblind and see the range of colors that are there to be used, I can execute that and we see that we have those colors. We can print some more. For example, we can say muted and execute again. Also, we can have another color range or theme. We can take, for example, bright and visualize it. So you see this is a bit bright. If you're fond of those bright colors, so you should go for the bright theme. And now, as I said, there are default themes, and also you can choose your own colors that you want. And to choose your own colors, we normally use what we call named colors. The named colors, you can actually follow this link and see the colors that are available for you to use. So these are the colors that are available for you. And we have 954 most common RGB monitor colors as defined by several thousand participants in the XKCD color name survey. So as you can see here, we have, like, for the color purple, there's this code that can be used to specify that color, or you can actually decide to use the name purple instead. But it's always important to maybe bookmark this website, or just bookmark this website so that you can come back to this and pick the color that you want. So for the named colors, you can actually create your own palette that you want. As you see here, for example, for the bright, we see that we have several colors that your visualization, if this kind of theme is selected, then the visualization will pick colors from this. So what you do, so you can create your own palettes with some selected colors of your choice. You can say colors equal, then you pass a list of those named colors that you have that you've actually selected from this website. You can say pig green, khaki, blue green, whichever you want to choose, and make your own color palettes. So after you create this and you assign it the variable colors, and then you print it out this way using that function. If I execute, I see that I've actually selected how many colors: sky blue, cerise, color gold, seafoam, purplish. So those are the colors that I've chosen. So if for any visualization you specify that list, that's exactly what is going to be used for your visualizations. So you can select the colors that you want, either using the name or the code. For example, you can create from YLGN scheme. So these are scheme, a naming scheme for the colors. Rather than using the actual names for those colors, you can use this scheme of naming, and then we assign it to pretty colors. So once you save it, you can call it in the subsequent visualizations that you might want to create. So if I execute that, so we have a color scheme or the palette called pretty colors. Remember that. The next visualization that we're going to look at is what we call the count plot. For the count plot is almost the same as bar plot, except for this one, we only counting the number in each category. For example, we can go ahead and create a visualization for the count plot using the count plot function from Seaborn. And in this case, you only specify what you want in your x-axis, and Seaborn will count the number in each category. So you specify what you want in your x-axis, the categorical variable you want, and we specify our data set. And for the palette, we choose the pretty colors that we specified above here. So if I execute this, I get male and female. Well, these colors don't look so good. So perhaps we can use the default theme that we have. And it's very important that because you are making many visualizations, it's always important to save the color theme that you want. So what you can do, you can actually save a color theme that you might want to use for all your visualizations. For example, you can say the current palette, you assign it default theme bright. So I execute that, and now I can create my count plot. And instead of using the pretty colors, we use the current palette. So if I execute this, I now get, well, a better looking count plot whereby we have two bars, male and female, and we see that it's showing the count on the y-axis. And that's, as the name suggests, it's called a count plot. So we expect it to count a certain number of occurrences for each category in a categorical variable called sex. Well, sometimes you might not like the style that you have. For example, here, as you can see, we have a dark grid kind of style. You might decide to have a different kind of styles for your visualizations. And here you can set it to be white, white grid, dark, or dark grid, like what we have now currently. So if I decide, for example, to have it as a white, you can use that and comment this out. If I execute this, you see I have a white background behind these bars. We can play with this. You can say this is actually a dark style. If we execute that, we see just a dark background. And sometimes you can have even the white grid, or you just want to have white background, but with some horizontal lines. So I execute this, I get that, which I think this looks better because it kind of gives someone a feel of what the count is. Like here, I see it's 150 and it's just above 150. So we can say probably 160. Yeah, something like that. For male, and for female, it's about probably around 80 something. So that's how you can do a count plot. The next set of visualization you're going to look at is the box plots and violin plots. Box plot and violin plots show the distribution of quantitative variables by category by plotting the median, the lower and upper quartiles, Q1 and Q3, the interquartile range, IQR, whisker, and outliers if they do exist. We'll begin with box plots. Create a box plot visualization. We use box plot function from Seaborn. We specify X to take values from the day column, Y to take the values from the total bill column. Our data is tips, and the palette we are going to use here is HLS, and we take 4 colors. So if I execute this is what I get. So basically on the x-axis we get day, and on the y-axis we have total bill, and we have 4 colors that have been used. And we see for each day we have some set of outliers, which was a bit low for Monday and Tuesday as compared to Saturday and Sunday. And we see that the median, which is the line at the center, presenting the median for Thursday, was a bit higher than Friday, but it was highest on Sunday. In some cases, you might want to have the box plots being horizontal rather than the vertical. So here we introduce another argument in the function box plot, which is the orient equal h. By default, it's always vertical, but If you want to have a different orientation, then you have to introduce this part where you say orient equal h. If you execute this, we now get our box plots being horizontal. We see that on the y-axis, we have day, and on the x-axis, we now have total bill. What if we wanted to introduce another categorical variable such that we have for each category in the third variable that we're introducing to be represented by a separate box plot. Here, we do the same thing, but we just set the style to be white. Here, we do the same thing. We use the box plot function. We specify the x-axis variable and the variable that goes to y-axis, which is the total bill. And now this is what makes a difference. We introduce a third variable where the value for total bill will be classified into two. We know that the smoker has only two categories, which is yes or no, and the rest remains the same. So after executing this, here we see that we have for each day, the total bill or the box plots have been generated to be two, each one separate, representing either whether there was a smoker in the party or not. So for smoker is red and no is green. And that's basically how you're able to create box plot visualization. The next visualization you're going to look at is violin plots. Plot these violin plots is simply the same way you're doing for box plot, but with the function violin plot. And something else that you're supposed to note is that all the plots that you create will take whatever grid type you had specified earlier. So when I execute this, I get these images that look like violins, and on the y-axis we have total bill, and on the x-axis we have days. They kind of look nice. I love the colors, but you can change the color to match whatever you want. But in this case, we use set2. Probably you might see that the grid is not good. You see, we have a white grid. So if you want to change the grid, we do the same thing. We set the style to a different kind of style. We can say dark grid. So if I execute this, we get now a dark grid. So it helps the visualization to look nicer, but they kind of look too dark. So probably we can change the colors, and we can change the color palettes, and also change the grid or the style that we want there. And probably we can actually even introduce that variable at the same time. So first we set the style. After setting the style to white grid, meaning that it's gonna be a white background with some horizontal lines, and we introduce that variable where we want the total bills for each day be categorized into two, and we change the palette to be muted. Muted is one of the default theme that comes with Seaborn. So if I execute this, we see that now we have two different categories for each day. For each day, we have male and female. Male is represented by blue, and I believe this is orange. Is it orange or brown? Whichever color that is. But just know that blue represents male. So, but what if we don't want to have separate violin plots for male and female? What if we just want to have one violin plot, but the violin plot is divided into at the center vertically wise, and one side represents male and the other one represents female. So in that case, we introduce another argument, and this argument is called the split equal to. It means that rather than having two separate violin plots for male and female, we can split one violin plot into two, and we change our color to colorblind. We execute this is what you get. We see that one side has the color blue representing male, and the other side represents female for the 4 days that we have. And We can also use a map function to plot whichever chart we want or visualization. In this case, the first thing we do, we can actually do a distribution of total bill amounts by time, sex, and smoker status. And to do that, we can actually use these lines of code to achieve that. So first, you'll set the style to text. The palette is set to, and the font scale is 1.1. And then we set the facet grid such that we have our data is tips. Then we have all is time, the time variable. Then we have size to be 5 and aspect to be 0.75. Then we can use the map function to come up with the visualization that we want. So here, the map function will take the chart type we want, and then the second argument is sex, meaning that it's we have variable sex, total bill, and smoker, and then the palette. We pass a dictionary with no take B and yes take Y. These are the colors that smoker will be split into, or will be the colors that will be used to represent yes or no. So, and then we set inner to be none, meaning that we won't have this a bar with a dot at the center. And then the line width, there will be a line in between. Maybe I can just execute this and I'll show you what it means. So we have a line at the center. One side represents lunch, time equal lunch, and on the right side we have time equal dinner. So meaning that there's a split. There's a split, and we set the width to be 0.75, and the spine you say left equal true. And then now we can set where we want your legend to be. Legend is just the smoker is yes, no. That is the legend. You specify where you want it to be. And in this case, you're saying for the legend for smoker should be on the upper left corner. You can change this to maybe upper right. You can actually play with this. So you see that it's upper right on one side. So basically, but I like it left aligned. So you can say upper left. So this looks a bit better. So you see, this is comparing the distribution when, depending on the time of the day. And on the x-axis, we have sex. And on the y-axis, we have the total bill. And for each violin plot, it's showing one side for smokers and the other side for non-smokers. And then we are comparing the time of the day. So basically, we have a pair of violin plots for each time of the day. Then the next kind of visualization we are going to look at is what we call a strip plot. And basically, a strip plot plots qualitative, categorical variable, and a quantitative variable. And this should not be confused with scatter plot, as a scatter plot plots two quantitative variables. And to do that, we can first set the style and the font. So we say that the font scale is 1.35, and we set the style to be white grid. And then we can use a strip plot that has on the x-axis we have day, and on the y-axis we have total bill. Our data as usual is tips, and the palette we use has 1. So if I execute this, I'll have a strip plot. Each strip are showing different days from Thursday to Sunday. Then, but in some instances, you might find like there are some overlapping points such that you won't actually see all the points. So for you to have a clear picture of what we have, we can introduce noise to each point so that we have separate points. We use something we call jitter. We set it as true in the strip plot function. So you see, we set this as true and everything else remains the same. So when I execute this, if you can see here, right about here, we had these 2 points which seem to almost overlapping, and we can actually separate them by introducing a little bit of noise by saying jitter equal true. Now, suppose you wanted to color code by a categorical variable. Suppose we say we want to color code by, so here what we do, you can use hue. I know by now you are familiar with what hue means. This is just the third variable that you want to color code the strip plots or the points. If I execute this, we see now we've introduced different colors for the two categories of sex or gender. So here we see we have total bills on the y-axis, day on the x-axis, and the strip is in two separate colors. Suppose now you didn't want to have the legend, and legend, this is the legend. If you didn't want to have the legend, you can simply introduce, after plotting the strip plot, we can say we can use legend underscore dot remove function to remove the legend. And we can actually do this, execute this. We see now we don't have the legend that was on the top left corner. And if you had some overlapping values or overlapping total bills, it's always important to introduce the argument jitter equal to true, just to have a clear separate points for anything that was overlapping. So we can do that, but it's always important to have the legend because you need to tell anyone viewing your chart or visualization that the color code means something. So I'm gonna execute this, and this is what we have. It's the same, almost the same chart, but some noise has been introduced, and you can see all the points in the strip plots clearly. Now, suppose you wanted to combine two or more plots into one. For example, you might want to have a strip plot and a violin plot. So how would you do that? In this case, all you need to do is just plot a violin plot and a strip plot in the same cell. Remember, you're using Jupyter Notebook, so that's exactly what you do. Just combine both in one cell. Now, when you execute this, we see we get a strip plot and violin plot for the days that are in our data set, Thursday, Friday, Saturday. And then on the x-axis, we have tip. In Seaborn, there's a very important function called factor plot. A factor plot will enable you to pass the type of visualization you want to plot alongside all the other arguments, and this is how you can use it. It's called a factor plot. You can have it as a header, and to use it, we can first set the style, set the font scale, and choose your colors that you want and save them as a variable. And then you can pass this the x-axis, the variable, the x-axis inside the factor plot. We can pass the total bill as the y-axis, and our data is tips. And then here is the most important. We say kind. We want a strip, and our palette is my color. We execute this, so I get this. X-axis we have sex, and on the total y-axis we have total, and we have two different colors. This color is for a code for green, and this is code for yellow. We can actually play with this. We can say this one to be, maybe let's say bar. Let's see what happens. So if you change this the kind to bar, probably you can even decide you want a violin. Let's see what happens. You get a violin. So here is where you just change the kind. You can plot as many, you can plot different kind of charts that you want or visualizations. But in our case, we had strip. So executing that, go back to our strip. Thank you for watching. Please do remember to subscribe and let me know if you have any questions in the comment section. Welcome back. In this video tutorial, we are going to look at data visualization using Matplotlib and a little bit of Seaborn. To begin, we first import Seaborn as SNS and Matplotlib pyplot as PLT, and we also need to import NumPy as NP. And to make sure that our visualizations are on this Jupyter Notebook, we use this magic command, %matplotlib inline. This will ensure that all our visualizations are on Jupyter Notebook. Next, it is important to note that sometimes some libraries might be out of date, so you need to update them. So sometimes when you try to run any command, you'll get some sort of warnings. So in this case, we need to import warning, and we can filter out the warnings by using function called filter warnings from warnings library, and we can pass ignore as an argument. For this tutorial, we are going to use a data set that is already preloaded in Seaborn library. We are going to load it using the load dataset function from Seaborn, and we pass the name of that dataset called tips. And we can go ahead and take a look at the dataset using the head function from head function. This is from base Python. So this one will only show you the first 5 rows and the columns. We see that for this dataset, we have total bill in dollars and the tip of the amount, tip given, the gender of the person paying the bill, whether there was a smoker or not in the party, the time of the day, and also the size of that party. We can check the dimension of our data set using the shape keyword. And here we see that we have 244 rows and 7 columns. So we're gonna get right into the visualization that we're going to look at. The first visualization we are going to look at is the scatter plot. And using the scatter plot, we are going to examine the relationship between the total bill and tip amount. Here, we are going to use scatter function from pyplot, from Matplotlib. And here we pass what you want to have in the x-axis, which is the total bill, and tip should be on the y-axis, and the edge colors, we specify them to be K. So we can execute that. We see the points. But then looking at the chart, it doesn't look appealing. We have no idea what is x-axis and what is on the y-axis. So in this case, we need to define the x labels and y label using PLT, x label and y label. You can do this, do it in the same cell. So we see that we now have the x and y axis, but we still need to have the title. So we use the title function from pyplot, and we give it a title called total bill versus tip. And we need to show the plot. So executing this, we see now we have a scatter plot showing the points, and you see that looking at it, the relationship between tips and total bill seems to be a linear relationship. As the total bill increases, also the tip amount increases. But looking at this scatter plot, we don't get as much information as we would like. So we need to customize this a little bit. And to customize a scatter plot, we can add some colors and markers to tweak it a little bit. So here, to add colors, we can specify the colors you want in a dictionary. Hereby you see that we have male will be blue and female would be red. And we can also specify the markers that we want. And once you specify the colors and the markers, we see that for the non-smokers, we have something like a circle, and an arrow represents the smokers. So here, we go through the points that we created and we change them in a bit. So using the scatter, where we are getting the group for the total bill and group for tip, and we specify there's another group, sex, and we use the map function to pass the colors and we specify that our markers is for the smokers, and we say that the label are for the smokers, and we specify the edge colors to be K. And here we are looping through the different groups of the smokers and assigning the markers and also the colors. So here you also define what X labels would be. Also, you need to specify what the Y label will be. In this case, we have it to be tip. We also need to specify the title for our chart. And also, we need to specify that we want legend, show the legends, and make sure that the title of the legend is smoker, and we can go ahead and show the plot. So if I execute this, we see we have a different kind of scatter plot showing different levels of smokers and different shapes. So here we have an arrow or a triangle shape and a circle shape showing different colors. We see that for red, it represents male. No, scrap that. Male is blue and female is red. And a circle represents non-smokers, and the triangle represents the smokers. And you can still see the linear relationship that is also evident as the total bill increases and the tip will always increase. The next kind of visualization we are going to look at is the histogram. And for histogram, you can use it to analyze the distribution of total bills and tips. So here, we are going to have to define two histograms. The first histogram is for the total bill, whereby you use the hist function from pyplot. We pass what you want in the x-axis, how many bins you want, how many bins do you want to split the total bill, and you also need to specify alpha, and the label would be total bill. After doing that, we need also to specify the histogram for the tip. We do the same thing. We use the hist function from pyplot, and we specify that we need the tip column in our tip data set, the same number of bins, 20, alpha is 0.5, and the label is tip. And we also need to specify our x-axis label and y-axis label, and as well as the title, the same way we've been doing, using x label, y label, and title functions. And also we need to display the legend, and lastly we show the plot. We execute this, we see that both histograms have been displayed in the same chart area, but looking at it, it doesn't show the comparison well. So it's always nice to split this into two and have one on the right and the other one on the left. So we are going to have two charts. So to achieve that, we can use something we call subplot from pyplot from Matplotlib to actually display histogram for total bills and tips on a separate windows. So here we need to use the subplot. The subplot function, once you specify the number of rows, the number of columns you want, so you need the two charts to be on the same row in that figure. Basically, we're going to have another one here. Split them into two side by side. So you need one row. How many columns do you want? You need to have two columns. And the figure size is 12 by 4. I can actually show, just don't assign it. If I execute this, I see what this means. The subplot will create two chart areas on the one side. We call them like, this is one row because they are horizontally aligned. And we also have two columns, and the figure size each is 12 by 4. So we can actually unpack the subplot into figure, into different charts, AX1 and AX2. This one is AX1 and the second one is AX2. The next thing we need to do is now on different charts, X chart, we specify the histogram for total bills and we specify the labels. So here on chart 1, we plot a histogram that is taking the column total bill from that dataset tip, 20 bins, and alpha is 0.5. And here we specify what the axis labels are and the title. If I execute this, I see that on the left axis, I have a histogram for total bill. So the only thing that we need to do is just copy the same thing down here. We change the axis to be 2 and this to be tip. So and then we change this to be 2, axis 2, and this should be tip amount. So at the end of the day, we have that. So we specify the color that we want on the tip histogram. So if I execute this, I get the two charts. But then you can realize that we have these parameters here showing what we have. Do we really want that? No. So we need to use something we call the tight layout, which is actually looks better. If you can see the difference, it's not looking so good. But once we use the tight layout, we execute, it looks a bit tight and it fits that page. But we also need to display or to show the plots. It's always a good idea to show plot at the end of that code generating the visualizations. So basically we have our charts there. On the left side we have the total bill, and on the right side we have the tip amounts, and it's orange in color. Here you can change the color to whatever you want. Maybe you can say this is red, so you have a red one. And if you want the first histogram to be a different color, you can simply pass that color argument there and just pass it there and maybe call it green. Let's see. Once you pass that, you have different colors of those histograms. So this kind of give you a better way of doing the comparison, and you can see the distribution. So the next kind of chart we are going to look at is the box plot. And basically, box plot is used to compare distribution of numerical variables across different categorical variable levels. So in this case, we are going to do a comparison of the distributions of total bills and tips across different days. So in this case, we are going to use a Seaborn library to plot the box plots. And so in this case, we plot the box plot whereby the x-axis is day and the y-axis is total bill. Our data set is tips, and we specify our title to be total bill distribution by day. That's for one plot. And then we go ahead and do the same for the tip. So in this case, it's just the same thing, but we pass different columns. And we can go ahead and execute this. Here, we see that we have now two charts, which are horizontal, vertically aligned. One for box plot showing the total distribution by day, and another one for tip distribution by day. And that's how you can do box plots. The next one we are going to do is the bar plot. And for this bar plot, we can use it to compare average total bill and tip amounts between smokers and non-smokers. So how do we do that? Here, we simply say we group by first. We group by smokers. So we create a variable called group by smokers. We pass our data frame called tips, and then we group by using the group by function. We group by smokers. So what happens is that the data set is grouped by smokers, and then we pass this, we select these two columns, total bill and tip, in that group data, and then we get the mean, because for this bar plot, it's gonna use the mean, the grouped by smokers for those two columns aggregated by mean. So here, after doing all that, we now use the plot function, and we pass the kind of chart that we want, and we are doing that for whatever we created up here for grouped by smokers. If I execute this, I get a chart. Yes, no smokers. That doesn't look too good. So we need to specify what our y-axis is and what the titles are. So we execute. So we see we have now a title and y-axis. We also need to change some few things. You see that the x-axis has yes and no. We need to format that to be either smokers or non-smokers. So in this case, we need to add this plt x ticks to format. We say we want the ticks to be 0 and 1, and the labels is smokers, non-smokers. Actually, we know this is smokers, so we need to interchange this. We need to interchange that because we know that this is yes is for smokers and no is non-smokers. So we pass those as the labels. And as you can see, this doesn't look so good having them as vertically orientation. So in this case, we need to specify the rotation. 0 means horizontal and 1 means vertical. So we need to change that and rename yes to be smokers and not to be non-smoker. And finally, we need to show the plot. So executing this, we now get a better looking bar plot showing average total bill and tip amount by smokers. On the y-axis, we have amount in dollars, and then on the x-axis, we have smokers, and for each of those two levels, it's showing bars for total bills and tips. So we see that the smokers seems to be paying bills, huge bills, as compared to non-smokers. But for the tip paid or the tip given seems to be fairly or relatively equal. But you can do some other tests to see if these tips are the same. You can do something like t-test, but that's not within the scope of this. So, and that's how we do the bar plots by different categories. But looking at this, sometimes comparing two levels side by side is not so good, it's not so appealing. So you might want to do what we call stacked bar plot. So we are going to use stacked bar plot to compare the number of bills by each sex across different days. And to do that, because we have sex and day. So we need to group our data set as group by day and sex column. So here we need to create a variable called grouped by day and sex, and then we group by day and sex. Just pass those two columns as a list, and you can go ahead and execute just to have a feel of how the data look like. So this doesn't show you anything. It just say is pandas.co group by generic blah blah blah, all that. And now from that we can get the sizes. So basically it's like you're counting for each of those levels. So we see that we have day, sex, and then we have the count. So from there, we need this to look like a data frame. And to do that, we use a function called unstack. So once I unstack and print this again, I see now we have something look like a data frame with columns and rows. It's a named with some named columns and named rows. So now we need to plot our stacked data frame. Here we use the stack plot function as we've done before. We specify that the kind is bar, and then if I execute this is what I get. I get the bars side by side. So how do I ensure that I get the stacked? To ensure that I get stacked bar plots, I specify stacked equal true. If I execute this now, I get these stacked bar plots. But this doesn't look too good because we don't have axis specified and we don't have a title. So in that case, we need to specify what our y-axis is and what our title is. And finally, we need to show bar plot, or we need to show our plot or our chart. So executing this, I get the bill paid by sex across different days as our title. And on the y-axis, we have number of bills, and we have a legend labels for sex. We have male and female. And on the x-axis, we have day. Remember, I told you you can use the ticks. You can use the ticks to change all these values, but you can play around with that. But in case you need to know the code, let me know in the comment section. And I realize that some people are watching my videos without subscribing, so please do remember to subscribe. That would be super helpful. Like the video and leave a comment. So looking at this chart, probably there's more that we can do with it. You might want to change some patterns and some other things that to look a bit appealing. So in this case, we can customize this stacked bar chart, and to customize it, we need to import from Matplotlib, we need to import colors and tickers. This will allow you to have different colors and also specify some patterns that you would want the bar charts, bar plots to display. And we can do the same thing that we did, group by day and sex. We first group by day, sex, and then we get the size for each. And then on the resulting data, we unstack to form a data frame with named rows and columns. And then here we need to specify some patterns that you would want. And you also need to specify some color lists. So here we have two colors that you would want to use in your charts. And you need to go over to plot the charts. And for each bar, you need to loop over and do some things. So in this case, you need to use a subplot from pyplot to kind of get the chart area. We assign the figure, or you basically unpack the subplots into two, the figure and the axis. In this case, we're going to have only one axis, but if you wanted more than one axis, you need to specify some parameters, like the way we did for the histogram. You can go back and check how to make those changes. Then the next thing you need to do is, using a for loop, you need to plot each bar and assign different parameters. Here, we need to enumerate, and we need to use a zip function using the columns for the group by sex. For those columns, zip, and then you pass the pattern. Now these two patterns. This is for basically for the first column and the second column. Here, we are going to have I, and we have sex and pattern. Remember, we need to specify the column that we want to use from that group by function. Group by day and sex, we need sex, and the pattern should be for sex. Remember? So these patterns, if looking at this, we need to apply the pattern to these bar charts, and because we already grouped by male and female, or group by sex, we need those for sex. So after using the for loop, now we can loop over those bars and do that. So we need first to get the index. You pass the column that you want, and then you see bottom group by sex iloc. Now this is just selecting which column you want to get the sum for. So we first select this part. Basically, we are selecting all. It's like you're selecting all the rows and all the column until I. So it's like you're selecting one bar at a time. And we get the sum for the columns. And we apply the color from the color list. Remember, we have two colors, one at a time. And we say that hatch equal pattern. And our pattern is from this list. You see, we have patterns, so we are looping over one at a time. Remember, we have two. So we assign that pattern. You say hatch is equals to pattern. And then the label is sex. So we need the legend in a way. Then after doing that, we need to specify the X and Y axis labels as well as the title. And to do that, we use that X label, set X labels and set Y label functions and set title. And we can go ahead and say that we want our labels to be our legend to have a title sex. And we can go ahead and show the resulting chart. We can execute this and you see we have now these patterns. The patterns, remember these lines, we specified them here. On the top one, we have those patterns. You can actually tweak it a little bit. You can have different patterns for those stacked charts. You can specify different ones like that. And if I execute, I now see that we have different patterns on top and bottom. You can have whatever. You can have circles. Yeah, whichever pattern you want. You can have X, so you have those crosses. So you can actually play around with this. Your choice, whatever you want, you can get. So basically, that's just to show you how you can customize those stacked bar plots. The next thing we are going to look at is how to create pie charts. So for pie charts, in our case, we can use them to show the proportions of the number of bills paid by each sex. So the first thing you need is the count. And to get the count, we first select our column is sex, and using the function value counts, we get the counts for either male and female. But for the pie charts, we need to have percentages rather than the counts. So here we specify that we need the sex count as the source of data that's going to use to create the pie chart. The label is whatever the index for that was, which is sex count. Basically, in this case, it's going to be male and female. And then we specify that we need auto percent and we pass some formattings. In this case, we say that we only need the percentages to have one decimal place. And that's how we can do the formatting. So we can execute this. So we see we have our pie chart, but there's lots of things that's being printed here. So, and we don't have a title. So here you need to include a title, bills paid by sex. So, but then you still need to show the title, else this doesn't look so good. It's showing you all the elements of the pie chart that has been created and including the parameters. But we need to show the plot if you want it to be printed, to be shown in a better looking way. So you only need to show the plot, not the other specifications for that chart or the pie chart. So here we see that we have now been able to create a pie chart showing bills paid by sex. And we see that for males are the biggest, have the biggest proportions of the number of times the bills are paid. So basically men pays more in this context. Probably in some other context, maybe females pay more, which is likely to create a debate anyway. So that's how you can do a pie chart. Then these are not the only charts that you can create. We can actually explore some other different plots. For example, we can explore a chart called KDE plot, which is kernel density estimation chart. So in this case is from Seaborn. So using Seaborn, we can use the function called KDE plot, and we pass our data that we want to use. And then on the x-axis, we specify that we want the total bill And then on the y-axis, we want tip amount, and then we want to partition them by sex, or to show different categories of sex, or color code them with sex. And then we are going to use CMap equal this name, Viridis. I can't read the name well, but just use it the way it is. And after that, we do our usual things. We need to specify the X labels, Y labels, and the title, and eventually show the plot. So executing this, we get this kind of kernel density estimation of the total bill versus tip. We have our legend for sex, male and female, showing that the blue line is for male and the orange is for female. And we see that the center of the kernel density shows where the points are densely located. It's more denser around the center of that kernel density estimation chart, or those lines. So you see that it's around maybe 2.1 and around 13 for the total bill. But anyway, that's how you can create the kernel density estimation chart. The next chart we can have a look at, it's called Hexbin plot, which can be used to visualize the density of the data points for the total bills versus the tip amount given. So here we use a Hexbin function from pyplot. We pass the column that you want on the x-axis and the column that you want on the y-axis. You specify the grid size to be 20, and then we use the CMap Viridis, whichever the pronunciation of that word is. And then after that, we need to do our usual thing, specify the x-axis and y-axis labels using pyplot, and also we need to specify the title. So I'll go ahead and execute that. So we see this Hexbin plot of total bill, and we have on the x-axis tip amount and bill, total bill on the x-axis, but we don't know the legend, we don't know the scale or the key. We need to know what these colors mean. So here we need to use something we call color bar to show what those colors mean. Execute that. I see that the different colors, and it shows that the blue, the darker it is on the lower side, shows that the tips are not concentrated, but as you go up the color bar, the points are densely populated in around this area. The greener it is, or whatever this color is on that spectrum, the denser it is. And then we need to set the set the labels for the legend of that color bar. So that's the chart, but we still need to show the chart. It's always good to do that. So we see our chart, a Hexbin plot showing the total bill versus tip, or the density of those points, using this color bar, showing the higher you go, the density of those points goes up or increases or forever. And that's basically it for this tutorial. If you have any questions, you can post them on the comment section, and please do remember to subscribe, like, and share my videos. That will be super helpful for me, and it shows that you appreciate my work. Thank you. See you in the next video.